8 in the morning. So good morning in Vietnam. Good early morning in elsewhere, United States and the UK and India and Malaysia. But good afternoon in Australia. My name is Quang Ha. I'm supposed to introduce you with Professor Chiu Đức Trình.
Yeah,
He is the Vice Rector of VNU University of Engineering and Technology. Please welcome the Professor to give us an opening speech of the workshop on energy, infrastructure, and environment research 2022 in Hanoi. Yes, Professor Jin.
yeah.
I'm
Okay,
going
so
to.
yeah, thank you
Recording in
very much.
progress.
Okay, I got it. Yeah, thank you very much. And good morning in Hanoi and Asia, and good afternoon in Australia, ladies and gentlemen. First of all, on behalf of the VNU University of Engineering and Technology, I would like to welcome all of you to the third workshop on energy, infrastructure, and environment research. Ladies and gentlemen, with the rapid growth of population and increased life expectancy, urbanization has emerged as a new chance of living. Along with global warming, urbanization is on a hand the cause of many serious impacts, including energy sources, infrastructure, deterioration, and environmental problem and associated with health risks. On the other hand, opportunity also rise from major scientific and technological advance, economic change, and ecological protection measures. Okay, the evolution of smart city enabled by digital technology is set to be one of global development for the future with enormous potential for addressing sustainable needs of civilization and population health. The transition of advanced in digital technology into real world, actionable and personalized service to benefit the general community has become a central focus of many research endeavors in as well as outside Vietnam. For this reason, study to implement the digital intelligence in urban development are being focused for priority areas such as the energy generation from the renewable source, building the management and resilience enhancement of infrastructure, water management, air quality monitoring, and environment health. Ladies and gentlemen, on behalf of VNU University of Engineering and Technology, I would like to thank uh, committee's member and workshop attendees for the rich contribution today. On this 2022 New Year occasion, I wish you the best wishes for the successful year and stay safe during COVID-19 pandemic. And again, thank you very much. And I just ask you will find this workshop informative, inspiring, and motivating. So thank you very much.
Thank you very much, Professor Jin. Thank you.
Yeah, thank you. Yeah.
We hope that all well and all ready. So I think now I will, if you don't mind, I will take my role to suppose to kick off with my kind of just short presentation to explain what the series of this workshops is about and what we can work together just today and hopefully for many time to come. Now I'm going to share my screen. Hopefully you see my screen. Yeah.
Yes. Yeah. Yeah.
Okay. So, hello everyone. Welcome to this workshop EIER 2022. The host is, as you know, Hanoi University of Engineering and Technology at VNU, Hanoi. Forget about the online, and first of all, I have to apologize for kind of some issue or technical problem or matters with the access to the website. And, well, anyway, but we are here. Okay, so let's move on. Yeah. So this workshop series is just a couple of academic staff and friends in Sydney sit down together during a coffee time. Professor Tung is here. We think about doing something modestly, but something that has some significant idea to as a thoughtful approach to address the key problem in Vietnam and in the region regarding energy infrastructure and environment. So we are here just to research. So what we can to raise awareness of the community and to sustain high quality research in the area. Then on the way, we also try to foster collaboration, provide early research career, research, and even middle career researchers with opportunities to interact with each other, to interact with senior scholars around, and to further research engagement, to work with responsible stakeholders towards some feasible solutions to the burning issues of energy, infrastructure, and environment in Vietnam and the region. But this look like too ambitious. We then go into state clear that most of all we like to address to the youth, to the young people, to the researchers who are ready to take a PhD candidature or to enter a postdoc or to enter the research career. Basically, the first is in Ho Chi Minh City. Yeah, you can see that whenever we see that Bến Thành market cities of Saigon. Okay, and that dated back to, I think, 2 years ago. We are there, a small group, yeah. But then we set up goals rather large towards some feasible solutions. Too ambitious. We did not realize that, but we really thank that at that time the Professor Tien, National Key Lab for Digital Control Engineering and System Engineering, and also the Dr. Vin, Faculty of Geology and Petroleum Engineering, GeoPet at Ho Chi Minh City University of Technology. We are small at that time. We were small, just 37 delegates, 5 countries, single track, all together as informal as we can. But the thing is that we recruited 2 excellent PhD students who are now at UTS, and I hope that we will kind of start with good recruitment of PhD students and of postdoc maybe. Okay. We then address the environment, energy, infrastructure.
Em vừa gửi cái link mới mà phải link ấy vào được rồi.
Hello. May I ask you to mute your mic? Yeah.
Okay. Good rồi. Vâng.
We talk about the big issue regarding environment, energy, infrastructure. Debate, discussion. What we can do turn it out to be very small, very modest. And at that time, the hot topic in 2020 is about smart cities. everyone is so was at that time so keen in terms of smartness. Wow, intelligent, smart city, smart technologies everywhere. It's like a hot. But then during the debate, interesting discussion, and we realized that one attribute to smart cities is sustainability. We can't see a smart city like Ho Chi Minh City, but that own just a couple of showers and own in the flood. So by all means, sustainability. How can we sustain our human life, taking a lot of injection of renewable energy sources and cut off the carbon, the emissions there. Okay. We then come into last year where I think Professor Kun, who is the host of this, Professor Kun is director of the newly established Institute for Circular Economy Development in Ho Chi Minh City, associated with VNU in Ho Chi Minh City. At that time, you know that it was affected by the COVID. We had only one choice, that to run the workshop online. And the snapshot is wherever the Tuyên from here and also Professor Zach Dev from the United States can be there. They are great artists, kind of musicians, guitarists, percussionists, but have a great enthusiasm with the environment and with the research that we are doing. Okay. Then the host, as I said, ICE, Institute for Circular Economy Development at VNU, Ho Chi Minh City. We had, I think, over 80 delegates. I'm not sure this number, maybe more. I expect it is more. But then we recruited three very good PhD students also. And we have three teams at that time because it was crowded. Professor Kuang is very clever. He ran the workshop into 3 tracks. Team 1 on energy, team 2 on ecosystem service, and team 3 about the circular economy, which is one of the research activities that is very hot this day, also to address the sustainability of human being. Yeah. Okay. Well, I insert this figure because at that time, I think in October 2020, this flood in the central coast of Vietnam, and also during this workshop, Pahang, Malaysia, my colleagues, Russia, also could not log in because of the flood. So it looked like the nature is not in terms of kind of favor the workshop where we addressed these key problems of sustainability with climate change, with flood, with air pollution, with water, with energy shortage, etc. And more or less, if you trace back, at that time, the whole world affected by the COVID-19. The death toll at that time, I think that is the net 2 years ago, the 13th of January, nearly 2 million, I think. Okay. And just send a message as to we need to be resilient. We need to be resilient. We aim at sustainability, but how could we get lost about in the pandemic? Okay, so by all means, kind of the need to be resilient in order to survive, in order to sustain. And that gives us to this time the theme of 2020's workshop, Sustainable for Resilience and Resilience for Sustainability. During the workshop, I may prompt that we have a very good, thoughtful keynote addressing these two attributes of modern life, namely sustainability and resilience. This is the picture. It is thanks Dr. Hiệp, who all agree with me that this is a good emblem for this workshop. Tradition of our ancestor of the Vietnam is there, Hoàng Thăng, kind of royal monument as a shining emblem of the Vietnam civilization, and now just rediscovered by the by archaeologists. But in preparation for this slide, I look again at the coronavirus pandemic, and unfortunately, the death toll nowadays is going to over 5.5 million due to this deadly coronavirus with all the variants. Well, looks like the Greek alphabets have no more capacity to see to convey on the variants. But on the way, we also have vaccination. We have a booster. I already did, and now we are rather strong. We are rather robust. We are rather resilient against this coronavirus, so that we are here happily joined together to have this workshop. I have a talk a lot. I think I appreciate the keynote speakers with all the special guests, especially two musicians, one from Sydney, one from Massachusetts. I hope that science is the music of the intellect, but music is the science of the heart. And we approach these key issues of resilience and sustainability, with the heartfelt of a scientist of whatever human being. Now, what we will work today is that the language is English, and we are here basically coming from all kind of background. So I would ask speakers, I would ask presenters to be generic and to uphold the timing. Multidisciplinary. Given that we have some pre-recorded and PDFs, and our workshop is informal in a sense. Not archive, not have any citations standard whatsoever. It's just here to motivate to be together and to feel that we are here working together toward something that we believe that it is a good, inspiring. And for that, all the copyright and responsibility rests with authors, with speakers and presenter. And I like to thank last words at the Vietnam National University Hanoi, University of Engineering and Technology Hanoi, the Advanced Institute of Engineering and Technology AVITECH, all the keynote speaker, renowned scientists. Well, thank you so much for accepting our invitation. And the two musicians, guitarists and percussionists, and all the plenary presenters and all the attendants around the world who join this at the moment or will access to online resources later on. My special thanks go into Professor Trung, Director of AVITECH, Dr. Ha, Dr. Hip, and their team, and thank you very much. Okay. Now probably, yeah, I stop share and I go back to my, I think I am nearly on time. So, yeah. So I invited the first, keynote speaker, renowned Professor Dr. Professor Nguyễn Đình Đức, VNU University of Engineering and Technology, and his co-worker Dr. Phan Tiến Thành, to give the first and opening invited lecture on biomass-based photothermal composite material for sustainable desalination solutions. Yeah, I think you can share your screen, and yes, feel free to go. Welcome, please welcome Professor Nguyễn Đình Đức.
Okay, thank you very much, Professor Chu Đức Chinh, Professor Quang Ha, and today I am very pleased to meet you on my colleagues from all over the world attend to the workshop today. Thank you very much to organizing committee for give us opportunity to present today. And same year, my research group is some research about composite material, and today I would like to present Dr. Nguyễn Tiến Thành. Dr. Nguyễn Tiến Thành is a Finnish PhD in Japan, as now is working with me in my research group, and Dr. Thành will be present today. Please, Dr. Thành. Thành báo cáo đi.
Can you hear me?
Thành báo cáo đi Thành ơi.
Giới thiệu. Thầy nghe thấy gì không ạ?
Yes, we can hear you.
Yeah, clearly.
Can you hear me? Can you hear me?
Yeah.
Thank you. I'm sorry. I would like to share my slide today. Yes. Thank you, Professor Chairman and Professor Đức, for introduction. I want to say thank for committee members to give me the chance to present today. First of all, I would like to talk about my brief introduction. I obtained the bachelor, master, and PhD degree in Tokyo Institute of Technology in Japan, and I received my PhD degree in 2014. After that, I came back to Vietnam and started teaching and researching in Tokyo and Vietnam Japan University until now. My research topics include studying optical property in the metallic nanostructure, multilayer nanostructure, and bio-inspired material and their application. I also study about light absorber based on nanostructure and plasmonic metamaterial bright body and photothermal material for solar steam generation system. Today, I would like to talk about the topic solar steam generation with title biomass-based photothermal material composites. Biomass-based photothermal composite material for sustainable desalination solution. In this slide, I will show you the situation of water scarcity in the world. Fresh water is vital resource for the healthy development of human being. Is become precious rapidly. Water scarcity, which driven by the growing population, rising pollution, and civilization, is one of the most pressing global issues. This picture shows the projected country level country level weather stats in 2014. As we can see, most of coastal countries will face water shortage. According to the UN World Weather Development Report, 3.7 billion people are currently affected by water scarcity. And in this slide, I would like to show you the situation in Vietnam. Vietnam is currently facing a serious shortage of fresh water due to drought and salinization in the Mekong River Delta. The salinization is complicated in some area. Salinized intrusion is as far as 100 kilometers from the coast. Leading to the scarcity of fresh water, and about 100,000 households lack of fresh water in this area, and 40% of fruit trees plantation area is affected by salinization. From the situation of the work in Vietnam, the scarcity of fresh water is one of bigger threats to the sustained growth of the world economy. And this slide, I would like to show you the technology for producing fresh water from seawater. To cope with this situation, many technology for producing fresh water from seawater have been developed and applied, such as distillation and ion exchange, membrane filtration methods. In 2018, more than 20,000 water desalination plants has been constructed all over the world. However, their methods have limitations such as high cost, high consumption of material due to the seawater and so accumulation, and is not stable for the underdeveloped countries such as Vietnam. To meet the pressing need for fresh water at minimum and energy cost, the desalination methods use solar energy. Has been proposed, and its application in water desalination has been widely investigated in recent years. This is situation of basic research and advanced R&D and application about the desalination methods use renewable energy in use solar energy. We can see there are many methods to use renewable energy for seawater desalination. For example, we use wind and geothermal energy to seawater desalination. We focus on the solar steel methods. This is a solar steam generation system due to the desalinate seawater to fresh water. Because the desalination methods based on solar steam generation, so many merits such as renewable energy consumption, zero CO2 emission, and simple structure and operation, and the price is very cheap. This is solar steam generation. And as this slide, I would like to show you. I would like to introduce about the solar steam generation system. About the structure, the solar steam generation device for desalination have three main components. Including the light. This is the light absorber. And in this component, the absorber absorb light, sunlight, and convert it into the heat energy. This is structure. This is roles in this is water supply system, and this is clean water collector. Yes, and about operating principle. The solar steam generation operates based on evaporation theory. liquid water tend to evaporate into the ambient until the vapor pressure in air is equal to the saturation pressure of water at the given temperature. Because the saturation pressure increases with temperature when the water temperature at the evaporation interface evaporation interface when the water temperature at the evaporation interface is increased by solar heating, a significant higher saturation pressure will occur. And in SSD system, water is evaporated to air water interface, and by the thermal energy which is transformed from the sunlight by light absorber. Yes, and the SSD system shows many advantages such as renewable and energy consumption and zero CO2 emission, and the system can produce from 6 to 10 milliliter per water per square material per day. Yes, and we can use SSD system in desalination of seawater, photothermal steam, and light-driven thermoelectric system, and photo heat catalyst. And about the key essential for the SSD system, we have three factors, including photothermal effects in absorber and water supply and steam escape in substrates, and thermal management in absorber and substrates. In SSD system, photothermal component play key role in absorbing and converting solar energy to thermal energy. Then water supply system transport water to use the heat generation while during the process thermal management is great important for suppress the heat loss and ensure thermal energy to be maximally used for water evaporation at the interface rather than heating the water at the bottom. Therefore, the photothermal material is most important. The most important in SSD system. Most publication about SSD system have focused on fabrication the photothermal material. However, challenge to the wide application of the SSD system still remain due to complicated fabrication and high cost, low structural stability, and unaccepted side effect of the material to the environment. About the type of photothermal material, there are many six types of material about metallic nanostructure, semiconductor, and carbon-based material. This is biomass based photothermal material. In your research group, we focus on fabrication of the metallic nanostructure and carbon-based material based photothermal material. And to apply the SSD technology in practice, we need to fabricate the photothermal material with excellent properties such as high sunlight absorption and fast water transportation, low thermal conductivity, and excellent structural stability. In this slide, I would like show the result in my research group. We have been studying on photothermal material since 2 years ago. Then we also published some paper in the high impact factor journal. For example, about photothermal material based on metallic nanostructure. We have published one paper in scientific reports about absorber material based on copper nanostructure. And then we also published other paper in advanced sustainable system about SSG system based on coating CO2 film into natural nanostructure. In this slide, I would like to show you the photothermal material based on biomass material. In the paper exhibit the method to fabricate the photothermal material based on biomass material, and the SSG system using the material so high water evaporation rate and evaporation efficiency, and so advantage such as excellent structural duration, so surface self-cleaning property, and simple fabrication methods with low cost. And because that we will report that.
Sorry, Dr. Tan, can you come up to the conclusion?
On biomass material in the next slide. This is properties of biomass material. About the component of biomass material, cellulose and hemicellulose and lignins as the main component of the biomass material. Then the material presents some advantages of structure property which suitable to photothermal material, such as low thermal conductivity and hydrophilicity and self-cleaning property. About the morphology of the biomass material, almost biomass material shows the porous structure. This line SEM image and round surface and micro side capillary chain. We can see there are many capillary chain in this biomaterial. Yes, and
maybe you could
pictures and this picture display four key factors for the SSG system, which were explained in the previous slide. We can see the photothermal material based on biomass material as able to meet all up required, such as to enhance light absorption, through multi-layer light trapping and scattering within the porous microstructure. This SAM picture. And about the heat management, the photothermal material based on biomass limits heat loss due to low thermal conductivity and eye passing through micro side chain as isolator. From their property, we can see the biomass material have high potential for fabrication of photothermal. In this slide, I would like
to come up to conclusion, Dr. Tan.
Coconuts.
Yeah.
I would like to about coconuts. We can see coconuts is quite common fruits in tropical countries such as Indonesia, India, Philippines, and Vietnam. These coconut fruits, which include coconut husk and shell. We use coconut shell to fabricate photothermal material. Coconut shells consist of two components such as cocoa pits and coconut fiber. This is SEM image of coconut fiber.
Nói ngắn thôi Thành ơi. Nói ngắn thôi. Nói ngắn đi.
And the material shows very significant advantages such as low thermal conductivity, excellent structural stability, and eco-friendly material. We use this material to fabricate photothermal material. This is concept of SSC system based on coconut husk for the desalination. We have four steps to fabricate photothermal and apply in seawater desalination. And in this slide, I would like to show you the process to fabricate photothermal material based on coconut husk. This is photothermal. Based on coconut husk material. This fabrication method is simple. It's simple fabrication process and affordable price, and all the material is material as eco-friendly material. This is SEM picture of coconut, natural coconut husk and photothermal material based on coconut husk. We can see porous structure and coconut fiber. And we in the photothermal material we can see nano micro scale complex between hydroxyl group of TA and FFA and FE in surface of coconut hook structure. Yes, this is coconut fiber in the photothermal material based on coconut husk. This is formation of complex between the TA and FA in coconut husk surface. We can see. Sorry, this is.
Excuse me to interrupt. Because the program is quite tight, so could you please jump to the conclusion of your talk, and the slides you just send us, we will upload to the workshop website. Thank you.
Okay, thank you. I'm sorry. Yes, and I confirm the super hydrophilicity and high speed water transportation in my photothermal material. In this material, I have identified thermal conductivity of the material. The material shows low thermal conductivity with about 0.18 watt. And in this slide, I would like to show the sunlight absorber ability. The absorbance of the CFP material is about 95% in the Wayland range of the 300 for 2000 nanometer. And this is solar steam generation in the lab scale. And this slide I would like to show the mass change in the SSC system based on CFP material. We can see it's 1.8 kilogram of water includes by 1 hour. And this slide the structural stability of material. This material shows excellent structural stability. And this slide, in this slide, I demonstrated seawater desalination in outdoor condition. This system can produce 3, 4, 5 liter per day of the fresh water, which meets the requirement of the WHO standards for drinking water. This is system in the real condition. And conclusion, we fabrication a photothermal material based on coconut hooks and with many advantages. The system can produce from 3, 4, 5 liters per day of the fresh water, which meets the required WHO standard for drinking water and could meet the daily fresh water need for people, family, and the fabrication process is simple and affordable and eco-friendly material, and the SSD system based on the photothermal material so high potential for water waste treatment and water desalination application. And this is comparison of the other research in with my research. Thank you for the listening.
Thank you very much, first Professor Duc and Dr. Tan. Very impressive work. However, we are over time. So
sorry, I'm sorry.
Yes. To move on to the next speaker. May I invite, can you quick your slide? And I invite the next keynote speaker, Professor Michael Neknevisky, from University of Tasmania. He is an expert in the power system and renewable energy. His topic today is high renewable energy penetration and power system security, new challenges and opportunity. Yes, I'm really sorry that we don't have a time to introduce on the biography of the renowned scientist. Just, you excuse me. Just may I invite Michael?
Thank you very much, Professor Ha, and thank you all organizers for inviting me for this presentation. This is a very interesting conference, and I really enjoy first presentation. But my area of expertise is power systems and current trend which we experience in power systems. It's high renewable energy penetration. High renewable energy penetration creates some challenges, and I will try to underline the most important challenge here and potential how we can address this challenge. So first of all, I will introduce what power system security is, concept of operating reserve, inertial and primary frequency response, briefly underline the impact of renewable energy generation, and introduce a risk-based security assessment. So let's start with the word security. Security in the context of power system implies its security against a complete collapse or blackout when all customers lose power. A security operation involves practices aimed to keep power system operating normally when contingencies occur. In other words, we operate our power system in such a way that any contingency in power system, single contingency usually, will not create a blackout. An increase in penetration on intermittent generation introduces additional uncertainties in power systems. As I mentioned, power system designed and operated to withstand contingencies, but those contingencies selected on basis of their probabilities. In practice, those contingencies usually defined as a loss of any single major component in power system. We cannot stop contingencies from happening. For example, we cannot stop short circuit happening because of lightning. We cannot stop failure of power system equipment. Also, power system equipment is very reliable and resilient, but still failures happen. What we can try to predict when when how system can operate when such contingencies occurs. In other words, we need to model and analyze potential contingencies in power systems. To ensure the required level of security, a power system must have sufficient reserves. What does it mean? It means when power system loses the largest generator, it will have sufficient reserves, sufficient generating capacity to put in and ensure balance between generation and demand, and no fluctuation of frequency will occur. Those reserves are needed to balance short-term variations in supply and demand, mitigate the effects of load forecasting errors, handle a peak demand, and manage fluctuations in renewable energy. But most of all, reserves are needed to withstand contingencies. Power systems equipment is subject to random failures. As I mentioned, we cannot prevent those failures. When large generation or heavily loaded transmission line is suddenly taken out of service, our system must continue to operate successfully. This additional capacity, which provides power system ability to operate successfully, is called operating reserves. This is a typical contingency event. At the point of A, some event happens and power system lost a significant generation capacity. As you can see, we experience a frequent drop in frequency, sudden drop in frequency, but then frequency slowly restored until it reaches back to 60 Hz. It's event recorded in a US power system. Couple of words about inertial response, because inertial response plays very important role when we talk about renewable energy. At the very instance of generation loss, synchronous generators that are still connected to the grid release kinetic energy stored in their rotating masses. Turbines, shaft, and rotors are very heavy and provide sufficient inertial response. And this injection of energy into the system provides us ability to resist a frequency decline. This type of response is called inertial response. Large, fast rotating generators have a larger inertial response than smaller machines. The system inertia or cumulative inertial response of all rotating machines depends on initial slope of the frequency decline. Increasing penetration of renewable energy creates uncertainties in power systems. However, the impact of a variable generation on system security is usually exaggerated. In reality, we can feel when renewables actually impact on power system only when wind and solar penetration reaches levels above 20–30%. The main challenge, unfortunately, facing power system now is a displacement of conventional synchronous generators by non-synchronous generation. Kinetic energy storage in rotating masses of synchronous generators provides a system rotational inertia. However, wind power generators are decoupled from grid by electronic converters. And electronic converters practically ensure that wind power generators cannot provide any inertial response to the system. The system becomes more vulnerable to contingencies. Even contingencies that previously were considered safe can now lead to frequency violations and system instability. This is an example of aggregated rotational inertia in a German power system. If you pay attention to this graph, you will see that aggregated inertia varies all the time. But the problem is, in some points, it drops so much that contingency event, which is quite safe at this point, will become a problem when inertia reaches this point. In other words, a frequency will be decreased to such a way that under-frequency shading may take place. In other words, some customers will lose their power supply. Couple of words about inertia constant, because it is important to understand how inertia is calculated in power system. So inertia constant is expressed in seconds. It indicates duration that the generator can supply its rated power to the system using only kinetic energy. In other words, when you stop providing steam to the turbine, your generator will continue to provide energy to the system for a number of seconds. For example, inertia constant of 6 seconds means the generator can supply its rated power to the system for 6 seconds using only energy stored in its rotating masses. So as you can see, it's quite significant energy which can be provided to the system when contingency event occurs. Here I provided very simple case study which demonstrate that displacement of conventional generators by wind energy will result in very significant change in inertia. So as you can see here, total system inertia constant before it was replaced, before conventional generators replaced by wind was 9 seconds, now it's 7 seconds. And as a result, you can see that frequency drop is significantly lower. It means that at this point, under frequency load shading may take place. I have to underline a very important point here, that system still have sufficient reserves, but because a system becomes lighter, it responds much faster, and frequency drops during contingency event much faster. What we can do about it? Obviously, power system engineers can install additional devices, for example, battery storage. But battery storage is very expensive. Power system engineers can install additional devices, synchronous condensers. In other words, very large motors which will provide additional inertia to the system. But such motors have to be powered. In other words, you have to produce energy to power such motors, and they practically do not produce anything. So what we propose a so-called risk-based security assessment, which reconsiders practices in power system. So traditionally, security assessment is performed based on deterministic criteria. It means power system is investigated and line by line, generator by generators are taken out of service one at a time, and potential impact is investigated. This approach has satisfied the need for power industry for decades. However, a deterministic approach to security may not be adequate in modern power system with market-driven dispatch and high penetration of renewable energy. Deterministic security criteria defined a set of credible contingencies. However, deterministic contingency analysis does take probabilities contingency into account. A selection of so-called credible contingencies implies that those contingencies are more likely to occur in reality. So we decided to redefine security. Security can be defined as the risk in the system's ability to withstand random contingencies without interruption to customer services. The higher the risk, the lower security. Also, the risk cannot be eliminated completely. We can reduce this risk. Risk-based security analysis is concerned with voltage violations, overloads, and frequency response adequacy. Frequency response adequacy is a relatively new term, so I defined it here. So it is defined as capability of frequency response resources to prevent frequency from dropping below a certain limit. We need to assess primary frequency response because of the risk of under-frequency load shedding, particularly in the systems with low inertia. It means with high renewable energy penetration. In risk-based security assessment, we do not use a predefined list of contingencies, but generate contingencies at random. And we based this generation on probabilities. Then we assess contingencies of those consequences of those contingencies and determine whether loads are disconnected following different events such as voltage violations, overloads, and significant imbalance between load and generation. This allows us to measure the impact of random contingencies in terms of loads not served. And as soon as we have this definition, we can use this simple equation and calculate the risk, or rather risk index, which, as you can see, is based on probability of contingency operating states, probability of contingencies occurring in the state, and so on. So this new approach provides us opportunity to increase power supply, reliability of power supply, and at the same time to provide a quite reliable indicator of security of power system. In conclusion, the main challenge facing power system with high penetration of renewables is the displacement of conventional synchronous generation by non-synchronous generation. The deterministic approach to security may not be adequate in modern power systems with market-driven dispatch and high generation of renewable energy and distributed generation. In risk-based security assessment, we generate contingencies at random based on their probabilities. Thank you for your attention. I think I managed even less than 20 minutes.
Thank you very much, Professor Negnevisky. Thank you very much, Michael. Your presentation, 23 minutes. Sorry. Yeah, -3. What it means is 17 minutes. But because we have our time by the first speaker, so yeah, thank you very much. Thank you. I think given that we can just have passed on the overtiming issue, so probably if the audience have a special questions, maybe we can follow up and later step, or we can have a discussion forum this afternoon. Shall we move on? So I apologize, Michael. We probably move on to the next speaker. Yeah, we have, I think here, Professor Koshi Bagis from IIT Madras. Yeah, Koshi, are you there? Hello?
Yes, Kwang.
Yeah.
Good morning.
So good morning. So thanks a lot for taking the invitation. I know that you are very busy as dean of that very hectic time and very busy schedule in IIT Madras. But thank you very much for making it for this workshop.
No, the timing worked out perfectly. So this works very well. Pleasure to be here. Let me share my screen and just confirm that you can see it.
Yes.
Yes.
Okay, so Koshi's title today is Low Carbon Construction Through Innovation in Materials and Management.
Yeah, thank you. Thank you for inviting me to speak at this conference. I've been here for the last two speakers and I've seen the presentations were excellent. Very detailed presentations from the earlier speakers. My talk is going to be a bit broader. And this is something which our group at IIT Madras is working on. So I'm a faculty at the Indian Institute of Technology Madras with the Civil Engineering Department. And my group within Civil Engineering is called Building Technology and Construction Management. So we work in two areas. One is in materials and in management. And and that's in construction and project management. And as you can see, the title of my talk kind of merges what both of our groups do together. That is both a material and management group. Going forward, we have seen that moving away from at least all of the activities that we do definitely has a dimension into what we are leading towards, which is sustainability, conservation, and low carbon. So I'm focusing my talk on kind of more a very broad level of what we are doing. I've noticed the earlier talks were very detailed research studies. We do have detailed studies and numericals on some of the topics which we are covered, but my presentation will be broad. This will be the outline. I will talk a little bit about demolition waste and circular economy, go into the framework of our solution and the approach which we are taking. And I'll be happy to answer questions on this as I know at the end. I think many of us are aware of the growing solid waste problem. And if we have seen our cities, I know that my city here the landfill has been growing and also moving. As the city grows, we take landfill space and then the landfill keeps moving. And in today's economy with discarding packaging and not much of reuse, we can see there is a lot more increase. So the projected values are really high, really scary as to the amount of solid waste we're generating. And the waste generated for construction is contributing significantly to it. So you can see here, in this figure that construction contributes 20 to 25% of this waste. And we have not really thought much about construction waste earlier. Okay, one, the volumes were probably not that high. Two, we didn't think it was cheaper to just reconstruct or to use new material to mine it and bring it and construct. So today, with the increasing amount of renovation that's required, increasing amount of buildings that are being brought down and new buildings taking its place, or infrastructure that's coming up, it is really critical that we look at this as an issue. Now, when we look at construction waste, we not only look, so I think people have become aware, research groups have become aware that there is a significant amount of carbon emissions in building operations, and there are several groups working on, how do we make buildings more sustainable, and from LEED ratings to several other kinds of ratings have come up to try to make our buildings more sustainable. And we look at from the building construct materials point of view, there's significant embodied energy and carbon in this. Now, if we come to the graphic here, you can see that out of all this, most of it is discarded. Very little is recycled or reused. Okay, so there are definitely challenges to doing this. Okay, it's much, I mean, so the question gets raised, if I use energy to recycle or to reuse material, the waste material, does it actually consume more carbon? You know, so these kind of questions we are, have been raised all over the world. There are research communities that are trying to quantify it. And definitely we find that energy use, especially with concrete construction or, where we want to kind of recycle, there is a tremendous amount of energy use that goes into the recycling process. So it is not a straight equation that we would take the discarded material and recycle it and, get it ready to use. So that is one side. Two is when we recycle it, in addition to the energy use, there is a change in material properties. Okay, so now how do we redevelop or characterize those materials and make it ready for construction? So these are some of the questions we are looking to answer. So when we look at it from volume perspective, again, we can see that there is huge amount of specific volumes of construction and demolition waste that are coming up. Now, on the table here, you can see the demand for different kinds of materials and the reserves available. So it looks like, yes, there are reserves, but is it our right to actually start digging into these reserves? I think if you look at something like limestone, which is an essential constituent for cement, there are several efforts to be able to, bring in cement, which is less, limestone intensive, or use lower grade types of limestone to be able to make better quality cement. So there are a lot of efforts going in this direction. And if I take a look at sand, for example, in India today, sand mining is banned because many of our rivers are facing a problem due to people mining sand from these rivers. Okay, and so we get into this. It has become kind of a requirement today that you use manufactured sand, which is based on other materials rather than river sand. Although most of our codal provisions and everything is characterized based on good river sand. So these changes are starting to happen. And how do we as scientists enable to make sure that these changes occur rapidly and most efficiently? So we go into this issue. We are aware of the hours of waste management, whether we want to, ideally refuse or, not use the kind of high carbon material or reduce it, reuse, repurpose, or recycle. So if we look at what from a circular economy perspective, okay, so this graphic basically shows where we start with mining and manufacturing. Our earlier process would be just to go through, make the building materials, construction service, do the operations, and then go, and whatever demolition occurs, go, at the end of life into landfill. But we realize that we cannot do this, so we have to start these loops today. Now, in some ways, especially in the Indian context, I think our economy has gone from a very high, I'm sure in some other parts of the world, compared to many of the developed or the advanced countries. We have always been having a culture of recycling materials on recycling, but not necessarily towards construction. It's mostly reuse for other purposes or repurpose material for other uses. But even there today, we find the volumes are becoming so high that the supply chains or the processes and the industries that were doing this recycling are overloaded. And sometimes the technologies are new to be able to reuse or redistribute, that the technology to recycle or reuse does not exist, so it gets discarded. So even in economies like ours, where there was always certain amount of recycling that has been done, and there has been economic and social benefit to people who do it, with today's challenges, we find that with the volumes, it's becoming a problem, and the technology is also a problem. And this is, of course, so when we look about plastic or some things like that, we can definitely find ways to recycle. It's also a larger social problem. But when we look at construction waste, it's not so easy. You need systems in place. You need larger players. you need policies in place. So when we look at the Indian scenario and look at construction, we see that there is absolutely no, I mean, like I said, we have inherently we have a recycling mindset in the economy or in the people or in society. But when we look at some things in the volume of construction waste, this kind of approach does not simply work because the volumes are too high, the technology required is high, and we need a larger approach. We need a larger scale approach to this. So when we look at all of the demolition, so India, last 70 odd years, there's been a lot of construction, but then a lot of things are also coming, a lot of structures and facilities are coming to end of life. So they are being renewed, they're being demolished. But at the same time, while facilities are being demolished, we have a large amount of construction infrastructure that's going on in the country. So this is just an example of the metro rail project. So you can see these are all the cities that have had a metro rail constructed in the last 10 years. And there are even more cities that are going for metro rail construction. So these are large infrastructure projects that are being implemented. The only country that exceeds this volume is China. Otherwise, globally, India is just undergoing a huge infrastructure boom with all kinds of new construction going on. But are we going to mine our materials from virgin soil to be able to do this, or can we use recycling? So in addition to metro, I'm showing you some general figures of all the other kinds of infrastructure which is now being done. So you can see metro rail at 2.16 billion is small compared to highways and roads, or in housing and urban development, or in water projects, or in the rural development projects. So there's a large infrastructure boom, and what is the opportunity to be able to be sustainable in developing this infrastructure? The infrastructure is going to be developed, but what is the opportunity to be sustainable? We have firms like Godrej Construction, which are leaders in sustainability and looking at sustainable, at the country from a sustainable perspective. They have set up plans to take concrete, recycle it, but more into non-structural kind of elements such as this, or even more into kind of not critical elements. Okay, so these kind of practices exist, and I mean, again, they are slowly becoming, they are not, the economic viability is not at its peak, but it's gradually rising. Now, at IIT, what we have looked at, or our group is looking at, is not just demolition waste, not just C&D waste, but a lot of other wastes that come into the construction phase, or potential material that come that is available to construction with chemical properties that are beneficial. Now, we look at it from the materials perspective, we look at it from the process perspective. The construction group looks at it from the process perspective, and it's not just for non-critical construction elements, but also for regular construction elements that we are looking at. Now, if we look at this whole material and process waste to make sustainable construction, we take our approach kind of in a holistic manner, which is kind of shown here, because any change, while we can do the basic scientific research in our laboratory, unless there's policy, management, and technology aligned with it, does not make it to the field, does not become a practice. So our group is looking not only at the basic scientific research, but also at the technology that needs to be developed to translate this research into implementable form, the management and organization required to take that implementation to practice, and as well as from the top, the policies required to make the practice mandated or make the practice acceptable or required. A lot of times the policy is what drives what is there. Let me try to illustrate this. Okay, I will try to illustrate. This is a key slide. I will try to illustrate this with some examples from this, but this is actually a large-scale project which is spanning over the next 5 years. But if I take, for example, raw materials, okay, from a policy point of view, we need to understand what raw materials are available and what can be mined and what can't, and what is the policy level issues on that. At the same time, if we need, from the technology development, we need to be able to understand how different kinds of material affect our material properties, How do we develop, how do we kind of process the material so we get the best properties for the use we are planning? We need to develop codal standards and provisions from a policy and management perspective so that the use of this is standardized and made widespread. So people do not have to do research every time or detailed testing every time. Similarly, when we look at the materials and supply chain perspective, again, we can have plants in. So we had this technology called, in fact, this was originally from Australia, glass fiber reinforced composites, which were made from gypsum actually. And we had a lot of fertilizer plants that could supply the gypsum, but these plants were not located, in areas where the supply chain was feasible, that we could serve all parts of the country. So then which parts can be served? If we try to initiate the projects in areas which are not well served, it is definitely going to be a problem. So when we look at, again, design, the same issues apply in design, starting from design codes to, how do we bring design into the training? How do we train designers to do this, to be able to develop tools and technologies to enable the design, and to be able to do the basic scientific research to enable design with recycled elements, recycled material elements. The same issue with construction. So here is an image of a 3D printed house, but this 3D printed house, which we built on our campus recently, required new material. It was not recycled. But can we, now that 3D printing is becoming more viable and more popular, how can we now use recycled material for 3D printing? Okay, we're looking at durability, then we're looking, so on this side of the figure, we have fairly large issues. For example, when we do CND waste collection, it's easy for us to say that the waste needs to be collected, but there are a lot of issues in just the logistics of collecting and sorting these wastes. So a lot of these are policy issues. The urban corporations or the urban bodies have to enable this to be done properly, and they have to align with state and national policies. I will touch a little bit upon the kind of test beds we are planning here. So this is another part. We need to do a lot of experiments with test beds. So if we go to the test bed, this is one of the aspects which we propose, where we actually have to do a lot of testing in our laboratories. So we are planning to make, we have a test bed which is going to look at the different elements of the scientific aspects. Okay, and I've just put in, and a lot of this needs to go into also roads, because this would make a big difference for the number of roads we are going to construct. A lot of applied research and development. Kwong, I will finish in a minute. Okay. And so ultimately, this leads to what we're calling technologies for low carbon and lean construction. The vision of our center is given there. And we are going to be a center that's looking at international collaborations, because many countries face this problem. And we are looking at reaching out to many groups to be able to enable this vision. But definitely the need for India is high. And we are the leading group. With all of these holistic approach, we hope we can tackle this problem at least in the coming years. Okay, with that, let me close. Thank you very much.
Thank you very much, Professor Bagis. Very interesting talk. And again, probably, would you mind sending over the slides, and we shall move on. Apologize me. I probably need to catch up with the timing. So thank you again, Toshi.
Thank you. Bye.
Thank you. According to our program, so the next speaker will be another keynote from renowned scientist, Professor Bijan Samali from Western Sydney University. His topic will be development of energy-efficient roof tanks. Again, also, materials, things like that. Bijan, are you there?
Yes, I'm here.
Okay, thank you very much. Thank you. So please, it's nice to see you, Bijan. Okay.
Yes. First of all, I like.
We shall string up to the timing. Yes, if you don't mind.
Yes, of course. I will stick to the time and try to catch up a couple of minutes. To back on time, I would like to thank my colleague and a good friend for many, many years, Professor Kwang Ha, for organizing this and inviting me. I'd like to also acknowledge the previous speakers, especially the last speaker was very comprehensive and well received. I learned a lot. So thank you for this opportunity. The topic we are talking to today is one of the projects that started as a PhD program, is now gaining more momentum on investigation of the development of energy efficient concrete roof tiles. And I'd like to acknowledge my colleagues, Professor Zhang Tao, Dr. Abdul Alim, whose PhD was on this topic. A quick background, some objectives, talk about thermal energy storage technologies, phase change materials, development of form stable PCM, development of form stable PCM into integrated tiles, and also incorporation of FSPCM into concrete hollow blocks, some test results, some quick summary, and potential future work. The way we, I guess, have to look at this issue is, I guess, somehow, some extent covered by my previous colleagues and speakers. Globally, we spend about 36% of total by buildings, and they are responsible for about 1/3 of related CO2 emissions. So it's a huge, huge amount, and we need to see if we can actually reduce this by having more energy efficient building construction technologies. To the right the screen, we can see HVAC systems consume about 51% for heating and cooling, lighting about 25%, which are the main players, and the rest are also listed, which are not as much. Let's see if we can progress this. Okay, got stuck for a second, my apologies. In Australia, buildings are responsible for about 23%, 13% for residential and 10% for commercial of countries' total greenhouse emissions. And this presents a significant opportunity to lowering emissions by reducing the building energy consumption, which is the main feature of this talk. Objectives of this study include development of energy efficient roof tiles. Here, I think I would like to distinguish it between solar panels. We are not talking about solar panels. Solar panels have been effective, but they're coming a little bit at the end of their life. They have never been aesthetically acceptable. They are a bit of an art on top of the roof. Whereas you are talking about tiles that you put on the roof, and the entire roof is tiled by so-called solar tiles, which can work very well and efficiently. We can also use the same technology to building blocks, especially in Australia. Many places use hollow blocks and fill concrete inside it for exterior walls and so forth. And the idea is, why can't we use some of these technologies into building blocks for that purpose? I finished with a simulated model to show the energy savings, to just give you a feel of intended technology to achieve this purpose. And this the goal of this is basically thermal energy storage. So we want to basically, I don't know why my slides get stuck. Sorry about this. Yes, let's talk a little bit about this thermal energy storage technology. And the idea here, which is the basic idea, is to basically change from one phase to another phase and store it. I think probably most familiar and easy to understand material in terms of phase change material is simple innocent H2O, water. You can actually have ice in a solid form. You heat it up, you end up with, with water. Here, the change phase temperature is 0 degrees. There is another one at 100 degrees when it becomes vapor. But then in the bottom graph, you can see 1 kilogram of ice at 0 degree. You can have 334 kilojoules per kilogram, make it 0 degree, but liquid has changed phase. And any increase in temperature will heat up the water. So that is basically the concept of phase change material, which we are going to use here. Sorry, what did I do? Sorry, let me just go back. It seems that my screen is not moving at the speed I ask it to. Okay. Okay, the next slide I have here for you. Just see if I can go to slide mode. I might actually stay with this one because I'm afraid going back might delay this again. I think you can see. Phase change materials are favorable for this thermal energy storage. It's an excellent heat thermal storage, has excellent heat capacity, and has capacity for high storage. There are many forms of these. Some of them are more expensive than the others, but the costs are coming down. It has a particular property that it significantly reduces the size of the storage materials. It can also reduce the cost of the storage systems. And to the right, the working principle of PCM is mentioned, which is similar to what I mentioned to you earlier. So basically, you have a solid form, blue circle on the top. Temperature rises, it changes its phase into liquid. You then start to take energy off it, temperature falling, it goes back to the previous one. And we can have phase change materials at a specific temperatures, for example, 26 degrees, for example, 34 degrees. These are the temperature at which this phase change happens, and these are the temperatures of interest. For example, in summer, around 30, 34 degrees, we like to intervene and see if we can actually store some of the heat generated during the day. That's the concept here. Generally, they are not very stable, so we can actually do some mixing and matching with concrete itself, and we refer to them as form-stable PCM. They're highly porous, 80 to 90%, have low bulk density, about 128 to 320 kilogram per cubic meters, a larger specific area. They have superior thermal capacity, stability, and chemical inertness, and unique open pore size distribution. An SEM of this is shown to the right, as you can see. So basically, the idea is to include cementitious material with the PCM. And as you can see, it looks like just a powdery material. And the SEM is also shown to the right. And then you basically cast it like any other tile. And that's your final product. At this part of the program, we have 3 levels of testing. I'm presenting to you today the testing in the laboratory. The next phase, which is undergoing at the moment, is testing in the outside, in a yard, outside the lab under natural UV light. And finally, we are going to make a couple of control and another small building and put it on the roof and do some measurements and comparisons, which is closer to real life situation. Basically, you have, some test setup, which we have, in order to economize, we have put 4 of them together. Each of one, you can see the tile in figure A, figure B. Figure A is just a container, which is basically a simple container. You have the main figure is to the right, points 1, 2, and 3. There are thermocouples installed there. 1 right above the tile on the top, 2 below, just below, and 3 inside. And the heating has been generated by some UV lighting lamps inside the chamber. And that has been also connected to data logger that measures the temperatures. Quickly, some test results, since we have only 4 minutes. To the left, we have outer surface temperature. To the right, B, we have inner surface temperature and inside air temperature. And we can see that the black one, which is the reference tile, is much hotter than the red one, which is the combination of 2 form stable PCMs. We call it form stable PCM 26, which the phase changes at 26 degrees, and 35. And the red one is the combination of the 2, some hybrid form, which gives you much less temperature, as you can see from the graph. And of course, the horizontal axis is the time. According to test results, the indoor air temperature reduction is 11.5, 15, and 21.2 degrees, which is fairly significant compared to the reference tile. And the corresponding energy savings is about 25, just about 30 and 41% respectively. And for this smaller scale, which of course that cannot be generalized to the larger scale, the payback period was not even a year. In other words, the cost of the system compared to how much energy you save, you could recover your investment in almost no time. The same concept can also be used in hollow blocks. A lot of builders use hollow blocks. The idea here is to fill the blocks rather than with normal concrete with this form stable PCM. And we have done some testing, similar results, but because of the time, I did not include them in this presentation. Then we did a simulation using a software called Energy Plus. A typical residence, the plan is shown on the top, and the 3D view shown at the bottom. And the table to the right shows the amount of energy savings that is there. which amounts to about 21% savings. So by using this phase change materials, we can 20% savings in energy is not insignificant. We also know and think that if we have not exhausted the capacity and the potential of this, it can be optimized further by new materials. At this stage, our biggest enemy is the cost, which is also coming down, and exploring other materials that have similar phase change materials material properties. So to summarize and to stay with time, Kwang, up to 52% PCM can be retained in diatomite, which is one form to prevent PCM leakage. So PCM has to be stable, should not be leaking. 60% by weight was incorporated in tiles. The form stable PCM tiles significantly reduced the indoor air temperature by 11.5, 15, and 21% respectively, compared to reference tiles, and the corresponding energy savings of 25, 30.7, and 41 almost. And using form stable PCM in a real house leads to, according to the simulation, saving of 10.57 kilowatt hours per square meter per year, which is saving of about 21% on heating and cooling energy costs. As I mentioned at the beginning, there's some future work being undertaken, including work on a larger scale in an open air environment, and finally looking at these on a couple of small brick houses to measure the efficiency of the system. On that note, I would like to be on time and finish here. Thanks for the opportunity.
Thank you very much, Professor Samadi. Well, thank you very much. Yes, I have a quick question, if I can. And well, it is great to have that energy efficient times on roof in the future. But nowadays we have 3D printing. So I would say, how can the material can it be well 3D printed to be produced in reality?
Yes, that's a good question, Kwang. 3D printing is a viable technology and can be used in this. I think at the end of the day, the focus of the project is make it the commercial reality. So cost and efficiency go hand in hand. We have companies interested in this, but they are more interested in efficiency versus cost. If 3D printing happens to become cheap enough and competitive enough, certainly it's an option. Otherwise, other methods may have to be considered.
Well, thank you very much, Bijan. I think we have more room. I really apologize due to that we do not have time much for question and answers and also interaction with renowned scientists around. But I hope that we still hold the spirit and collaborate in the future. And also we have a chance to follow up in the forum. And also you have email contact again. Yeah. So thank you very much, Bijan. Thank you.
Pleasure.
Yeah. Now I would invite Professor Derek from the University of Illinois in Chicago. I think I did not see him in the dashboard, but I have his video. He already sent us well, very kind of comprehensive video, and Cybo's video, in fact, addressed directly the theme of this workshop, namely sustainability and also resilience. So since he is not here, may I take the opportunity to share screen and pop up to his video? Yeah, I'm going to run it now, see if I can do it. I will double click on here. Okay.
Hi, everyone. My name is Sybil Darable. I'm an associate.
And I will start from the beginning. Let me share screen. Let me share screen. Share screen. Okay, everyone, you see in front of you the video, right? I'm going to enlarge it and run the script by Professor Derek Blur. He is, in fact, a scientist working in the Illinois, Chicago. However, he is French, so probably I think I'm pronouncing his surname right. May I introduce Professor Sybil Derek?
Hi, everyone. My name is Sybil Darable. I'm an associate professor in the Department of Civil Materials and Environmental Engineering at the University of Illinois at Chicago. It's a pleasure to be here presenting at this workshop. I wish we could all be together in Vietnam, but we're not. We're online like we've been the past 2 years. So be it, but I'm really hoping to meet all of you in Vietnam in the next few years. What I want to do today is to talk in line with the workshop, to talk about sustainability and resilience, but I really want to frame it in the context of infrastructure. And really to bring you a bit more of the conceptual level of sustainability and resilience, especially applied at the systems level. That's what we're going to try to do. So sustainability, resilience, what do they mean? I mean, those terms are vague. I don't think we should necessarily seek to have an official definition or a great definition, but they are vague. And so what I want to do is really talk to them within the context of infrastructure, apply them again, maybe just challenge the way that we understand them. Usually sustainability, we associate that with low energy, low carbon. We'll see that we have to be careful a little bit with that notion. And resilience, a lot of times we're
đã bị mất tiếng. Đồng giáo sư Hà bật trở lên đây đang bị mất tiếng. Giáo sư Hà bật micro lên đi đang bị mất tiếng. Rồi anh Hà đang bị tắt micro, đang bị mất tiếng.
Is there any problem? Mất tiếng? Probably I mute. I apologize. I mute myself, and that's why I think I apologize. Let's rerun it, okay? I just stopped my video, but not mute. Okay.
Hi, everyone. My name is Sybil Darable. I'm an associate professor in the Department of Civil Materials and Environmental Engineering at the University of Illinois at Chicago. It's a pleasure to be here presenting at this workshop. I wish we could all be together in Vietnam, but we're not. We're online like we've been the past 2 years. So be it, but I'm really hoping to meet all of you in Vietnam in the next few years. What I want to do today is to talk in line with the workshop to talk about sustainability and resilience, but I really want to frame it within the context of infrastructure. And really to bring you a bit more of the conceptual level of sustainability and resilience, especially applied at the systems level. That's what we're going to try to do. So sustainability, resilience, what do they mean? I mean, those terms are vague. I don't think we should necessarily seek to have an official definition or a great definition, but they are vague. And so what I want to do is really talk to them within the context of infrastructure, apply them again, maybe just challenge the way that we understand them. Usually sustainability, we associate that with low energy, low carbon. We'll see that we have to be careful with that notion. And resilience, a lot of times we'll restrict ourselves to robustness or redundancy so that when a disaster or some event, disruptive event happens, that we have some alternative options so that it doesn't fail. So again, I'm gonna challenge that a little bit, apply it to the systems level within the context of urban infrastructure. And when I say urban infrastructure, I mean, what I'm gonna say now should apply to all of them. I like to describe myself as an urban engineer. I'm not focusing on one very unique infrastructure system, but I look at all of them. So I look at water systems, wastewater systems, transport systems, electricity systems, gas systems, solid waste management systems, and also even telecommunication. And I tried to look at all of them, their interdependencies, their interrelationships, and within the context of sustainability and resilience. So what does it mean for us? What we'll do is we're going to start with sustainability, then we're going to go to resilience, and then we'll have a small case study at the very end to illustrate some of the points that we're learning in sustainability and resilience. So sustainability, I like that common definition. That's the definition that's probably the most commonly accepted in the world. Some people don't like it. I actually like it a lot. It's sustainable development. It's development that meets the needs of the present without compromising the ability of future generations to meet their own needs. That's from the World Commission on Environment and Development, the Brundtland Report. That's how it's better known. That was in 1987. I like it a lot because I think it makes it sort of easy. Sustainability is essentially the ability to sustain an activity forever. If we do something and we can do it forever, then it's sustainable. If there's something that we're doing that's not working and we can't do it forever, then it's not sustainable. Another way to think about it is to give it more of an economics twist to it. And it's to how we have needs and we're trying to meet those needs. We have needs that's a consumption, so we're trying to consume something, and to meet those needs, we need to produce something to be able to supply for that demand, for that consumption. So essentially what we see is we have production and consumption, and what we want is for the production to always be larger than the consumption, always. So it's not only about production minus consumption is greater than zero. For it to be always greater than consumption, what we can do is instead of looking at the production itself, is to look at the rate of production and the rate of consumption. So one of the ways that we can turn this differential system into an equation is by having this dp over dt minus dc over dt is greater or equal to zero. So again, the rate of production, no matter what happens, the rate of production is always going to be greater than the rate of consumption. We usually don't have this equation. I don't think this equation is necessarily very helpful in practice, but just to think about again the concept of sustainability, I like it a lot and I use it quite a lot. What we can do is to even illustrate it. So here we have a figure with the x-axis, we have the time, y-axis, we have production and consumption. In the first case here, we see that production curve is going up, the consumption curve is going up as well. The production is systematically higher than consumption. And so in that case, we're just in a sustainable scenario. A good example of that for some places in the world, not everywhere, is water consumption. I live in Chicago. We have Lake Michigan next to Chicago. Lake Michigan is one of the biggest lakes in the world. We're fine with water. The population could double, could triple, we'd still have enough water. So we are in a sustainable state when it comes to water consumption, at least in Chicago. Now there are cases where we're sort of in between, where right now the production is higher than the consumption, the rate of production is lower than the rate of consumption. And so we're in a tolerable state where we're okay, we're meeting all our needs, but something is going to be different in the future. A good example of that is solid waste management. We're generating waste, we're collecting that waste, we're trying to put it in some dumps, in some landfills, and it could be okay, we have a lot of space, but at some point that rate of consumption or that rate of generation of waste is going to be so great that we're not going to have enough landfills. So that's why reusing, recycling, repurposing is something that we must all do. That's a good example again for service management of the tolerable scenario. And then we have the unsustainable scenario where the rate of production is just lower than the rate of consumption. A great example is transportation. Twice a day during rush hour, we have a certain capacity, and that capacity gets exceeded by the consumption. And that's why we're stuck in traffic. I like Vietnam because Vietnam is a little bit different because that rate of production actually, that capacity changes during the day because you have all those motorcycles that just drive on the road during the day, and in rush hour they also go on the sidewalks. So it's always fun or confusing or cumbersome to try to walk around in Hanoi or in many cities in Vietnam during the rush hour because all of a sudden the sidewalk get attacked by motorcycles. At least that's my experience when I was in Hanoi during my sabbatical. See, these are three. So again, I like to think about them: sustainable, tolerable, unsustainable. Where are we now, at least from a conceptual perspective, when it comes to infrastructure? The only one other thing I want to say is, we should be aware of low energy, low carbon solutions. Low energy does not mean necessarily more sustainable. Not necessarily. Sometimes yes, sometimes no. Because low energy might still means that we're going to consume more, and if the consumption grows, and at some point the production might still be lower than the consumption. So that's why purely just instead of just going for low energy systems or low carbon systems, I like to think a bit differently and really think more into concepts of consumption and production. Next, we can think about resilience. Here's a very common definition of resilience from the National Infrastructure Advisory Council in the US, and is the effectiveness of a resilient infrastructure or enterprise depends upon its ability to anticipate, absorb, adapt to, and or rapidly recover from a potentially disruptive event. I actually don't like that definition at all. One of the ways that it's normally illustrated is with this graph here, where we have time and the state, we have some kind of an equilibrium at some point, and then there's the disruptive event. There's a sudden drop in the state, and then depending on how fast we recover, whether it's a partial recovery, full recovery, or whether we can adapt and enhance the system, then that's how we measure resilience. I don't like this because I think it applies great. It's great at some parts, at small parts of systems. But when you think about the entire system, it's a bit more complicated than that. In the 1980s, Charles Perrow wrote a book called Normal Accidents, and it defines a system being composed of multiple subsystems that are composed of multiple units that are composed of multiple parts. And we've spent a lot of time looking at the resilience at the unit and part level. So a part could be a valve, for example, in water distribution systems, a unit could be a pump, and a subsystem could be the entire pumping station, and then the system is the whole water distribution systems. So what we're going to do with units and parts, and we're going to try to build redundancy, we're going to try to be robust, and it's working okay, but at the subsystem or especially system level, now we're running into a problem because you can't be redundant in the system. I mean, if you have a water distribution system, you're not going to have a separate parallel water distribution system in case something happens to the first one. So that mentality needs to change when we think at the system level. So redundancy is just not enough. The other thing is that what we saw the graph before really showed us that there was some kind of an equilibrium, but infrastructure systems are built over decades, centuries. So there's no equilibrium. We're not in a stationary state. Infrastructure systems are non-stationary. There's no equilibrium. So that mentality of trying to maintain a certain operation really doesn't work in the longer term. So again, that's why I don't like it. And so when we scrap that notion of being stationary, then we think more about flexible, we think more about adapting. And I think it really gives us another idea of being resilient. The other thing is that we should really change our design practice from fail-safe to safe to fail. So fail-safe means that we're just going to do everything we can so that if something happens to a system, it's not going to fail. If there's a disruption, we're going to have redundancies, et cetera, so it doesn't fail. Now we're trying to change it by saying, you know what, there are unknowns and knowns. That system could fail. There are some scenarios where, despite all the redundancy that we can build in, it could fail. And so what we want is, if it fails, we wanted that it fails in a safe manner. So again, different mentality. And the last one I want to mention is a different perspective. Again, is that we've spent a lot of time focusing on infrastructure. And what we realize now that we should really make infrastructure more flexible. So flexible is the key word, hard to operationalize, but we want us to make it flexible. And we haven't really thought about the organizations that manage that infrastructure. But now we realize that those organizations are also rigid. They have rigid structures. And so whenever there's a disruption, or if we need to adapt, even if we're 5 years or 10 years, because they're so rigid, it's not working too well. We can't come up with nice solutions so that infrastructure is more resilient, again, just because of those organizations. So there's the term, I'm borrowing terms now from Mike Chester at Arizona State University, is agile. So those organizations need to be more agile, so they adapt, so they change as the needs of the infrastructure change. So flexibility and agility in organizations. The other thing I want to mention is really also now we realize that for the longest time, I think we tried to optimize the system so it could be more resilient. So if there's something, we're optimizing everything. And now we really realize that optimization does not lead to more resilience, it leads to more vulnerability. Whenever you optimize the system, you can't include every single variable possible. So a lot of times what you're doing is you're actually building vulnerabilities, you're building bottlenecks, you're building places that are not as safe, where you don't have as many resources. And so optimizing is really more rigid versus another term that's called satisficing. Satisficing is a portmanteau term between satisfy and suffice. It was created in the 1960s or 50s from Herbert Simon, one of the fathers of complexity science. And satisficing is different. So optimization is rigid, satisficing is more flexible. Satisficing is more about meeting your criteria, your threshold. Satisficing is more even the way humans think. So for example, let's say that you want to buy a new laptop. You might want to optimize your card and your this and your that and your size and your screen so that you have everything optimized for what you do. But then you should realize that what you do actually evolves. Plus the offer that you get when you go to a computer store, you don't have the perfect computer for you. Sure, you could build your own, but again, something might change. So what you want instead is to, generally what we do instead is to think with a few criteria. I want to make sure that I have at least that much hard drive, that much, processor that has at least has that speed, etc., etc. And if we have that, we're okay. It's not perfect, but we're okay. But when we do that, because we're okay, we're actually building, we're putting flexibility in our system. And that's one of the mentalities that we're also trying to change when we think about design in infrastructure. So let's look at a case study. A great case study I like is water distribution systems. Here's the way it works in most high-income countries, at least in the US, that's how it works. We're trying to collect water, surface water, groundwater, whatever we can get, we collect that water, we treat that water, and then we distribute that treated water, that clean water, in thousands of kilometers of pipes, always at a high pressure, always at high pressure to make sure that no water leaks in the system from the ground. And that when we have leaks, because we'll always have leaks, that it leaks out. Plus, when it gets to your building, this way there's pressure, so it just goes up to the upper stories by itself, at least for a 4-story, 5-story building, so about a 30-meter head. That's usually what we go for. So this is not a sustainable or resilient system when you think about it. That high pressure that's always there just really consumes a lot of energy, and all those pipes at some point they age and they break. And so you have big breaks, you have to dispatch emergency crews, you have to change that pipe rapidly. So I really see those water distribution systems as ticking time bombs. And I was impressed and amazed when I was in Hanoi, because I thought that the water distribution system there was vastly superior than what we have in most high-income countries. So I don't think Ho Chi Minh City is exactly the same, but it is the case in many countries, middle-income countries. It's pretty incredible the way it works. So in Hanoi, what happened is that you had a water distribution system that could not provide for the entire city. So they would provide water to one district and then another one and then another one, and then every few hours or every few days. And so, but houses needed water all the time. So what they did is they a water tank in their basement. And that water tank is in the basement on purpose, so that water coming from the road is at a higher level than the basement tank. And so you always have water flowing in, even if the pressure, even if there's very little pressure in the system. So that basement tank is there, and then when the water is there, then what you do is you pump it up to the roof, to a water tank on the roof. And then when it's there, it's sitting there, it's a small tank, but it's there and just pumping water there whenever it needs to. The nice thing there is if you have a power outage for some reason, because it's at a higher elevation, you still have water all throughout your house. And then what you do is at the tap, if you want clean water, we have, the water might be in those tanks for some days. Some pathogens might have been introduced, maybe that there's a lower pressure in the system. In Hanoi, I think we're at about 10-meter pressure in the system. It can be lower really because everyone has a basement tank. So the minimum is not so much what we need for the buildings, but it's the fire safety minimum. So what we have here is more pressure into the tank. Then at the top we have the filtration system, so that the water that comes out can still be is still potable. So I think it's vastly superior. I think it's more resilient, it's more complicated, but it's more resilient because a house can be separated from the main system for several days, still be autonomous, still be fine. So I think it's much more resilient. It's also more sustainable in part because it's lower energy. We just don't need as much energy to distribute all the water. And it's also more sustainable over time because over time we need less energy, and over time we have all those separated modular buildings essentially. So it's just a fantastic model. I'm a big fan of this model. So that's all I wanted to say. Conclusion, sustainability, resilience, we still don't have a definition. I don't think we should seek a definition, but we should challenge a little bit the status quo when we think about it. So sustainability for me is really about being able to pursue an activity forever. Resilience is more than just redundancy or robustness. It's really about being flexible, both the physical infrastructure and the organization managing it. And that the future really lies of infrastructure. The future of sustainability, resilient infrastructure really lies in creative solutions, such as the one that we saw in Hanoi. So thank you very, very much for the time. I really hope that we're going to meet in person in the future. And I wish you a great rest of the workshop. Thank you very much.
Thank you. Well, stop share. Now, thank you everyone for your patience. Yeah, well, 5 minutes is due to technical problems. I apologize for that. But anyway, the 5 minutes will be to move on to the lunch break. Okay, if you don't mind. Right now we are on time. For your information, Professor Derek is now flying to another workshop, and we will send a smile face with me regarding that we are listening to him. But I hope that his talk is rather inspiring and also explaining the theme of this workshop. Now we start with the next plenary presentation. The first one is Dr. Hiệp Đức from the DPI. I probably have no time in order to just move on to pass on to Dr. Hiệp. Are you ready, Hiệp? Hello?
Yeah, do you hear me?
Yes.
Okay. Yes, welcome to my presentation. This one is about the greenhouse gases emission. We usually focus mostly on anthropogenic emission, and that causes greenhouse gas increasing and therefore global climate change. But we forgot about some natural events which is actually affect the greenhouse gas emission quite a lot as well. So today I focus on two natural events and effect on greenhouse gas emission, CO2, due to dust storm and wildfire in Southeast Australia. Okay, so one of the things is that in Australia is a dry continent, and in the central of Australia is mostly desert. So you usually have dust storm, and actually the Australian dust storm is very frequently, and wildfire as well. And these two events is actually have effect on greenhouse gases emission. And in the climate change community usually focus on anthropogenic emission, but natural event can sometimes can offset those anthropogenic emission. So today I focus on two events. One is dust storm in February 2019, and one is on the wildfire in 2019 and 2020, and it's a very huge wildfire, and you probably heard about this about 2 years ago. with Wi-Fi, in effect, the emission from Wi-Fi to the atmosphere is huge. The CO2 emission during the bushfire in 2019 and 2020 is exceeded the emission the whole of Australia for the whole year. So, but for climate change agreement, natural event is included from greenhouse accounting. So today I talk about the reason why these two events is have effect on climate change. So first, is Wi-Fi and dust storm. When it deposit, when the emission, the particle deposit, on the ocean surface, is actually stimulate, the phytoplankton growth. And the phytoplankton are micro, plants. They are, and therefore, as like most plants, they have photosynthesis, and therefore, is can absorb CO2. And two of the main phytoplankton is Dinoflagella and diatom. And diatom is especially stimulate when into high growth when you have iron. So you probably know about the geoengineering concept of iron fertilization in the ocean to absorb the CO2. So this is the phytoplankton here. These are very small animal plant. And plant, they have photosynthesis. They have chlorophyll in their cell, so they absorb the CO2. And what's interesting is that when we have a dust storm, for example, in February 2019, you can see on the left here is a satellite image from Moody's satellite, and that is the yellow is the front of the dust storm, and the dust storm is starting from Central Australia in the right hand side there. That's a desert, Central Australia. So this one is the image of the dust storm. Is affecting the whole east coast of Australia, and if you, using modeling, using particle modeling called high split, you can see this actually is traveling to New Zealand and also to Antarctica as well. So it's a huge storm. Now it's interesting. Most people focus on the natural event, but if you look at the chlorophyll, this is the satellite image of chlorophyll. Is the green, the left-hand side is the AOD, that's the aerosol optical depth from satellite. The right-hand side is the chlorophyll concentration on the ocean. You can see after the storm, you can see high concentration of chlorophyll. That's mean the presence of phytoplankton. Interestingly, from the Himawari's geosatellite from the Japan Aerospace Exploration Agency, JAXA, this is the image from detection by Himawari satellite on the phytoplankton growth. You can see, is after the storm, you can see, is a huge phytoplankton growth, across, not only New Zealand, but also the South Pacific as well. So there clearly a link between the natural event, the storm, and the phytoplankton growth. And when the phytoplankton they grow, and when they die, they sink to the ocean. So therefore, all the CO2 will encapsulate at the bottom of the sea. So the emission, there are no emission of CO2 from the dust storm, but actually the dust storm stimulates the growth, and therefore we absorb the CO2. So this dust storm is actually a benefit, into a greenhouse gas capture. Now we're talking the next one. It's a huge one as well. It's a natural event. This is the black storm of 2019 and 2020 Wi-Fi in Eastern Australia. on the left, this is satellite image, from Moody's, Aqua and Terra satellite, and you can see the smoke, from the bush fire. And this is December and this is January at the peakable Wi-Fi. You can see the smoke in the aerosol, is everywhere in southeastern Australia. Now, this is the burn area in only New South Wales. You can see New South Wales is about 5 or 6 times the size of Vietnam. So the burn area here is about nearly half of Vietnam. So you can see the scale of the bushfire there. Now, the bushfire causes tremendous particle pollution. You can see the concentration up to 1,000 microgram per meter cube at some site in North New South Wales and also in Sydney as well. So what we do is we do some simulation of the bushfire, and then we can predict where the emission from the bushfire come and deposit on ocean, and then we can correlate with the phytoplankton growth. And that is the aim of our study. And the simulation is we compare with observation and with wind speed direction and predicted particle, and they look okay, they look fine. And we can also compare, with the NCAR, simulation. This NCAR is in the US, is associated with NOAA, and they are doing the simulation every day across the globe. And this is the for particular case, is we can compare with their output and our output. The particle is look okay. This look, reasonable good. Now. This is concentration of chlorophyll, is in before the bushfire, only in Southern Ocean and Tasman Sea, between Australia and New Zealand. Before and after, you can see the increasing of chlorophyll concentration for the bushfire. If you look at the Japanese satellite, is after the bushfire and before the bushfire. You can see the first half of January 2020 when the bushfire started, and the second half, is a huge plankton growth across the whole of Pacific Ocean. And the same thing, in February, first half of February is the peak of the bushfire, and then the second half, is phenomenon, growth of phytoplankton, and they capture a lot of CO2. And then the first half of March, when there are no more bushfire, and then the second half of March, they are disappear. All the phytoplankton disappear. So that means they die and they sink into the ocean. So they capture a huge amount of CO2. And now remember when bushfire, the wildfire, they emit a lot of CO2. But that emission is CO2 is more than the whole of Australia, anthropogenic emission from Australia for the whole year. But it's captured by the phytoplankton. So actually, it's a carbon neutral. It's not carbon positive or carbon negative, but actually it's neutral. That means it doesn't affect the global emission at all. It's compared to dust storm. Dust storm is actually positive. That means there's no emission from dust storm, but it stimulates the growth of phytoplankton and then absorb CO2. So actually, the more dust storm, the better for the world. In case of CO2, greenhouse gas emission. So the conclusion is the February dust storm, 2019 dust storm, and the Mega 5, Mega 5, we're going to Black Summer, that was called in Australia. Stimulate a lot of phytoplankton growth in the Tasman Sea and Southern Ocean, as well as the Pacific Ocean. And both events promote phytoplankton growth, but the Mega 5 trigger a massive growth of growth of phytoplankton around the Southern Hemisphere. The Mega 5 were much bigger and longer and emitted a lot of carbon and nutrient, and they deposit into the water surface and then promote stronger growth of phytoplankton. So in effect, they neutralize the emission of CO2. So the phytoplankton bloom occurred from January to early March. You can see the picture from satellite, from Japanese satellite, is across the whole of South Pacific Ocean. After that, the growth disappeared, completely disappeared. Probably nearly all carbon emitted by Mega 5 was reabsorbed by the ocean. So the thing that we focus, at the climate COP, in the Paris Agreement, they focus too much on the Anthropocene one. But in fact, we look at the natural event. It's natural event, contribute into the greenhouse gas emission. And actually, in total, they probably is benefit, because they reabsorb, they cause the reabsorption of CO2 emission. That is the message I have, and the work is still going on because we haven't finished the simulation yet to correlate, with the evolution of the particle and the final growth, on the Pacific Ocean. So I will thank you for your listening, and back to you, Kwang.
Thank you, Dr. Hiệp. Although that is a kind of pre-recorded video, I hope that the organizer, Dr. Hiệp, here will have it posted on the website, so that those who are interested can have the video. And we apologize for kind of the sound through the network because it is pre-recorded, so the echo and whatsoever. But we have the session open forum at 3 p.m. so Vietnam time. So if you have any question, feel free to bring the question to the forum. Now, thanks very much, the speaker, and now it's time to move on. I would like to switch to the next speaker, Ms. Huê Vũ. Her, together with Professor Bang, submitted the work on the preliminary results of the causes of air pollution in Hanoi, Vietnam. So it is rather actual. So, Huê, you please keep short. Thanks.
Yeah, thank you, Prof. Quang Ha, for introduction. Hello, everyone. Today, I represent from my team. I would like to present the results of the cause of air pollution in Hanoi. Just short results because our project is still going on. This project is funded by the MONRE, and we are the EIER VNU, cooperate with the INS and IHEM in Hanoi to generate this work. I'll keep this one. The study area of ours is the northern key economic zone in the northern, including the Hanoi, Hải Phòng, Quảng Ninh, Hải Dương, Hưng Yên, Vĩnh Phúc, and Bắc Ninh, which is the second largest economic zone in Vietnam, beside after Ho Chi Minh City. As you may know, Hanoi City it have more than 11,000 factories with emitting the air pollution, as well as more than 300 Grab village. For transportation, it have the total is more than 7 million vehicle circulates around the city, with the total length is nearly 2 million kilometers. For the resident, the city have 8 million inhabitants. For the PM2.5 level, the high level is appear in the beginning and at the end of the years. Usually higher than the Vietnamese national standard, which is 50 microgram per cubic meter. But when we look at the WHO's guideline, the PM2.5 level in Hanoi is always higher than the guideline, which means it already affects to the people health in the Hanoi area. The objective of this research is to calculate the air emission inventory for the 6 pollutants, including SO2, CO, NOx, TSP, PM2.5, and stage 4, and to generate the emission map for the Northern Economic Zone. For the methodology, we have divided evolution into into 3 big groups: is point source, the error source, and the light source. The main methodology is combined the bottom-up and the top-down approach using the emission factor. For the data source, we use survey using the questionnaire, the traffic counting, collect data from the Bureau of Statistics, and also from the light department in the Hanoi and surrounding province. This is the MSN model we use MSN model to calculate for the transportation. As Prof. Sippy has mentioned, he's amazed by the transportation and the motorcycle in Hanoi also. And like any other cities around the world, Hanoi City transportation is also one of the main contributors to the air pollution in Hanoi. And for the transportation, we take into account the coal, the hot and evaporation emission of the vehicle from the start to the end point. For the ship, for the harbor, we use we adopt the methodology from the US EPA according to the equation. I will skip it. And the next source is the area and the point source. We use the same equation based on the activity rate as well as the emission factor and the abatement measure that apply to to control the emission. And this is the sample that we have. We have total. This is the total number of each vehicle, and this is the sample that we will collect that we have collected in this year. Total is more than 2,000 questionnaire with the motorcycle, the car driver, as well as the truck driver. And this is the picture that we have interviewed for the ferry driver that across the Red River. Next step is the industry. As I have mentioned that Hanoi have more than 11,000 factories, and we have collected information of fuel consumption via the Strategic Bureau of Hanoi, and we also go to the around 150 factories to do the field survey of the worker here. And for the surrounding cities, Hạ Dương, Hưng Yên, Bắc Ninh, and Vĩnh Phúc, we will collect the potential point source in this province in around to 20 potential factories, including the coal power plant and steel and cement, etc.
Maybe you can go to slide by slide to the end, quick.
Oh, can you see my slide is skipping?
Yeah. I mean, that's so quickly good. Yeah.
Okay. I will go to the result also. So this is the result. As you may see, the PM2.5 is contributed by the industrial sector is around 3,000 tons per year. More important, the SO2 contribute from this source is also very high. It's around 8,000 tons per year. For the area source, the household and the rice straw burning is the two main source, which is different from the Ho Chi Minh City. Ho Chi Minh City's household is the main source, but in Hanoi, rice straw burning is one of the main contributor of PM2.5 here that we have to notice. This is just preliminary of our research, and the next step we will continue to the traffic counting, and by the end of this year, we will have the full report of the emission inventory in Hanoi and in surrounding province. And beside of the emission inventory in Hanoi, I would like to introduce you to the work of our team is the healthy air that we have public on the internet of the healthy air apps. You can download and install via the mobile app using Android and iOS. And that's all of my presentation. Thank you.
Thanks so much, Quinn. In fact, congratulations to Professor Bang and the team and you yourself for a great well app on our mobile healthy air. Okay, so thank you. Yeah, we can have a question for the team and Quinn in the forum. Now we shall move on to well, colleague in Malaysia, Dr. Raja Ismail. Raja, are you there?
Yeah,
oh,
yeah. How are you?
Thank you so much. How are you?
Good.
Okay.
I'm great.
So you can share screen and be short if you don't mind.
Yeah, of course. We'll be very short.
Okay, I hope at this time you don't have a flood in Malaysia.
This year it's not very serious.
Oh, okay, good.
I hope you can see the PowerPoints.
Yes.
And not else, because I'm also opening some other applications. Okay, so okay, so first of all, thank you so much to Professor Kwang Ha for inviting me to participate in this edition of EIER. A very short introduction. Again, nice to meet all of you again. I'm actually honored to be the regular participant in this EIER. Okay, so I'm from University of Malaysia Pahang, as you can see on the top of the head of the slide. And I apologize because I'm not preparing a comprehensive slide because I thought that the pre-recorded video is everything. We'll handle everything and we will proceed with the Q&A session. But no problem. Yeah. So my current research works are related to control and modeling for renewable, or we say alternative energy system. Okay, so by the way, I think since we are coming from diverse background based on my experience participating in this EIER, I think it's worth to just share some insights on the topic, not too deep on the design and etc. Okay, maybe 3 minutes because I only have 3 slides. So this one is actually the one that I've shown in my recorded video, so maybe we can just see some photo. So hydrogen, like electricity is an energy carrier capable of delivering a massive amount of energy. So along with the introduction of especially electric vehicle, electric cars, so recent advancement in hydrogen fuel cell has the potential to so-called to revolutionize the future of transportation vehicles. And then, despite there are many types of different fuel cell, for example, solid oxide fuel cell, which is also very popular nowadays. So hydrogen is perhaps the cheaper alternative. And then, as you can see, the photo at the middle is actually the test rig at our lab, the hydrogen fuel cell. You know that U-shape with PVC pipe. That is the available at our lab. We are studying that system. Okay, and then comes the role of the power electronics converter. Okay, because in order to utilize the energy, we need to get the one that already can be consumed, because any energy comes from photovoltaic, solar, wind. They are rather you can say rough, or whatever term that you would like to say. So we need to process it for the usage of the domestic purpose. Okay, and then that's why it is very important to to study the control on the conversion from the energy source, PV or fuel cell or whatever, to the end consumer. Okay, so in this project, we implement the so-called the robust control. You know, robust refer to the ability of the controller to deal with the external disturbance or we can say uncertainty in the system. Okay, so it is known as the sliding mode control, and it has a few variants, some hybrid control as well. And then I hope you can see the graph on the slide, because the problem or the challenge with controlling the hydrogen fuel cell, or we call this PEM fuel cell, proton exchange membrane, okay, like the title, is the challenge is the gas, the pressure of the oxygen and hydrogen gas keep changing. So how to cater with this problem, and how to maintain so-called the maximum power point tracking, because we want to extract the energy from the system at maximum points. Okay, so based on the preliminary results, we managed to get a good results in which the system managed to track the power at its maximum. So I think that's all, maybe, Prof. Kwang.
Well, thank you. Thanks so much. Thanks so much. Yeah, in fact, fuel cell will be the fuel of the future. Yeah, hydrogen cell and the next fuel is belonging to hydrogen. So it's very timely. I'm very happy that you are now working on PEM fuel cell. Well, thanks. Wow. Thanks very much, Dr. Raja Ismail.
No worries.
Well, one last question, maybe updated with the research. So remember that we have a joint grant, right? Okay. So for the audience, if we have any further questions, then probably we can have bring it to the forum at 3:00 p.m. Hanoi time. Right now, thanks very much, Raja. We shall move on to the next the presentation to be delivered by Phạm Đình Nguyên in the the talk entitled "Automatic Simulation for Safety Prediction of Composite Structures Under Crack Propagation," co-authored by Vũ Thị Thúy Anh, Phạm Đình Nguyên, Trần Hiệp Định. Thanks. Yep.
Yeah, just give me 1 second. I'll share the screen, the video from my side.
Well, I take the opportunity to say that we should apologize for any technical problem and the connection. But now the timing is here. If you are ready. What's the you? I saw the button for running the video, but you forgot to press anything.
Sorry, can you see the share screen already?
Yes, share screen. No, not yet. You haven't shared. You share and then you stop.
I know, but I think there's something wrong with my Zoom. Just give me 1 second.
Oh. I saw your video button and then you forgot to press on that. In the last result, I think the video already uploaded to the website.
Yes, it is actually already on the website. So maybe we can refer to the something that has been uploaded to the website just to save the time for now.
Maybe you can run the PDF or whatever, and then or the abstract, and then just share with the audience the main point of this research work.
I'll try to share again. Just 1 second, and then hopefully it works now. Can you see the presentation?
Yes, I saw the share screen. Yes, this time you click the button. Yeah.
Today I would like to share with you the topic automatic simulation for safety prediction of composite structure under brand application. As you know, composite materials have been widely used in the industry due to their advantage of characteristics. Certain high strength lightweight materials used to avoid chemical resistance compared to conventional materials. The current challenge is studying the characteristics of composite materials improve but are not limited to optimal simulation solution, crack, and progression application potential of AR to related problems. Regarding the graph application problem, current simulation methods for composite materials are medicated down by converting the material to homogeneous. The distribution of the reinforcement component material in functionally graded is also almost non-applicable. Besides, current studies only focus on static graphs, while dynamics one and inconsiderate appropriately. Last but not least, that corresponding also resting concern due to the variety of new composite materials. These studies are carried out by us from three steps, with first one of the software is.
Sorry, the noise, the sound could not be listened well. Probably you can drag it to the end and just come to the main point if you can.
We have only one slide. Yeah, sorry. So actually, it's just a combination of collaboration between people in computer science and people in mechanical engineering. So what we're trying to do is we will generate a lot of simulations from, like a crack propagation, because normally the data collection in real life is very time consuming and also very expensive. So we hope that with this one, with the simulation we have tried on our previous study, showing the high correlation between the simulation and real life cracks. So we hope that with this kind of automatic simulation method, we can actually predict the safety level of crack propagation, and then give out some kind of on-time warning for material, especially for new kind of materials like composite reinforced by graphene. Okay, that is actually all for our presentation. If we have any question related to this, we can discuss later in the open forum. Thank you.
Well, thank you very much, Dr. Hip. Yeah, when you talk live, we hear you very well. And when pre-recorded video is running, then of course it is rather murky in a sense that like the Dr. Hip's one, but Dr. Hip's even better. Now, probably as Dr. Hip said to Hip, then probably if you have any question on the monitoring of the composite structure with crack propagation, then you will ask in the forum time. And now I think I will move on to the next presentation by Vũ Ngọc Linh, Nguyễn Văn Đông, Trần Văn Bảy, Nguyễn Hải Bình, Vũ Duy Tùng, Nguyễn Hồng Nam, characterization and potential applications of the solid residue from macadamia nutshell gasification. I think it's the topic rather very interesting. Vũ Ngọc Linh, yes.
Hello, everybody. Thank you for the opportunity to be here and present our work. My name is Vũ Ngọc Linh, and today I would like to present our project so far. It's still ongoing research project. Can you see my slides? Excuse me, can you see my slide?
Yes.
Okay, so I would like to start. Thank you. The work I bring to the workshop today, it's called the characterization and potential applications of the solid residue from macadamia nutshell gasification. So our work basically is to investigate the properties of macadamia nutshell gasified char for application determination. And by trying to establish a commercial-like gasifying conditions, and then we yield the gasified char, and we put it through FTIR analysis, nitrogen adsorption and desorption, X-ray fluorescence, and SEM-EBS analysis. So we can get the graphs of the characteristic of the char itself, and from there we can determine or we can locate a suitable application for that material. And our research so far, this is only preliminary results because we just started this project. And then, but so far we have found that the char yield from gasifying macadamia nutshell holds great potential for sustainable use as biofertilizer, which will increase largely the sustainability of the entire process itself. I would like to go into my work now. So first, a very quick description of the gasification process is a thermochemical conversion process that operates from above 700 degrees Celsius up to about 1,400 degrees Celsius with reacting agent using to be carbon dioxide or steam, or maybe a combination of both. This gasification process converts the solid biomass or solid fuel into syngas and biochar, and syngas is a very high value energy carrier which can be used as for direct energy generation or as precursor for chemicals and so on. As for biochar, is actually the solid residue, mostly unwanted from the process, is what left off after the gasification process is done. However, this is a very promising source of carbon that we can use, and also in order to the sustainability and also the development of gasification process and technology itself is depending on two factors. First is the diversification of biomass feedstock, as now the gasification process mainly use wood or wood-like or woody feedstocks, and that make a big competition with other industries. So, and also we also use a lot of solid residue as biochar. So the sustainability of this entire technology depend upon these two factors. Either we can diversify the feedstock and we can find a suitable application for the end pipe residue, which is biochar. And in Vietnam, Vietnam is an agricultural dependent economy. So in 2013, it's roughly estimated that the entire country produced 75.3 million tons of agricultural byproducts, and only 40% of those were only used. Therefore, it is a great potential for gasification feedstock in order to decentralize the energy generation, which is good for our not only energy security, but also our energy portfolio as a nation. And also, we look into the byproducts of gasification, which is the biochar. And why we choosing macadamia in a nutshell is because this is a extensively growing global cultivation activities around the world. It is estimated that from 2009 to 2019, which is 10 years, the global cultivation of macadamia has grown above 200%. And interestingly, more than 70% of weight of the crop consists of husk and shell. So therefore, the cultivation of macadamia produce a very large amount of residue. And currently in Vietnam, they are only used as feedstock, feed for chickens and other alike. And also, the macadamia nutshell holds very similar characteristic to wood, as you can see in the table, with which we pulled from an article from Mr. Bada. Okay, about the process that we use. First, we rinse and dry the macadamia nutshell, and secondly, we pyrolyze it in 600 degrees Celsius in 2 hours under the inert atmosphere of nitrogen to produce pyrolyzed char. And finally, we gasify that pyrolyzed char at 950 Celsius degree with the atmosphere, the reacting atmosphere to be consist of 20% of the carbon dioxide and 20% of steam. We chose these conditions in order to mimic a commercial-like process of the gasification. And from that gasifying process, we yield the gasified char. And we use this gasified char to put through some analysis in order to determine their characteristic, and so that it would reveal the suitable application of that. Okay, so coming to the results and discussion. First, on your left side, we have the nitrogen absorption and desorption isotherm of gasified macadamia nutshell char. And we found that the specific surface area to be quite low. It's only 73 meters square per gram. We believe this is to be because of the high temperature that we use to gasify the char that caused the collapse of the porous structure. And therefore, this sample is deemed unsuitable for use as adsorbent. On your right hand is the SAM EDS images that we took of the gasified char surface. And as you can see, there is no visible porous structure. Therefore, again, falsify the conclusion of this to be unsuitable to use as adsorbent. However, as you can see on the right side, there is the EDS image of the elemental mapping of the char surface, and you can see that the red dots are carbons and the green dots are potassiums. So on the surface of the char itself mainly consists of carbon and potassium, which is very beneficial if we would use it as biofertilizer or soil amendment. Next, this is the results from the FDIR spectra of the gasified macadamia nut shell, and we investigate the existence of functional groups on the char surface, and we found that the char surface mainly consists of carboxyl and hydroxyl groups. This is deemed to be beneficial for use as soil amendment because these functional groups tend to form salt when used as a solid soil amendment, and it would increase the soil alkalinity, and therefore very beneficial for the plants itself. Next is our XRF spectra of the gasified macadamia nut shell. These results fortify the claim of the macadamia nut shell char to be great potential to be used as biofertilizer. As you can see, the content of potassium is overwhelmingly high. It's for some sample is up to 69% of the mass of total organics in the char itself. So as the conclusion, we so far in this study, we have found that the macadamia nut shell char gasified at high temperature with carbon dioxide and steam as a reacting agents obtain a non-porous structure with insignificant surface area. However, the char itself possesses a promising potential to be used as affordable biofertilizer, and more importantly, it's potassium fertilizer, which only can be derived from a specific ores, and that some countries are very, some countries don't have such ore, so they have to import it, import a lot of potassium biofertilizer. Okay, so the future plans of our research is to investigate the characteristic of macadamia nut shell char produced from different gasifying conditions at different conversion rates, and also to we would like to bring it to the pilot scale. We already have a gasifier at pilot scale, and we like to use the macadamia nut shell as the feedstock for that pilot scale gasifier, and then yield the char that is left off at the end of the process and try to analyze its properties and in order to locate its suitable application. That is the end of my presentation.
Thank you very much, Dr. Lin. I think the presentation is so impressive. Yeah, thank you very much. I have a quick question. Is that the macadamia, there is a bundle or a lot of this kind of fruit in nuts in Vietnam?
Yes, the macadamia cultivation activity is very popular right now in Vietnam. It's growing very fast in the central highlands areas and as well as the northern mountainous areas.
Apart from biofertilizer, can it be used for kind of energy production?
Actually, our team, we are testing different chars of macadamia shell. We produce it at different conditions, and we use it as adsorbent for dye in wastewater, and also for CO2 absorption, and we yielding promising results. But we still we need to work on more samples to build up a adequate database in order to be able to spread to publish the work. Thank you.
Yeah, thanks very much, Dr. Lin. Look like it's very interesting and very promising. Thank you. Now it's time to move on to the next speaker, Dr. Kyu Chen Su from UTS. So I have the pleasure to introduce his presentation entitled Deep Learning for Surface Inspection with UAV Imaging. Since from UTS, I can put press on him to be short. Thank you. Jason, your time. Hello.
Hello. Would I like to play the radio or?
Yeah. You can do anytime, anything. Either to talk or you run the video. Make sure that's just 3 minutes or 5.
Oh, okay.
You can share screen. Hello?
Oh, it's play. Oh, can you see the video?
You're not yet.
No.
You're not yet the share screen. Yes, now.
How about right now?
Yes, yes, yes. You're in it. You're in. I think we don't have him because you mute. Yeah, but your video doesn't have a sound track.
Yeah, of course. And it has a soundtrack.
The video is already uploaded. So my suggestion, Jason, is to just run the
Hello
slide.
everyone, my name is Qichen Zhu, a nearly graduated PhD student from University of Technology Sydney.
Okay, is that okay?
My topic for the workshop today is deep learning for surface inspection with UAV imaging. Nowadays, UAV imaging is increasingly used in automated inspection for infrastructure surface defects, especially in hazardous or unreachable environments. During the COVID breakout, it's an effective way to reduce the face-to-face workload for building and construction in industry. In machine learning, the key to crack detection rests with robust and accurate algorithms for image processing. To this end, a deep learning approach is proposed using bidirectional convolutional neural networks and an intercontrast iterative thresholding algorithm for image binarization. First, a set of branch networks is used to generate a possibility map of the cracks for rough estimation. Next, a contrast-based thresholding approach is developed at the post-processing step to binarize the possibility map of the identified features for classification. The proposed technique is then applied to identify surface cracks on the surface of roads, bridges, and pavements. Various experiments on cracked images has been conducted, including those captured by our unmanned aerial vehicles inspecting a monorail bridge. As exemplified in the pictures at the bottom, our approach can effectively detect the surface over misleading marks, coverage, and the shadow. Such performance demonstrates the merits of the proposed deep learning approach for surface defect inspection. Thank you.
Thank you. That's my presentation.
Yeah. Basically, you can sum up that yeah, you use a deep learning for crack detection after processing the UAV captured images, right?
Yeah.
So if for the audience you have any question, this is a rather interesting work by Dr. Zhu. So if you have any questions that we can discuss in the forum at 3 p.m. Right now, thanks a lot, Jusen.
Thank you.
Yeah, can I move forward to welcome the next speaker, Nguyễn Nhật Tiến, Võ Trần Thị Bích Châu. Hello, are you there? Yeah. Okay. So you have 5 minutes, Tiến.
Okay.
Welcome.
Yeah. Hello, everyone. My name is Tim from Canton University. It's my pleasure to be here to make my presentation about optimal planning for sustainable hybrid energy system, producing oxygen on site and considering byproduct hydrogen for backup power in our culture. And energy demand is one of the major challenges of the shrimp industry because much of the energy is consumed by water pump and pond aerators, which run 24 hours per day to improve dissolved oxygen in ponds. Electric aerator constitutes about 80% of farm energy demand, while pumping water accounts for 50%, leaving other uses at 5%. Farms are connected to the national grid and have diesel generator for backup. The big problem is that aerator runs continuously, resulting in off-gassing dissolved oxygen, wasted energy, high operation costs, and CO2 emission. Therefore, I propose an optimal design on sustainable hybrid energy systems for shrimp aquaculture industry. The constitutions of the system are divided into bioresources, biolot, and shrimp ponds. The main biolot is the electrolyzer. In the daytime, the primary power extracted from solar panels and wind turbines is converted to AC and emitted to the aeration system. The base load is supplied by stable power, while the remaining power is used to run the electrolyzer for producing oxygen in situ. Moreover, the byproduct hydrogen through water electrolyzer is utilized for various applications, such as selling to the fertilizer factories or storing in the tank for generating backup power. The pure oxygen from the electrolyzer is compressed via a short-term oxygen tank to the microbubble system at the bottom of ponds, which generates oxygen microbubbles for shrimps. The innovative aeration system, which is aerated by pure oxygen microbubbles with high oxygen absorption efficiencies about 90%, instead of oxygen from the air 20%, requires less energy demand and releases less emission compared to the conventional aeration. The oxygen requirement during daytime in shrimp ponds is low due to oxygen supplement from photosynthesis, corresponding with a low power demand from the electrolyzer. Consequently, the electrolyzer is controlled to change its input power according to the amount of dissolved oxygen in culture ponds. When the system is well controlled, the energy demand is reduced, leading to low operation costs. In addition, the surplus electricity is sold to the national grid. At night, only wind turbine system may not produce enough energy for the power demand of the system, especially the electrolyzer, due to the high amount of oxygen demand at daylight hours when renewable resources cannot satisfy the power load demand due to the uncertainty of the resources. The deficiency in power is inevitable. In other words, when the imbalance occurs, the power backup system is employed to compensate for the mismatch of the system in islandless operation mode. And the proposed optimal design of hybrid system for a shrimp farm is carried out at Vĩnh Châu, Sóc Trăng province. The simulation results show that the increase in the system cost leads to the significant decrease in CO2 emission. Nevertheless, the cost has negative value. You can see here indicating that the robot system is able to obtain revenues from selling surplus electric power to the national grid and the dump hydrogen to local fertilizers factories. And solution 1 corresponds to the lowest value of the system cost and the highest amount of CO2 emission, while solution 2 is the intermediate solution among all solutions, with the utilization of fuel cell as backup power in solution 2, the amount of CO2 emission declines considerably in comparison with solution 1, and the conventional aeration system. Under the cost of the system of solution 2 is considerably higher than solution 1. It is still significantly lower than the conventional aeration system. Hence, farmers could sell about $28,000 per year. And thank you so much for your attention.
Thank you very much, Tim. Yeah, it is a rather impressive work from Cần Thơ. I really like it. We like the infrastructure. We like the shrimps in Cần Thơ. So shrimp farm and the use up of that for generating energy is great. Again, probably by the way, the audience, do you have any question for Dr. Tim? If not, then probably we will move on to the next speaker. And if we have questions to the presenter, we bring it to the forum at 3:00 p.m., right? Now, to keep up, we move on to the next speaker. Varun, are you ready? Hello?
Hello, sir. Yeah, I am ready. I will just share my screen.
So be short, okay? We try to be on time.
Yes, sir.
Because,
Sure.
yeah.
So, hello everyone. This is Varun Kumar Reja, and I will be talking on existing challenges in computer vision-based progress monitoring of construction projects. Project monitoring is a three-step cycle with plan, monitoring, and control. The key step here is monitoring of construction project so that we can take control and timely action. The challenging task is for controlling, we need as-built or actual status from the site. And the challenging task is how to get the as-built status. Once we get the as-built status, if it is not taken properly, the cycle gets compromised and we run into cost overruns and time overruns for the construction project. The problem motivation behind this is that planning for progress is need for many things like machines, cash flows, manpower, and delays. But conventional progress monitoring, which is pen and paper based method, is labor intensive, time consuming, ineffective, and prone to errors. Generally, the technologies used for progress monitoring include pen and paper based method, RFID based and QR based methods. But recently, vision-based techniques have been predominant, like laser scanning, photogrammetry, and videogrammetry. We, by extensive literature review, we have identified three major steps for progress monitoring using computer vision. First is data acquisition and 3D reconstruction. That can be done in many ways, as you can see, using drones, robots, handheld devices, etc. Second step is for as-built modeling. Once you capture the data using images or point clouds, you reconstruct the data in some form to get the as-built model, which can be in form of point clouds, mesh models, surface models, etc. Final step is the progress estimation step, where we compare the as-planned model with the as-built model of the facility, and we compare we get the progress status. Additional step includes sending of notifications and warning and reports to the project managers. So for the first challenge is how to select a better device. There are multiple constraints on selecting devices for data capture for project progress monitoring. There are multiple devices in the market. In an exploratory study by us shows that the current challenge in progress monitoring is mainly the progress monitoring happens through Excel sheet based DPR and DPR based reporting, and the vision based methods are very sparsely used. The main reason being that the high tech cost of technology and improvement and the requirement of skilled staff. The main factor affecting the computer vision based methods is the weather issues. For example, if image is captured, it can be affected by mist, fog, rain, dust, and other issues that affect the visibility of the scene. These issues not only affect the image capture, but also the reconstruction. Second types of issues, challenges which we face are navigation issues. At construction site, there are a lot of unwanted objects that are present, and in some areas, even the light is not adequate. For a drone or a robot to move freely, there are navigational constraints that comes as a challenge. Third is the cost of technology. The cost of technology, as we already told, is one of the major challenges. As you can see, the accurate data capturing technique is from laser scanner, but it costs very high and it costs lakhs of euros. And low-cost techniques like photogrammetry also cost high, but gives poor results. So one of the cost of the technology also have to be brought down. Finally, there is a process called a scan to BIM, where we scan the point cloud and convert into a BIM model. It requires geometrical development and BIM development using learning-based techniques or heuristic-based techniques. Conventional scan to BIM is a very complex and tedious task where we have a point cloud captured. Then with manual hands, we create walls, doors, windows, and using some of the tools, we can create a BIM model. So this is time consuming, less accurate, manually very intensive, and requires specific tool set and domain knowledge. Using using constraint-based methods also requires a high amount of data to be fed. For example, in this scene, if we want to capture a column, the dimensional constraints of this columns needs to be fed earlier to detect that column. And finally, the learning-based methods, where we have an object and we learn it based on a model, which is there, and it gives us, it detects the object in the point cloud, whole point cloud. So specific challenges to apply learning-based method includes that it requires an extensive data set for point clouds. Secondly, for all unique elements, it is difficult to get the training data for all the unique elements in construction. It takes high computational time. And for each construction project, the project is different, and the components of the projects are also different. So hence, open sourcing and benchmarking is a step towards applying learning-based techniques. So here I want to summarize it with the challenges, the 4 key challenges in scan to BIM, that the conventional techniques are manually intensive and time-taking. Heuristics-based information requires too much knowledge to fed in prior with domain knowledge, and learning-based techniques are less explored. They require a particular mid-construction dataset for training, which is not there, and requires efficient architectures for object detection and labeling. With this, I complete my presentation. Thank you.
Thank you very much, Varun. Well, our team works very well on timing. Thank you. Again, if we have any questions to Varun on the construction project monitoring, then please bring your questions to the forum at 3 p.m. Hanoi time. Right now, Hubert's already logged in. Oh, congratulations for the new haircut. Thank you. You have 3 minutes, Hubert.
Okay, yeah. Do we share my screen now?
Yeah.
Okay, do you see my screen now?
Yes.
Okay. Hi, everybody. Today, I would like to present my recent research as a assistant at the Department of Planning, Industry and Environment of New South Wales State, Australia. The topic is on deep learning techniques for enhancing the accuracy of air pollutant forecast. As air pollutant is a huge problem, not only in developing country, but also in Australia. So every day, nearly 2,000 Australians die, and people, government spend nearly $24 billion for healthcare that related to the air pollutants. So the government spend millions of dollars to build their air monitoring station and the water sensor network over the whole country in order to inform the real-time information And they also dedicated to build the software and model-based method to forecast the pollutants. But this model require high intensive computing efforts and affected volatility of the environment. So it cause degrade accuracy. And this is my motivation that using the high technologies. Recently, we know that the deep neural network are very powerful for fusing these data from station, from wireless sensor network, and from the forecasting model to improve the accuracy of these models. My main core technology using in research is long short-term memory, state-of-the-art neural network, and the inputs of my models is including only two values. The first one is the fusion of the forecasting value from the model-based method. We call the chemical transport models you're using in the New South Wales state now. That also included the meteorological features. And the second one is the real observation collected from the high-quality monitoring station is the input for forecasting models. And secondly, I also concern on the uncertainty of the forecasting values, so that I incorporate the Bayesian neural network, which is very powerful when using the posterior of the model parameters in order to infer the uncertainty. But because the neural network is very complex due to the nonlinear relationship and the high number of parameters, so we need to have approximation method. In my research, I applied the variational inference method in order to approximate the posterior distribution of the models by optimized function we call the Kuhn-Bach-Leibler diversion. And with these hybrid models, we can produce the preliminary results. As you can see here, the ozone prediction. For each time step, it can produce a predictive distribution. Not only just one values as normal or simple deep learning models. And from this distribution, we can infer the confidence intervals where we can apply later for the decision-making system. And I apply my hybrid models for different data set because it has a different distribution over to distinguish pollutants. The first one is ozone, and the second one is PM2.5. And I use the root mean square error as an evaluation matrix. And you can see over here for evaluation, I use the long short-term memory deep learning models as and model-based method CTM as the baseline models, and performance for all dataset, both ozone and PM2.5 show our proposed model outperform the baseline models, and especially in some cases it can improve up to 72.8% and 40.4% for ozone and PM2.5 respectively, in comparing to the CTM forecast that is using in New South Wales state for forecasting air pollutants. So briefly, in conclusion, I would like to say that the first preliminary results show the improvement with the hybrid model between the deep learning, LSTM, and Bayesian neural network. And from this one, we can not just only using for air pollutants domain, but also for similar time series domains like weather forecast, IoT-based monitoring system, or using for low-cost wireless sensor network or monitoring station. And from this research, we can see that it can be robust in both stochastic and seasonal data, so that it can be applied widely for different domains. And as I presented, I use only two inputs, the CTM and observation, so that it can reduce the resources and time for calculating. Thank you for your listening.
Thank you very much, Hubert. Thank you. Although the presentation is short, but it's rather comprehensive, and the topic is rather sound in a sense. So whoever like to follow up, then we have a time in the afternoon at 3 p.m. For the open forum in Hanoi time. Now the next speaker, I like to invite Larry. Yeah, are you there?
Yes,
okay.
Yeah.
Game theory and formation control of drones.
So can you see my screen?
Yes.
Yes, so hello everyone. I am Lang Nguyen, and today I would like to present my current research, game theory for cooperative UAV system. In recent years, the interest in UAVs has been growing with numerous applications in both military and civil applications. For multiple drones, the individuals working in a team can draw a significant improvements in their performance. To control multiple UAV systems so that it can complete the mission, we design a hierarchical control structure, including 3 layers: the formation design layer, the path planning layer, and the task execution layer. In this project, the objective is to minimize a cost function, including multiple objectives, such as collision-free, minimize formation error, minimize total traveling distance, and minimize trajectory checking error. The cost function Jn mentioned here is known for each path quarter. These cost functions conflict and interact among vehicles. Therefore, it is difficult to solve multiple optimal problems simultaneously. Meanwhile, game theory is a study of conflicts and interactions among decision makers. The game players can pursue their individual objectives by simultaneously considering possible goals, behaviors, and countermeasures of other decision makers to achieve a win-win situation. The solution of a game is a game equilibrium. As can be seen, the UAV control system is aligned well with the game theory. Therefore, we design a cooperative UAV game. To find the game equilibrium, particle swarm optimization-based technique will be introduced. In PSO, by updating position and velocity of every individual in the swarm and evaluate its finish function after every iteration, an optimal solution can be found to achieve the game equilibrium. In the experimental setup, 3 3D solo drones forming an equilateral triangle shape are connected to Q-route control station by a 3D link secure Wi-Fi network. Using the game theory and PSO, the game equilibrium is achieved, demonstrated by the convergence of the UAV finish functions. The figure below shows the trajectory checking performance of actual paths with respect to planned paths. It shows that all 3 drones can track their planned routes well with minor checking error, illustrating the feasibility and efficiency of the proposed approach. So in conclusion, there is conflict outcome among UAVs in cooperative UAV applications. So game theory is designed to achieve the common or conflicting goals of UAVs, and PSO is interested to find the game equilibrium. Thank you very much for your listening.
Thank you very much, Larry. It's great work. I didn't expect you to do a beautiful video slides. Okay. Again, the topic is rather interesting, and whoever like to follow up with us, then please come up to the forum and we can have a further time for discussion. Right now, I'd like to move on to invite a young researcher from Quy Nhơn University. Vũ, are you there?
Yeah, I'm here, Professor.
Okay, so Vũ has kind of willingness to follow up a PhD degree, and let's see how he like to propose during his 3 years or 4 years candidature for a PhD work. Okay, so yeah, your time, 3 minutes, please.
Yeah, thank you, Professor. Can you see my presentation?
Yes, I saw your screen.
Hello, everyone. My name is Bengal.
Not yet. You need to share your screen.
Let's
yes,
me see.
Now, it's okay now.
It's okay, Professor?
Yes, go ahead.
Hello, everyone. My name is Bengal. I come from Win University, Vietnam. And today, I would like to show you my PhD research proposal about developing.
You can enlarge your slide, if possible. You see the icon next to the on your right hand side. Yes, you can. Yeah. Okay.
Yeah. Yeah. Thank you, Professor. And for years now, loading of research has been carried out that aim to apply drones in crop management. Unfortunately, agricultural robots like drones haven't had significant impact on agricultural practices. And then my PhD research proposal would mainly concentrate on the integrated learning and control algorithms applied to data-driven controllers for application to agricultural robots like drones. And when it comes to my hypothesis, I hypothesized that the theory of data-driven control has an enormous potential for developing controllers for agricultural robots. And I think there are various reasons why we should use data-driven controllers for agricultural mobile robots. First, there are some drawbacks of traditional model-based controllers. For this, an input-output for a state-space accurate model is required. However, in some actual cases, accurate model is not available, or it is very difficult to acquire. Furthermore, if a mathematical model is available, it is often a simple approximation of the original system, which may have nonlinear, higher order, or time-varying behavior, of course not included in the model. And on the other hand, if we use complex model of the system, this can lead to complex controllers, which are difficult to design, diagnose, maintain, and implement. By contrast, there are some advantages of proposed data-driven controllers. Unlike model-based controllers, have to use a mathematical model of the system. Data-driven methods use only input and output data in the controller design procedure. And furthermore, some major problems such as unmodeled dynamics or unavailable description of the upper bound of uncertainties do not exist with this method. So I think there are reasons why I have designed my future research will find out deeper about developing data-driven algorithms for agricultural robots. And speaking of methodology and technology, first, the theory of the developing data-driven controllers will be taken into consideration carefully and then applied for developing controllers. And next, these controllers will be tested via simulation, maybe using MATLAB Simulink or the like. And finally, experimental data of the real system would be analyzed to compare with other algorithms. Thank you, everyone. My presentation is over.
Thank you.
Thank you, Professor.
So if the audience, you have any questions to Vũ, then you can raise your question. And apart from that, involved in this workshop, do encourage you young researchers, young lecturers to consider to do serious research. Earning a doctoral degree will be like a license to help you in the career. So if you consider that, please feel free to contact us around. Yeah. Okay. So very good timing. I see now, although we have even 1 minute earlier. In fact, the talk and performance will start at 3:40 Sydney time, or 11:30 in Hanoi time. But I think right now we see the two musicians, Professor Salil Zakdev. Hi, Salil. And Dr. Lê Tuyên Nguyen from Sydney. They are all ready. Well, if you are fine, and if the two musicians are fine, then why not to go? Or maybe you can take a deep breath in and breath out to relax, to meditate, to thank God that we still joining together and be happy together and doing something interesting together. Yeah, given that I receive a lot of messages of warning, etc., from the Omicron, from elsewhere as well. Yeah, and it's a good time to meditate and to appreciate that we still survive the pandemic. We still feel sustainable, and we still feel resilient. Resilient because we spent I think from 12 to 3 hours, more than 3.5 hours continuously. I think we nearly break a record that we continue talking about and scientific matters in 3.5 hours, non-stop. And it covers a lot of topics, from energy, from infrastructure, from environment. And believe us, it is not that easy, very sound, very in-depth. However, we still feel alert. Well, thanks God. Yeah, so it is timing. I like to introduce in front of you Dr. Lê Tuyên Nguyen, our close friend, and also a great guitarist, musician, holding a doctorate degree in the musicology from ANU, and also teaching fellow ANU, and now working for Department of Education in New South Wales. Also Professor Salil Zakdev from Bridgewater University, Massachusetts. Well, sorry, Salil, that you need to get up at this time and then joining us. But hopefully you still feel the resilience and the sustainability and the energy to talk, to perform, and we just very keen to listen to you both, how you feel the marriage between the music and science, and how you address all the issues of burning issues that the human are facing nowadays, regarding the pandemic, regarding the shortage of energy, regarding the degradation of infrastructure, regarding the environmental issues. I think right now I feel very excited to welcome both musicians, Dr. Nguyen Litwin and Professor Salil Zakdev. Your time. Thank you. I think Litwin, you are mute. You click on yeah.
Yeah. Thank you so much for the kind words. Yes, Salil, my colleague, and I normally talk this time anyway, because we work for years. So I just remember talking with him all the time. All right, so just a brief introduction. I met Professor Sachdev in 2010 at the first Asian symposium at the Sydney Conservatorium in Sydney. And we hooked up and we performed. So he invited me to the USA to perform. And then since then, we've been playing around the world. The beginning, we basically, our music is, funny enough, it's about culture and also about nature. So we talk about that more later. But for now, I would like, I will play you some music in a moment. After Professor Salil said that we'll talk a little bit about how, he think about our work together.
Yeah, thank you so much for inviting us, Kwang. Looking forward to our presentation here. Yeah, so as Litwin mentioned that we met about 10 years ago and we looked at each other's performances and really felt the need, the desire to collaborate with each other. And as Litwin very appropriately puts it, our music is very reflective, even though consciously, I don't think consciously we made an effort to really to create music about the environment, the nature, and perhaps even culture. But I think that just happened by itself because a lot of the compositions that Litwin has composed, whether he has thought about it, I think it's just something that has come out from within him to deal with like the highlands of Vietnam, the festivals of Vietnam. And then when we came together as a group, I brought in my background, which is in Western classical music and world music and African music, and to quite an extent in Indian music as well. And of course, Litwin is very strongly embedded in the Vietnamese tradition and the Western classical tradition. So unknowingly, perhaps we just felt that this combination worked really well. And that's where we are today. And we continue to explore. We are not just limiting ourselves to one particular tradition. We continue to evolve and explore as a duo. So, yeah.
Yeah, now I will play one of our first piece of music playing together. I always do that on a recording, so it's easier to listen. Now, this music is an example of what we do. This is gong music. Gong music is like a cultural an essence of the Vietnamese highlands people. And I put it on the guitar, and Salil using the hang. He will talk about that later. So we bring the highlands, the music, the people, the ambience to the Western stage by using just the guitar and the hang. So I will play the music now. So you will see, I will share the screen. All right, now we'll play the Call of the Mountain Forest. Okay, so that's the first composition that we normally play together. And Salil will now explain, what he used in this. So the music is the music of the Highlands. Now the scales and the rhythm is used on the guitar, the Western instruments, and Salil also used the tone color of the hang to mimic the sound of the gong. So we will talk about the hang in a moment.
Right. So the one particular instrument that I used for this piece, which actually Litwin felt would be very appropriate, was because this is an instrument called the hang, right here. It looks like a flying saucer, and it was invented in Switzerland in I believe in 2000. So it's about it's only 21 years old as such. And the very great thing about this particular instrument is that you are able to play melodies by simply using your hands. And since I play percussion using my hands, this was quite a gift to me, because normally you are not able to find an instrument where you can actually play melodies by simply using your hands. You can use, mallets on a xylophone or a marimba, but you don't really have an instrument where, or till the hang was invented, you really didn't have an instrument where you could play melodies by hand.
Let me add to that, just one side. Now, that's perfectly fine with the Vietnamese gong, because the Vietnamese Highland people actually play with the hand.
Right.
So I just want to make sure that people understand that why it works so well.
Right.
Because you actually play with the hand.
Right, and also the instrument is designed in such a way you can see, these little side areas of the instrument, which are actually tuned to specific notes, and the central note here is almost representative of a gong-like sound. I don't know if you'll be able to hear this, but I'll just demonstrate it to you. And then if I demonstrate this, let me see, the scale to you, it would be like. So that's the instrument. I'm not sure whether you could hear this, but anyhow, that's the.
Very well, I can hear it.
Okay, and so one more interesting thing, the term hang, which was coined by these two inventors in Switzerland, it actually means hand. So it's a very appropriate term for this particular instrument. So that's the instrument I used. Yeah.
Thank you so much. Yeah. The next is the Salil. We talk about culture. So Salil and I have a musical dialogue for about 10 years or more. What the outcome of that is we have music, but at the same time, Salil can now sing in Vietnamese. So today, the very first time in, ever, Salil going to be singing in Vietnamese in public for the first time. He actually play. So the conference attendees today will witness first of its kind ever, an Indian musician singing Vietnamese. So I checked everything. And I think he's doing very well. So, okay, back to you. Singing Vietnamese now. Thank you. We're waiting for you.
I wish I was as confident as Litwin, but I really sing. This is about one song that I learned, Likon Shao. And the reason I learned this was because, I play this song with Litwin quite a bit, but I also direct a world music ensemble at the university where I teach. And because of my collaboration with Litwin, I felt that I could teach my students this particular song. And we actually, I had an ensemble of about 5 students. And last year, we actually ended up performing this piece as well in our final concert. So I'll give this a shot. Please excuse me for those of you if you think my pronunciation is wrong, but I'll give it my best shot. So this is Likon Shao, Song of the South. So ai đem con sao sao sheng shong cho nó so long cho nó so long bay co con sao bay xa so long bay xa con sao bay xa. That's about as far as I can do.
Thank you so much.
May I just interrupt, Salil?
Yeah.
I think during the Vietnam War, the great musician Phạm Duy, maybe you already heard, already played this to Steve Addis. Steve Addis is now a professor.
Yes.
Also, and also they also play Lý Công Sáu.
Oh, that's great. That's great.
So 50 years, half a century, there is another professor from United States again, Lý Công Sáu.
And I'm actually going to be teaching this song. Like last time when I taught this song to my students, I had them do it instrumentally because I was not confident to teach them the words. But now I feel more confident. So now I will make them sing the song actually as well. So now you have a newer generation who will also be learning this song.
Yeah. And there is a philosophy behind Lý Công Sáu.
Right.
Maybe I can explain you to another time.
Yeah.
Why I đem con sáo sang sông cho sáo sổ lòng bay xa.
Yeah,
Okay.
but because of time, up now we'll play the instrumental version of it. Salil actually play that on the Middle Eastern fan drum. I'm playing the guitar. So this is the music.
Oh, this is the frame drums that I use to.
Hang on, let me play it first. Hang on.
Yeah,
wait.
sure.
So I share the desktop. Share. Okay. Okay, so Salil going to explain the frame drums from Middle Eastern. He used in Lý Công Sáu.
Right. So I use these drums that are known as frame drums. And actually, this is a combination of two drums. You have one large drum over here, and then you have one small drum over here. And I've basically just taken a sort of a clamp and I clamp them together. So when I do that, you get a sound which is both higher and sound and lower in range. Again, I'm not sure whether, through a Zoom you can hear this, but I'll just show you. So, You get a
Yes.
very wide variety of range. And that's the drums that I use for this particular song.
Yeah, so next I will show you the African context that Salil has brought to our music. So we have a next music called Come Together. We are trying to depict the festival of Vietnamese of Highlands, like when they get new rice. So here's the music, and then Salil will explain. He actually used a thing called djembe, an Indian, African drums. We talk about that in a moment. But at the moment, I will share the screen, and you will hear the music. What's called "Come Together," where you will have music of the Vietnamese festivals, Highlands festivals. Yeah, so you can see that in that sounds, guitar, we got percussion instruments from Africa, and I think some of the Indian jingles as well, from the Indian dance, classical dance. They put foot, so they're going to show that to us in a moment.
Right. So, very simple thing. Indian classical musicians wear this foot jingle on both their feet while they're dancing, particularly in South India. So to reflect that festive spirit, I also sort of tied these on my ankles, to give that sort of a festive spirit to the music. But then that was the Indian aspect of it. But then the drum that I play is this particular drum. It's called the djembe, which you basically, let me see if I can strap this on and show you. Yeah, which I basically sort of strap it between my legs and play with my hands. So, to us, the important thing was not necessarily to use instruments from Vietnam to reflect the Highland Festival feeling. It didn't matter what. The important thing was to use whatever instrument that would be reflective of that festive spirit. So I ended up using the foot jingles from India and then the African drum from obviously West Africa.
Yes, and now all that cultural influences, we're trying to talk, and we bring it to raise an awareness of the environment, nature. So we talk about, right. We raise all that. Now, one of the collaboration with another person where we work together is Trung Nghĩa. He used our music. I wrote the music called Heart of the Ocean to raise awareness of the Great Barrier Reef in Australia. He actually used that for an exhibition about raising another awareness of the environment in Vietnam, in Da Nang. So here's the music. So I'm just gonna share the screen again. 2. Yeah, so you can see that our music is used by other people to also, like we use that for, we worked with the WWF before to raise awareness of the, people. The last rhino was killed in Vietnam. So I wrote a piece of music dedicated to the last rhino. So Liu and I have been playing music and raise awareness of the, the highlands, Vietnam, and now we, also, the seas. So we but we didn't never intend to do that in the first place. It just happened, and we suddenly become strong advocates for nature and culture. And lastly, we're going to show you one thing that's a very exotic. Which is, so we're going to show the Indian, the Tibetan Buddhist bells, and we play for our music. Before that, I will show you how it sounds like first, and then we'll explain what it is in a moment. So I will show you the music first, and so they will show you the Indian bells. Hang on. Sorry, something wrong. Hang on. Yeah, okay. That's the sound of the Tibetan Buddhist bells. Yeah, so Liu, I'm going to show what it looks like and how you play it. A very interesting concept of Buddhist bells.
So I use these Tibetan bells, which I had gotten from India. But the way I play these bells is not simply with the hand. Actually, a friend of mine, he made me these, what we call finger mallets. So I actually strap these onto my fingers like this. I strap these onto my fingers like this, and then I use these finger mallets to, it looks kind of scary, but I use these finger mallets to play on the bells, because I'm able to sort of get a big nice sound out of the bells, and I'm also able to strike the bells strongly as well.
Yes. Now, with run out of time, so we're going to play a quick last thing. This is called Moonlight, and so we're actually going to play on the actual Tibetan gong, and I play the guitar, but you will not hear any guitar sound, but you hear the sound of harmonics. So it sounds exactly like the gong. Okay, so Moonlight. Thank you so much.
Thank you very much.
Thank you.
Thank you.
Great performance, great talk.
Thank you.
Great
Yeah.
inspiration.
Thank you so much.
Yeah.
I just want to say one last thing. See, I use guitar not in a very strange way. I use guitar as if it's actually a gong. So you hear on the guitar, but it doesn't sound anything like guitar at all. It sounds like two gongs playing together with the Tibetan gong. And that's one different way of thinking.
One more, I think it creates many dimensions. You hear the sound, you hear the performance, but your perception is various, and the greatness coming from many dimensions that that kind of music and the synergy of the sound can offer to us. Thank you so much.
Thank you so much for inviting us, and Professor Quang, Salil and I will love to go to Queen University. So we look forward.
But however, we really appreciate your willingness, and we love also to see you both again in the next event.
Thank you so much. Thank you.
Thank you. Okay, so we are very on time, and I think we are now having the break. Yeah, we will have a break till 2 o'clock. No. We are having a break till 1:30.
1:30, okay.
Yes, 1:30 in Hanoi time. So you have roughly 1 hour and 20 minutes for refreshment and lunch, and we will resume back. And to be mindful and to be cheer up, the first speaker will be a very prominent, renowned scientist, and many things to be expected from his speech. Again, I would love to see you. Here, Professor Tuan, we just mentioned.
Oh, sorry.
Yes, you missed. Of course, but you just come in just in the right time that we are going to have.
I'm sorry. I just sneak away to Singapore for a few minutes, and then I'm now back.
Yeah. So you have something to add in, otherwise the people around here will have a lunch break.
I suppose we can have a lunch break.
Hello, Professor Tuan.
Hi.
Yeah. So
Hi, Ben.
basically, the workshop will resume in I think in 1 more hour.
1 hour, about 1 hour, yeah.
Yeah. Basically, your kind of lecture, invited lecture, will start at the 1:30 Hanoi time. What it means is
1:20. 1:20.
1:20. It means 1:20.
That means 5:20 in Australia time.
Yes, 5:20.
Yeah.
5:20. So I myself have not have anything as yet. Yeah, I also need a kind of refreshment. to be honest. And also the audience here also need kind of lunch. Yeah. So if Professor Tuấn say something, then we listen to you. Otherwise, maybe we have a break, Tuấn.
I think we should have a break.
Yes.
It's quite a heavy program.
Yes. But we love to see you at 1:20 in Hanoi time. What it means is 5:20 in the Australian time. Okay.
Sure.
Okay. See you everyone.
Look forward to hear Professor Tuấn talk. Will be very interesting.
Yes.
Yeah, I hope so. I got some very nice data from Vietnam, and it's a very nice relationship. Something that we expect, from a communicable disease point of view. So I guess you probably like to see this is real data from Vietnam. Not simulation or something like that.
Okay.
Very good. Yeah.
Okay. So have a break, everyone, and good timing. I should stop the recording, and then we leave here. All right?
Yes.
Bye. Bye for now, and see you in 1 hour.
Recording stopped.
I'll see you later.
Well, welcome back, everyone. And we have 5 more minutes to go, right? We start at 5:30, right?
I'm not sure. I thought 5:20, but then
like
it just gives you extending
time for people to to attend. The more the better. So according to his timetable, we will wait for 5 more minutes to
Okay. Yeah.
Anton, can you share your screen or?
All right. Okay. Let me try. I think it should work. It's okay.
Yeah. Basically, it's okay. So in fact, I don't think that we make the serious things around, but in fact, so far so good. Well, thanks a lot for everyone, especially thanks for the patience.
So I will try to keep it on time, so you guys can have a sizable time of discussions.
And in fact, the forum or whatever, and might talk as well. Everything is flexible. You take your utmost the priority in order to address this, of course.
So you think in the forum open discussion, are we going to use Vietnamese or English?
I think to be consistent, we just talk in English.
In English, okay, all right.
Whoever go into this level probably need to be familiarized with English.
Okay.
Apart from that, you can give it somehow Vietnamese.
No way.
In that case, come on.
All right. Sometimes it's easier to tell people in Vietnamese. There's something I don't want to talk in English. Sometimes things are not that inappropriate, but it's not suitable to say within or among ourselves.
And there is no 100% equivalence in English and Vietnamese, especially something the kind of very the special property with our country, with our people.
Yeah. So but look, the slide is in English, and so people still can go back to refer to. They want to learn the new terminologies. They're on there. It's just a matter of presenting, orally to people, either in Vietnamese or in English.
Right now, I have only 16 participants, so probably we have 1 more minute to go. And whatever we should maintain on the timing, we are doing kind of professional things. So I guess,
But it's normal anyways. After lunch, people will fall asleep, and the biological clock is in trouble always. So you will see some drop from the opening sessions. I don't know.
1 more minute to go according to my clock. Again, I will do a recording, and I hope that this time we have a good video tape. Thanks a lot, Hip and your team.
That's a good job.
It is our first time organizing something like this from AVITECH side. Actually, I think the time we have is a lot, but the paperwork takes time. That is why there's something we should have done better.
Of course, we will learn on the way. Now it's ticking 5:30, and I think I'm first going to record this second part of the workshop. And yeah, I take the pleasure to introduce Professor Tuan Nguyen. NHMRC Leadership Fellow, Professor and Director, Center for Health Technology, UTS, Co-Joint Professor, School of Population Health, UNSW Medicine, UNSW Sydney, and also Distinguished Professor and Director of Bone and Muscle Research Lab in Tô Thắng University, Vietnam. So please welcome Professor Nguyen. Yeah. And the topic is rather very actual. It is on the pandemic, the COVID-19 case.
Right. Okay, thank you very much, Dr. Quang, for your glowing introductions. You don't need to mention all of those funny titles, for me. Once again, thank you very much, the organizing committee, for having me here to share with you something that is really not just topical, but also very close to my heart. Something that I have followed over the years. And so in the next 20 minutes or so, I'm just going to talk about a hypothesis and the data that I think support the idea that the population density as a catalyst for communicable diseases, and that when I talk about communicable disease, I mean COVID-19 case as well. And I'm going to use some practical or real-world data from Vietnam, to illustrate the point. And so to give you some idea about the situation that we are now facing, this is the data not really up to date because it keeps changing every minute anyway. So up until January the 6th, you can see, we have almost 300 million coronavirus cases. Not all of them are COVID, obviously, but look at the number of deaths, which is almost 5.5 million people have died during the pandemic, and that is one of the major pandemic that we have in this century so far. And if you follow the situation, you often hear things like this one. COVID-19 does not discriminate. Its impact does, right? You hear that all the time. Virus don't discriminate, and neither should we. I think the message is absolutely humanist and something that we also should follow. But in reality, this message, the message that COVID-19 does not discriminate, to me is a dangerous myth. Why? Because in reality, in the real world situation, you will find that there was an increased risk of those with low socioeconomic status, and particularly in a high density living. And these are not just opinions, but they are really supported by properly designed studies over the years. So I don't believe, that COVID-19 does not discriminate. It actually discriminates, if you see, things from a broader pictures of the field. So, to talk about the population density, I guess, I just want to touch on a very important issues, and that issue related to the causes of COVID-19. Now, in medicine, you can approach the cause from two angles. One is from the population level, and one is from personal level. I'm talking about individual level. So at the personal level, everybody knows that COVID-19 is a disease caused by SARS-CoV-2, right? So everybody know about that. It's a part of the coronavirus. And how does it spread? Well, it's spread, by droplets, something like coughs, sneezing, and breathing, and singing, and one of those things, which can be a major vehicle for the virus spread. And the major risk factor was a close contact. Now, so that is at the individual level. But if you think about the environmental cost of the COVID-19 pandemics, you will think that firstly, it's about the nature of the surface of the object that we touch. But to me, something that's even more important, but people have not really referred to, and that is a population density. Think about this one, you look in the left and the right. In the left is a photo from Saigon. It's like an online magazine, in the US, I think. You look at the high density and fairly, running down sort of residents in Ho Chi Minh City. And on the right is somewhere in the northwest or northeast of Vietnam. You can see that there's a fairly low density residency. So if you think about the impact of population density, you will find that most COVID cases occur in the city rather than urban areas. Right? We all agree on that. It doesn't matter where you are, whether you are in Vietnam or whether you're in Australia, that is the root. So most COVID cases occur in the city and the urban area rather than rural area. In Australia, 99% of the COVID cases actually occur in the city, not in the rural area. And even in the city, the situation is also different. Most COVID cases in the city occur in the highly dense area, not in the low dense area. And I think, those simple observations provide us an indirect evidence of the impact of the population density on COVID-19 pandemic. So that is an idea. Let's go to the data. And here is a very large-scale study looking at the association between social distancing, population density, and temperature, and the reproduction number. I will go back to this idea a little bit. And this study was published in JAMA, right? JAMA Open, but it's part of JAMA. And if you work in medicine, you know that JAMA is one of the top journals in the world. It's like a second, Bible of medicine, right? And the data was thoroughly collected from 211 counties across the US, 46 states, and almost 180 million resident data was collected. So it's a huge study. And the outcome, that this author looked at was the reproduction number. Reproduction number is the average number of infections that originated from an index case. So if the reproduction number equal to 2, meaning that one person on average will infect 2 other persons, and 2 other persons on average infect another 4 persons, and so on. So that is the first outcome measure. And in pandemics, and just like
recording in progress,
in any epidemiological problem, the reproduction number is the key index, is the key indicator to reflect the burden of the disease. It's not the number of cases, but the reproduction number. It's a very important one. And unfortunately in Vietnam, people don't pay attention to that. And the second outcome was the incident case. So what did they find? Well, here is the basic, table that I extracted from the paper. So in the columns here, they subdivide the population density, the county, right? They subdivide the 211 counties into 5 groups of population density, which they call it, a quintile, right? So the first county is less than 25th percentile, the next one 25th and 50, and so on, until the 90, more than 90 percentile. And to give you some idea about the population density, so the lowest quintile has a population density of about roughly 300 people per square miles. But go to the density like a 90 plus, but you are talking about New York and Chicago and that sort of city, almost 9,000, people per square mile. Even so, it's still less than in Ho Chi Minh City anyway. So look at the R0, which is the reproduction number. As I say, it's very important statistics. You can see that, the reproduction number here is almost linearly related to the population density. For the lowest county, for the county with the lowest population density, the R0 is only 3.1. Has increased almost twofold when the density increased to 90 percentile. The incident, another way you look at it is you look at the incident case per 100,000 population. Again, look at this one. It's increased from 121 in the lowest quintile to almost 1,200 in the highest quintile. It is I look at the numbers. So, wow, this is the illustration of the idea. That is even with the mortality. So, the counties with the higher density also record the higher mortality rate compared with the lowest one. It's pretty convincing to me. But that's in the US. In the US, they have a different lifestyle and population structures, than the Asian population. So what about in Asia? Okay, so here we go. This is a study in Malaysia, our neighbor. And in this case, this study is a bit funny. They look at the correlation between the active COVID case and the population density, and they present that as a Pearson correlation coefficient. It's not a wonderful study, but it gives you some idea about the relationship between population density and COVID-19 incident case. So whether you look at Malaysia as a whole or you look at the individual regions, look at this one, the correlation was pretty high. It was about 0.78, meaning that, the population density in a way explains probably about 64% of the variation in the COVID case. But again, this one is an ecological correlation. It's not the individual correlation. So you have to bear in mind about the interpretation. Now, what about in Vietnam? In Vietnam, as you know, there are, well, I don't know, there are maybe 4 or 3, depending on how you count it. But to me, I think there are 4 waves of the COVID-19 incidents. Recently, as you can see in this curve, so until now, we have recorded more than 1.8 million cases. And the sad thing is that there was a high case fatality rate. At the moment, the number something like 33,000, which is roughly about 3%, I think 3%. Compared with the world's maybe about 1% or less. In Australia, it's a very, very low fatality rate. And that is something we should keep in mind. Now, I decided, to look at the population, look at the relationship between population density and COVID case in Vietnam. So the way I did was that, I go to the General Statistical Office in Vietnam. I extract on the population data for each province based on the census data in 2020. I look at the COVID case from the government, and trust me, this one is not a simple task. I have to go down. To each province and they key the number. It's funny, in Vietnam, they do not provide the data so that we can analyze. But they want to make your life more difficult, essentially. but never mind, if you want to do research, you have to commit. Okay, so I extract the data from the COVID-19 website, and then I look at the outcome. The outcome, all I have is the PCR confirmed incident case, and I look at the case fatality rate. And case fertility rate is actually defined as the number of deaths over the number of positive cases. It's overestimate, by the way. It's overestimated the risk of death, but then not much we can do because we don't have the individual data point. So what did I find? So here is a simple graph show the number of COVID cases per 1 million population for each of the 63 provinces or city. You can see that top of the list is Bình Dương. The next one is Ho Chi Minh City. The next one is Long An, Đồng Nai, Tiền Giang, Tây Ninh, and so on. And the least case per million population was in Thái Nguyên, Tuyên Quang, Yên Bái, Lai Châu. So they are in the up north, and if you pay attention, that you will see that these provinces, they also have low population density. And Bình Dương, Ho Chi Minh City, Long An, and Đồng Nai, as you know, they have a pretty high population density with the influx of the workers from other provinces to this industrial area. So, it gives you some idea about the relationship between population density and COVID incident case. Okay, let's look at the mortality then. The mortality, again, those are provinces in Ho Chi Minh City, Tiền Giang, Sóc Trăng, Bình Thuận, they also have a pretty high mortality rate compared with Đắk Nông and Hải Dương. But then these are data, I think it's not adequate anyway. However, it still provides with a glimpse into the magnitude of the problem. Now, this is a very important graph. It's very simple, but it shows the relationship between the number of cases in the log scale, and the x-axis here is a population density. And as you can see, I also present them as a log scale. This is for statistical reason. So you don't need to know any statistics. You will see that there was a linear relationship between population density and incident case, right? So with Ho Chi Minh City and Bình Dương and Hanoi, all of these areas, regions rather, they have a high incident case compared with those in Lai Châu, BK. I can't remember what that one is, but anyway, these areas in Bai, right? They have a low population density. And if you want, draw the curve across here, and then you work out the correlation coefficient, well, that number would be 0.69. Don't worry about the p-value, obviously have to be significant. What about the relationship between mortality rate and population density? Well, the relationship is there again, but it's not as strong as the number of cases. As you can see here, the correlation was 0.5. The highest, the area or the locality with the highest mortality rate is obviously Ho Chi Minh City. But this one is probably a misleading statistics. You know why? Because a lot of severe case was transferred to Ho Chi Minh City, and then they record the number there. So that's why I think this number is probably not right. But having said that, even if you exclude this number, you still can see a substantial relationship between population and mortality rate. So, okay, so look like it doesn't matter whether you look at America or Malaysia or Vietnam. In fact, I have more data, but because of time, I don't have time to show you. You still can see a strong relationship, moderately strong relationship between population density and case and mortality. So the question is why? Why there was a relationship? It took me quite some time, to think about this question. And my answer is that, I start off with the individual level, me at the individual level. So what the virus is doing, when it enters our body? Well, when the virus enters our bodies, it will invade the cell and it will replicate it, and it will make a lot of copies, as soon as possible. And if you think that's the individual level, then you also can think at a population level. So on the population level, the spread of the pathogen here, I mean the virus, is governed by the interaction between its hosts. Between its host and you and me. So the interaction between people within the community, that is the catalyst for the spread of the pathogen, or in this case the virus. So interaction here, what I mean is a social interaction, behavioral interaction, human mobility, the movement of people across the area and the localities, the behavior interaction when some people for a certain culture, they seem to have a close contact. If you go to Italy, people seem to have, very closely and very enthusiastically. Compared with, in Vietnam, we don't normally do that. For social interaction, for people like me, I normally go to coffee every Saturday and Sunday, to have a chat with my colleagues. All of these interaction, I think it will promote the spread of the virus in the community or in the population. So, greater population density promotes the interaction, promote more interaction, which in turn lead to more infection. So that is, I think, the mechanism that explains the relationship that we observe. Okay, so that is mechanism. So what the implication? Well, it's difficult, for me to think about this one. I think that, it will say, I think of three implications. Number one, COVID-19 will resurgence in the future, in the city and in the state when we reopen. And in fact, it's just, you can see either you are living in Vietnam or you are living in Australia, you see that, the resurgence of the virus because the high density and the interaction of people, when we open the society, then, there will be more case anyway. And that's exactly what we see. I think there's another implication for policy. The policy is that we should not do the concentrated isolation. I think it was a mistake. And that's what we already made a mistake in Vietnam. Because in Vietnam, they have a highly concentrated, isolation camp. And that's where, it promote more interaction and more mortality. But I think it's also has the implication for the urban planning and design. I know that, you guys here, are thinking about, the new urban design and planning. Maybe you should think about that. Think about it, about the population density as a catalyst for control of the virus in the future. So in terms of size, I think population density should be part of the disease modeling. At the moment, they haven't done that yet. And we should consider population as a surrogate measure of social distancing capacity. I mean, for people, for a city like Saigon, how can you do a social distancing? When the population density is too high anyway. So it's very difficult. And that means, it's really a challenge, for a city like Ho Chi Minh City or Hanoi to control the spread of the virus. And then the precarious housing condition and the poor sanitation, I think also can be reflected by population density. And a potential indicator for infection spread as well. So in summary, I think population density is an important factor for the spread of COVID-19. And I already showed you the positive correlation between COVID-19 mortality and population density. And it represents a serious challenge in containing highly infectious disease like COVID-19 in Vietnam. And that leads me to the hypothesis. So the greater population here, population density here, promote more interaction would lead to the higher risk of infection. Finally, I just would like to take this opportunity to thank again the EIER organizing committee and Professor Quang Ha for having me, in this wonderful workshop. I must also thank, my employer, the Australian National Health Medical Research Council, who has generously given me funding and salary so that I can travel all over the world, to talk to people. I also thank members of my labs in Australia and Vietnam who over the past 20 years are having a lot to do all of these modeling works. Once again, thank you, and thank you for listening.
And we thank you, Professor Tuấn, for your charisma, your eloquence, and your knowledge. Yeah, I think all that already we learned from the reality. Whatever you are saying here is just shining the scientific insights into what happened already in reality. Yeah, especially the hypothesis is already true. So,
that's already true.
And I would invite from audience. I saw here a couple of colleagues from far away, and for some probably from the medical world, as Dr. Trường, or for example. So may I ask just one single question to Professor Tu?
Sure.
Hello?
Mute.
If not, then probably we save all the discussion in the open forum, which will happen in 3 p.m. Hanoi time. What it means is 7 p.m. or Sydney time. Okay.
I think there's one question. TD Horn.
Yes, Professor Tuấn. Yes, Professor Tuấn. My name is Dung Hoàng. I'm working at the Vietnam National University in Hanoi. I'm very thankful for the very nice presentation, wonderful presentation. Yeah, I would like to ask about the sentence you mentioned a while ago about the concentration lockdown. You said that is a mistake, and the government should not implement that policies. So, but before the COVID-19, we did not know about the ways or the measures to deal with the situation. So the government already implemented that policies. So in order to avoid the other mistake or the same mistake that happened previously, how should we forecast, and how should we do the policy? Yes.
No, it's just a small clarification. I did not say that the lockdown was a mistake. I said that the isolation of people in a camp, in a concentration camp, is a mistake. Because as you can see, when we put thousands of people in a very small area without medical resource and medical personnel, and that's why it promotes a lot of infection. Now, if you look at the mortality number in Ho Chi Minh City, I have the number, but I'm not allowed to show here. Most of the, well, not most, almost 40% of the mortality in Ho Chi Minh City actually occur in those isolation camps. And that's why, and I think it's nothing new really. I mean, the local government, I'm talking about Ho Chi Minh City government, they also recognize that was a mistake. It's not lockdown, but it's the way that we...
Okay, opinion accepted. May I invite the Lê Thủy? Probably we save the discussion for the forum. I invite the Lê Thủy from Osaka.
Yes. Thank you very much, organizer, and I'm very happy to join this very interesting workshop. And I would like to ask Professor Tuấn Nguyen. I am the specially appointed lecturer in Osaka City University in Osaka, Japan.
Yes.
Yeah, I am working in Department of Hepatology. So I'm very now we are facing with the Omicron variants. So
yes.
How do you expect the relationship between population density with the Omicron spreading?
Well, that's a very important question. You know that the Omicron has a reproduction number of 7 or 10. And then the Delta variant has a reproduction number probably 3 or 4, I don't know, so it's lower. And as you can see, as the reproduction number increase, and if we high in areas with high population density would promote more interaction, meaning that the number of Omicron the number of infection cases of Omicron would increase. And that exactly we see in the US now. In the US now, I believe that's about 70% of the new cases are from Omicron. And again, they also occur in the highly dense area. In Australia, we don't have the number yet, but some people I talked to a few hours ago, they they also think that Omicron is now the dominant variant in the new COVID case in Australia. And again, it has a huge implication for controlling of the virus. In Australia, we do not send people to a concentrated isolation camp at all. We only ask them to stay at home so that they can take care of themselves. And I think that model, that home care model, should also be adopted in Vietnam in the future.
Yes, yeah, I agree. And same in Japan.
Thank you very much, Professor Tuấn. Thank you, Lê Thủy.
Yes.
May I just invite you to participate in our open forum, which will be at 3 p.m. Hanoi time?
Yes, sure. Yes, sure. I'm very pleased to join.
Okay, right.
And so
right.
right now, probably we come back to our program.
Yes.
Well, we have one more invited lecture by a great prominent scientist, Professor Young Trung from Queen's University of Belfast in the UK. But right now, by program, we will start our program again for a next part of the workshop. Addressing the potential postdocs or PhD students, or maybe we lower the key here a little bit to address the youth. And I'm going to do quickly an inspiration presentation for these young people who are starting to do somehow a next step in their career, namely being a researcher as a PhD student. Okay, so I'm going to share my screen. Okay, a pleasant PhD candidature. And you know that as a supervisor, I have graduated 19 PhD students in my life and going to produce some more. So somehow an experience to share with all of the young people around here. Okay, first, can I ask whether you see who is this old gentleman? This gentleman? Yeah. Yes, it is academician Ivan Petrovich Pavlov. And my eye just surpassed some medical expert here to look at his biography. Ivan Pavlov, yes, this 1849 is the year of birth, and the death, the year 1936. Yes, and throughout his life, he received a medical degree. He, of course, is the father of classical conditioning. The bell, and then you do something, you have the bell and you do something, and it is the kind of reaction conditional. That is called Pavlovian conditioning. And his studies is on digestive system, and that won him a Nobel Prize in 1904. Okay. Pavlov's work set the foundation for John Watson, whatever. But I like to draw your attention on his death, 27th of February, 1936. And that is on that day, he wrote a request to the academic youth in Russia, also on his last day of his life. Okay, and that request was published in Science, and that the date is April 17 of the same year. And what he's right there, he just leave three kind of what we say the merits to the youth. Firstly, gradualness. Secondly, modesty and passion. Well, I expect that on here we are heading to a scientific world, and probably that is the kind of meritorious properties that we aim in our life. Well, for young people starting a PhD candidature, I guess you start a new life, and that's maybe a while ago. You feel yourself in that. So, well, of course, at that time, we was rather confused. We don't know which way to go. Which way? Which way I would code a letter M, which is a map. M for map. Let's say I'm from here, Sydney. I want to fly back to Hanoi to attend this workshop face to face. Probably I need to take catch a flight. Not sure if I can be entering for free because I need to have 7 days in isolation due to COVID. But in fact, it is a map that you need. Yeah. Well, a map. We are engineers. We need GPS or GNSS, global network satellite system, or path planning. Or you are a PhD student. You need a proposal, and you need an outline for your paper. You need a guideline, you need template, you need instruction, you need kind of mentoring or advice or supervision, you need a map. Okay, that is the thing you need. And what you need? And what if, I mean, just X. X, because I want to borrow that, don't put all your eggs in one basket. Okay, now you need plan B. Somehow, what if it doesn't happen as you like, as you plan? You need a plan B. You need second opinion. You need to compromise. In my practice of engineering, we need kind of soft computing. We need optimization. As in the morning, you see that Professor Derek already mentioned. We need conditional probability. We need the Bayesian network. We need approximation. We need tolerance. We need trade-off. Okay. So the next is why. Why is also a question if you are doing the serious scientific work. Karma. Yeah, that symbol is for karma. And for karma, you always need to say cause. What happened if you do something, and what happened next as in association with that? So we do prediction. Probably we need that kind of causality in order to predict consequence, effectiveness, efficiency. This is the kind of thing, property of system that we need. And if you are doing serious, rigorous thing, we need somehow to prove that that is you come up with necessary condition. And if you can incorporate that with sufficient condition, then it is good. It is a kind of a terrain in that. Okay. Then what next? You have a map. You know the cause effect. You can say the plan B, etc. Now you need to implement. You need to realize. You need to make it work. Okay. And I put this to answer to the question how. How is E for effort. Effort. So yes, efforts make all the difference. Okay. Now I quote here something in this satisfaction lies in the effort, not in the attainment. Full effort is full victory by Mahatma Gandhi. And you may like the the image on 100 US notes, then happiness lies in the joy of achievement and the thrill of creative effort. Franklin Roosevelt. So you need to work. By all means, if you do a PhD, you need to work. And more, you need to try hard. You need to try hard in all means if you want to make it. If you want to have your own contribution, if you want to make a difference. You smash it, you push it, you concentrate, you emphasize, you do it, you make it, you have a goal, and you don't give up. Okay, so what next? You do all your work, hard work, you need to relax. Relax, R for relax. Okay, relax, reduce, recharge. Nobody can do well, keep constantly by all means, you need to relax yourself, to take it easy. Just keep calm. You can, but you collect the moment, but not things. You need kind of to, what to say is you take pity on you yourself. You need to take care of you yourself. Sometimes the most productive thing you can do, just relax. Okay. So after saying that you try hard to achieve, you need to know how to slow down. Take a break, de-stress, have a coffee, retreat. And that's why after in the morning, we spend 3 hours together, we need to refresh, retreat. Somehow we need to check. It is the relaxing time is to check, to have a flashback on what happened in the past. Let it go, breathe out, move on, and let's say if you drive on highway, you will see that stop, revive, survive. Okay. What next? You need to smile. What I'm saying here doesn't mean that I stimulates the brain, makes you come across as friendly, and brings joy to the people around you. Whether you say hello to a stranger, you pass on the grocery store, or wave to your neighbor while you are on a run, adding a smile. Yeah, smile while you still have a teeth. Okay. I appreciate in my lab if the PhD student come to the lab, say hi and wear a smile. You like a humor, you like an anecdote, you like something to make you laugh. Teamwork, have a laugh, and friendship, collegiality, or whatsoever. Okay, all that is need like lubrication in to de-stress, to keep the bone rolling. Okay. So yes, I quote here, peace begins with a smile. And that is wisdom coming from Mother Teresa. Okay, in fact, it is not just saying, just saying for saying. I myself have to practice every day. Look at the mirror, wear a smile, try to make sure that it is a loving smile. It is a practice. It is a practice. So I can sum up just map, X, comma, effort, relax, smile, or let's practice, makers. Okay. I hope that my talk, although it is irrelevant to energy, irrelevant to infrastructure, irrelevant to sustainability or environment, but it conveys something to think, to meditate, as to in our pondering of the things happening around, meditation whatsoever, to think as to how we have done and what we should aim at in the near future. Just simple. Let's practice makers. I think I will end up this. I hope that I'm on time to invite for the next speaker. Again, Professor Tuân Nguyen is my senior colleague, and I learned a lot from him. We always having fun together, and also have a cup of coffee on the way. I think I will stop share my screen from here. And I'm back here. So I hope you don't have to ask me question, but if you have, then feel free to ask me in the forum, or maybe right now. I think Professor Tuân from, well, I have 4 more minutes. However, I think the topic that Professor Tuân will deliver next is rather important to us on how to get high quality impact journals, papers or publications, etc.
May I have a question?
Yes.
Yeah. Thank you very much, Professor Quang Ha, and I'm very interested in your makers. So in the in the six factor here, I mean, if we can say this is a 6 factors for enjoy PhD course or postdoc or something like that. So which one is the most important in your 6 factor you presenting here?
You can say right away. It is the most tedious stage in your life. You need to work.
Yes.
I'm sorry to say that. You need to work. You need to put all the effort. Make a difference. Just that.
Yes.
But on the way, of course, we always not all just work. Need to relax and need to have a plan B. A lot of time in my life, I take plan B. And we talked during the organization of this workshop with Hidden. In fact, we are here on a plan B with a link because it doesn't work.
Yes.
Simple.
Yes, I agree.
I think I like the last thing with passion. I think the only thing that keeps us doing what we're doing is actually one word: passion. Passion. Nothing will be done.
Passion. But passion is from Pavlov. Yes, of course, passion.
Yes, I think that's.
Yeah, thanks a lot, everyone. I hope that you enjoy my kind of. I try to get you from the serious thing of all the energy converter or infrastructure or whatsoever or COVID. Okay, let's meditate and let's have some passion. Okay, so the next talk I would introduce again Professor Tuân Nguyen. He has too many feathers on his head, too crowded. Of course, so each word from him would be a lecture for us all. But most of all, as Chị Lê Thủy asked me, effort to make perfect, to make yes. difference. And we need effort, but we also need recognition. In order to have a recognition, we need to listen to Professor Tuân Nguyen in how to get published in high impact journals. Okay.
Okay, thank you, Quang. Thanks again, for having me here. And in the next, 40 minutes. All right. in the next 40 minutes. Also, I just want to share with you some of my personal experience in getting data published in high impact journals. So this is something really, have been very passionate about. I don't know whether you realize that, more than 10 years ago, when I went back to Vietnam, to give various lectures, the first thing, I want to emphasize to them was to get some very basic skill like scientific writing and scientific publication. And over the years, and I turned that into a book, which has been highly receptive in Vietnam publication arena. So, but I don't have enough time, to tell you every section of the paper. I only have time to share with you what factors that make a correct paper, and I will tell you a little bit what do I mean by a correct paper. I will talk about the IMRAD structure. IMRAD structure meaning introduction, methods, for result and discussion. And I come up with a number of principles of how to write each of those sections. And finally, I will talk about the selection of journals that may be appropriate, for your data or for your research, and a little bit about the ethics of publication. I said to you earlier that these are all my personal experience because I have served as editors and associate editors of many journals, medical journals around the world. Some of them are #1 journals. I also review for Nature sometimes, not always, sometimes. I review for New England Journal of Medicine, JAMA. So all of those high-profile journals, I know them all. I publish there too. So that's why I just said that is my personal experience. Now, you probably have seen or heard this statement by Francis Darwin. He said that inside the credit goes to the man who convinced the world, not to the man whom the idea comes first. Now, this one's very important. You may be the one who comes first with the idea, but if you are not able to convince the world about the worthy of your idea, meaning that if you have not published, your idea, then someone will come along and pick up the idea, and then you will sort of receive into the back of the stage. So it's very important that you got you got the credit that you deserve for by publishing your works. I think about this segment a lot, and I feel very convincing that this is always true. Now, each of you, including me, I suppose, we always have a dream. I have a dream here. So she, here she looks nice. She has a dream. And she has a dream that, she wants to publish her data or her research in Nature, in Science, Cell, PNAS, not a big time journal these days, but in the old days was a big time journal. BMJ, if you work in medicine, BMJ, JAMA, Lancet, New England Journal of Medicine, Journal of Internal Medicine, and so on. All of these things are the big time journals. If you like, there's a high impact journals. We always, have a dream to publish data in this journal. I have to tell you that, one important thing about the type of journal that you want to publish. I serve as a review panel for the National Health and Medical Research Council in Australia. And every year, our panel have to review thousands of applications for a fellowship, very prestigious fellowship. And the rate of success is about, this year is about 5% to 7%. And, sometimes you see that, people, they have, a list of 100 of publications, but they fail. Sometimes, you see candidates which are only 2 or 3 publications. I'm talking about 3 publications.
Is there a problem with the microphone? Or? Hello? Professor Tung?
What happened with him? He may
Hello?
Hello, can someone hear? Can someone reply?
Yes, we can hear you, Professor.
Can you hear me?
Yes, we can.
Yes, so the problem is not from us, perhaps from his side, I think.
Yes.
Yeah, I can hear you. So yeah.
Let me call him privately to see what happened over there. Okay.
Yeah. So I think the system is fine. Yeah. Okay.
Yeah, I just called him. He said he's back now because of his network connection. So yeah, take a deep breath. Yeah, and meanwhile, I think I like to introduce that we will have a connection from the UK. Professor Yiltung later on. He's here. So yeah, while we are waiting, I think Professor Tuấn, let me check again to whether he is reconnect with the network or not. There is a kind of a technical problem from Professor Tuân home computer. Wow. May I take the opportunity to just foster the discussion if you have something? It is a very good timing to, to talk to each other while we waiting for Professor Tuân to show in this Zoom link. While we are here, I just introduced you to Professor Trung Yuan from Belfast. Hello, Professor Yuan. Can you say hello to everyone?
Yes, good morning, everyone. Good morning, Europe, and good afternoon in Vietnam, and I think in Australia. Yeah,
yeah.
Welcome. Yes.
Yes. Okay. Again, we waited for Professor Tuân to reconnect. So may I ask if you have any questions regarding the follow-up, or you have anything to want to raise here while we are waiting for again to listen to Professor Tuân's talk.
Yeah.
Professor Quang Ham, perhaps you can share with us more about the ways in the talk.
Yes, now.
Okay.
Back to work. Thanks, Anton.
Yeah, I'm sorry. I'm truly sorry. You know, I don't know why, they kicked me out of the system. Okay.
The network, not us, of course.
Yeah. It's about the internet connection problem.
Yeah. So I hope that you can share screen now.
Okay. Let me start. You know, when you start up the computer, it takes some time for us to
I know.
Okay, here we go. Oh dear. Yeah, I'm sorry. That's correct. So
yeah.
I thought, last time, in the last time, I talked until here. What I'm trying to say is each of us, have a dream. And our dream is that, we want our data to be published in some of these profile journals. And if you work in the area of science, then, Nature, Science, Cell, PNAS are the venue of choice. But if you work in medical science and medicine, we are talking about BMJs and JAMA Lancet, New England Journal of Medicine. We're aware of that. And I said to you that, I serve as a review panel for the National Health and Medical Research Council. And we always, look at the journals, that candidates, they publish. So sometimes you can publish 100 papers, but if it's not in the right journal, not in the impact journal, then it's very unlikely to get the scholarship. So what do I mean a great paper? To me, a great paper is made it consists of two components. One is about size, and the other is about presentation. And I'm not sure whether which one is more important than which one. I probably put them in the equal weight. When I'm talking about great size, I mean the originality of the paper and the impact of the idea or the data that it has impact on the field of research. And when I'm talking about great presentation, I mean the 3C. 3C, the first C is about coherence, which refers to the logical structure of the paper. The second C is about clarity. Clarity is here, I mean the grammatical syntax and the choice of words, that make, the paper look good. And the third C is about convincing. Convincing here, I refer to the style and the accuracy of your writing. I think inside it's very important, to emphasize the idea of accuracy. Style, I'm not sure, I have my own style of writing, but I do not want people, to follow me. But accuracy is something that we cannot ignore. When I was the editor of the JBMR, it's like the #1 journal in the field. I always ask myself a question, whether this particular manuscript is publishable. And when I said publishable, I always, ask, that question, and then, I match with the two criteria. First is about the quality of presentation. That means the quality of the manuscript and the quality of size. So if you put them into this two-dimensional, then there's no doubt that those papers that have a great quality of size and a wonderful presentation, then that must be publishable. And on the other side, those studies with the low quality and the presentation was terrible, that's not publishable. Most of the paper, by the way, is not in these two extremes, but they are somewhere here in the gray area. And when they're in the gray area, every detail, of the paper, of the manuscript will count. And I think that is something, you should pay attention to, when you write up your paper. When I review for New England Journal of Medicine, the editor-in-chief asked me this question: do you see the paper that have the wow factor? Right? You read the paper, you read the manuscript, and then you say, wow, that is amazing. That is something I never thought of. And that is really clever. And that is the wow factor. And that is what I mean by good size. And the wow factor here can be translated into whether the topic is interesting or important, whether the big issue is addressed by the paper, and whether the works will provide an advancement toward a solution of the big issue that we are facing on. For example, if you write a paper about COVID-19, right? And obviously this is a very interesting issue. It's a big issue in the field. And if you have a wonderful idea about modeling or about vaccine, I'm sure you will more likely to have a wow factor. And that is something you should always ask yourself: is your paper has a wow factor? So a great paper, again, is the paper that tells a story. And the story is based on the content, which includes the structure and the coherence and the writing, the 3C writing, with the clarity, and clarity. And I'm sure, if you can achieve those two components, you will have a great story, which in turn to make a great paper. Now, how to write the paper? Well, you know that the paper is made up of the title, the abstract, the introduction, the method, the result, and the discussion. Now, how do you write these things? I mean, each of these lectures, probably takes about 1 hour, and we do not have time to talk about that. So I will go through with you very briefly. So this is the so-called IMRAD structure of a scientific paper. IMRAD, the I here refers to introduction, M for methods, result, R for result, and D for discussion. But apart from those key sections, you also have the abstract, the title, the references, and the acknowledgements. So in the title and the acknowledgement and reference, something people don't normally pay attention to that. So that is something I would like to share with you about how to write a good paper, a good title. So there are 3 types of title, by the way. The first type title, we call it decoration or decorative. Essentially, that title convey a simple message of the paper. For example, smoking is associated with increased risk of death. That is a very simple title, goes straight to the point. And, you know, when people read it, they say, wow, you know, this is a confirmative, this is affirmative, you know, this is wonderful. And people tend to remember that. And there's a second type of title, we call it descriptive title. A descriptive title is really a neutral statement about the study subjects. For example, the worldwide distribution of human chromosome X. This is a neutral title. It doesn't tell you the key finding of the paper. It just says the paper is on about. And the third type of title is called the interrogative title, which by the name, as you can see, is referred to the question type. And it tends to appeal to curiosity. For example, the title is estrogen bad for heart? And obviously, you know, when you read this, wow, yeah, that's a very curious. So we better have a look on that. Now, each of these title, you know, have two subtitle. The one with the one part, which is a one sentence, and the one with the two parts, you know, separate by a colon. And that also allows the author to convey more important information on the methodologies. So there are 5 principles of writing the title. Number 1, you have to have the title that conveys the main message or the key information. Number 2, you should start with the important words, right? If you write a title, the first thing is important words. Why is it? Because, you know, people tend to remember with the first word that you say. The third principle, you should mention about the methodologies. Because of the paper, if you think about it, it's all about idea and methodologies. And people would like to learn about that. If you do a study, if you run a randomized clinical trials, then you should mention that, you know, in the title. And it should have a keywords. Now, this is very important because people tend to search the paper through the keywords. So you should have some keywords and people key in and they say, wow, you know, then they will capture the paper that you author. And the fifth principle is it should be informative. It shouldn't be a general sort of a statement. You know, it should be informative, meaning that it got some information, something that, you know, people can remember. And I can tell you that, you know, a lot of people, when they write up the paper, they never thought of the principles of writing a title. And as a result, you know, they do not catch the attention of the editors. People like me, you know, I'm very busy. I don't have time to read your full paper. I only have time to read your title and the abstract. That's all I have time. And you know, if I think it's interesting, you know, I will send to send to reviewers, you know, within the journal. I don't have time to read your full paper. And it's very important to get the attention of the editor by follow this principle. Now, what about the abstract? Well, the abstract, as you know, is the overview of the main story. So your paper may have, you know, 3,000 or 4,000 words, but the abstract has only 100 to 300 words. And in the abstract, because you have a very limited number of words, so you have to emphasize the key points of the paper. And now there's one thing, you know, I should mention to you that the abstract is an independent part of the paper. That means I don't need to read your full paper. I only read the abstract, and you know, I know what the paper is all about. And if you write the abstract and you don't have a key information or key message, then I'm sure you know, that you fail most of the authors, you fail most of the reviewers as well. So the abstract is a very important part of the paper, and you should pay attention to write it. And it's very difficult to write, you know, 300 words, right? And sometimes you have to invest probably about 1 week, you know, to have a good abstract. Now there are 2 types of abstract. One we call it structured abstract, you know, where you have a subtitles like background and study setting, subject, and there's another one called the unstructured abstract. Unstructured abstract is only a single paragraph but still, written in the structure of the subtitle that I showed earlier here. So it depends very much on the journal, whether they want you to write as a structure or unstructured abstract that you have to follow. Now, I have a number of principles for you to write in, for writing an abstract, and I call it NICES. The first, when you write the abstract, you should emphasize the novelty of the paper, the new things, the new methodology, the new finding, new interpretation, new study design, whatever. You have to have something new in the abstract. People love, new things. People don't like to read to be too stuck, right? So that's a very important one. The second principle is that you should emphasize the importance. Remember, I told you, one of the key components that define what is a great paper is the importance. When I read the abstract, I see, wow, this is an important word. Emphasize that. Number 3, about clarity. Because you have only 100 to 300 words, to describe your work. Imagine that you write a poem, only 300 words. So you have to write in a very succinct way. Succinct is in terms of the word choice, in terms of the sentence constructions, in terms of style, you don't write, the redundant word, for example. And you must have evidence. So anything you claim, any major claim in the paper must be backed up by evidence. And when I say evidence, I mean the data or some sort of key findings, that you can that you can quantify. And obviously you have to be short because you have only maximum 300 words, to convey your message. So those are 5 principles for writing an abstract. If I have time, I will elaborate more on this one. Now, apart from that, let's go to the main section of the paper. And the first section is the introduction section. So if you think about your infrastructure, this is the structure. So you start off with the introduction, and then you end up with the discussion, and in between you have the methods and the result. You see the size and the shape of each of these sections have a certain meaning, right? So in the introduction, you have to explain why did you do this study, right? And the way you write the introduction is that you go from the general to the specific. That is a very important point. You start off with the big picture of the problem, and then you narrow down into the issue that you investigate. And that's why it's got this sort of structure, right? So from general to specific. And what is the strategy of writing introduction? I come up with a strategy, I call it CARS. Well, car here doesn't mean car, right? Doesn't mean auto, right? Doesn't mean CARS here stand for creating a research space. Right? So first, you need to create a situation, right? So what do I mean by creating a new situation? You have to ask, what is the big issue now? For example, the big issue is how to control the pandemic. That's a big issue. Then why the issue is important? Well, because it kills a lot of people. And it affects a lot of people in the world. And what is the current knowledge? So that's when you create the situation, right? And then after you creating a situation, now you start creating a need for you. All right, so now it's your turn. And then you say, you're okay, this is a big issue, this is important, but there is a gap in knowledge. The gap in knowledge may be due to the fact there's a lack of data. Maybe the data is not up to date. Maybe it's a controversial viewpoint. Maybe because of the novel methods have not been applied. Right? So all of these things, you create a niche for you. That is something for you. You are the one who identify the problem. And then the next thing, you occupy the niche. You occupy the niche. What do I mean by occupy the niche? I mean, after you identify a problem, the next thing is that you set a test-table hypothesis. It's a very important test-table hypothesis. By setting the research question, And then, you go to the specific M1, M1, and 2, 3, what you're going to address. And this creating a research space or the CAR strategy is a very important thing, And I found that a lot of people, they tend to ignore this one. They write a lot, and as a result, we have no idea what are they writing. So next time, when you write the introduction, you just simply follow this one. And then the next thing about the mid-text section. In the mid-text section, you explain what and how did you do the study. And by doing that, why the meta section is important, because most of the manuscripts, and here is the study that they published somewhere in the journal Tourism Research. They look at the number of manuscripts and then the reason why they rejected those manuscripts. And here you see, 74% of the manuscript was rejected because of deficiencies in terms of methodologies. You see how important it is? 60% were rejected due to the fact that it's not important. The writing style also, accounted for a fairly sizable rejected manuscript. So methodology is the number one reason why your manuscript is rejected, and that's why you should consider you should be focused heavily in the introduction. Now, the principle of writing the meta section is that you should ensure the internal and the external validity of the paper. The internal validity refers to the methodology, the techniques of measurement, and the state of the art of the method that you apply in your study. The external validity, meaning that whether your data can be generalized in the external or independent setting. So when you write the method section, you should focus on the internal and external validity so that people, who can relate your finding in their own setting. You should ensure the reproducibility. This is a very important one because why? 95% of the published findings are not reproducible. This is a major crisis of science. Can you believe it? 95% of publications are not reproducible. So what are we doing here? We done something wrong. Obviously, a lot of us, we done a lot of things wrong anyway. So, and why it's not reproducible? Because there are no computer codes. Because the way they describe is inadequate. Because the measurement was a flaw or broken out, whatever. And reproducibility is an issue that each of us, you and me, have to ensure that our data and our findings are reproducible. Meaning that you have to describe your methods in a way that people can reproduce your study. Hopefully, they can reproduce your finding. And you have to provide evidence for your methodologies if you apply in your paper and the accuracy of the methods. Now, so what you want to write in the method section? Well, it's very much depend on the nature of your research.
Professor Tuấn, maybe.
Yes. Hello.
You are Mu, Professor Quang Ha.
Professor Tuấn, may I interrupt? Maybe you can just shorten a little bit because.
All right.
The business, okay.
All right.
Thanks a lot.
Yeah. Okay. So right in the middle section. So here, you are talking about experimental design, procedure of your research, the participants on the material, data collection, definition of outcome, sample size, and data analysis. After the meta section, you write the result. The result section essentially report what did you find, and what did you find can be presented in terms of text, or figure, or table, and a photo. All of these things, relevant to my research anyway. And the research section, there's something that you should not do and something that you should do. The thing that you should do, you should put the data in context, in subheading, using subheading. Stick to the short and straight to the point, report the direction of the relationship, and the magnitude of effect if possible. You should use past tense, not present tense. Use active voice. You should not do the thing you should not do, including repeating data in the table or figures. You should not report trivial details. You should not give a list of data that do not tell anything. You should not use table and figure for simple data. Now, in the discussion section, you have to discuss what do the findings mean. And this is a very important section. Why it's important? Because it represents the brain. It represents the brain of the paper. This is your intellectual contribution to the literature. Very difficult to write the discussion section, And over the years, I come up with a formula 6 point in the discussion section. Number 1, you start off the discussion by summarizing your study rationale and key findings. You compare your finding with the previous finding in the literature. You elaborate the mechanism or explain, why you found that. You generalize or you give them the implication in the field. You give them a strength. You talk about strengths and the weaknesses of the study, and then you go to the conclusion or the bottom line. Imagine that you look people in the eyes and you tell them honestly about what you found and what do they mean. So you may ask me, so what is the order of writing? Well, my style is that I start off with the result section. I write the result section first. I will sit down with the coffee table and write, sort out the table and the figures, and then I go to the method, the discussion, the introduction, the abstract, and then finally, I know what the message is. Then I write the title in the end. Now the journal selection and the ethics of publications. One of the things I love about Michael Faraday is that he said the secret is comprised in 3 words: work, finish, and publish. So you have the data, you should publish, and the publish, you should publish in a reputable journals. I don't know whether you realize that, the world's first and longest journal is this one, the Philosophical Transaction of the Royal Society. It was first published in 1665 and still going on. And so you may ask, so what are the journals for? People ask me that all the time. To me, the journals is a forum for knowledge exchange, is a venue for you to register your scientific works. It certifies your works as well. And it's a permanent record of a scientific evidence, which is very important for clinical practice and other policy developments. There are 2 types of business models. Number 1 is the journal belongs to a professional society. The other one is a commercial. If it's a professional society journal like BMJ or AJH or Econometrica, they normally created by, as you can see, professional society, and it's managed by a publication committee. It got an editorial board, a very good one, and it's published by a legitimate publisher. For the commercial journal, Nature and Nature Communication, all of those things are commercial journal. They do not really have an editorial board. You're probably surprised that Nature do not have an editorial board, right? You may ask me why, but anyway, we will discuss about that. So what is a legitimate publisher? Well, I suppose Springer, Nature, Elsevier, a lot of people, boycott Elsevier these days, Wiley, Tyler Francis says, and so on. There are more than 100,000 journals in the world, but most of them are not recognized. Only 24 or 25,000 of them are recognized. Recognized here means that, they are indexed in the Web of Science, Scopus, PubMed, or ESCI. And here is the table show you about the number of active journals. I don't know about PubMed and ESCI, but I know that Scopus has about 24,000 journals. Web of Science a little bit more selective with 20,000 journals, but the number of predatory journals here, you can see, is still quite a few, for Scopus. The Web of Science has about 20, more maybe less than 20 predatory journals. But for the early emerging SCI, there's 100 of predatory journals. Now there are 2 types of open access. Green open access, no peer review, you just post it there, and then just like a register of your work. Go open access, like a Nature Communication, there's a peer review, you have to pay fee. Last year, I had to pay $5,000 for one article well, I don't want to tell you the journal. It's very expensive. And there are major players in this golden open access mode, including PLOS and Biomedical Center. Now, I want to talk to you a little bit about predatory journals. You know, the name of the predatory journal was actually wanted by Jeffrey Bill. He was an academic librarian of the University of Denver, and he showed, you know, a number of major characteristics of a predatory journal. They normally mimic, you know, the reputable journals. They have a very broad scope, no editorial board, very aggressive through email, you know, for paper submission, no true peer review, poor quality, English is terrible, turnarounds only 1 to 4 weeks, and the country publication normally from Africa and some of them from Asia. There are more than 50,000 predatory journals in the world. Can you believe that? And they publish more than 4,000 papers. And so it is a very, very big market. And I know that a lot of our colleagues in Vietnam have fallen into the trap of predatory journal. Can you imagine that, you know, this particular paper, there has only one sentence that repeats, you know, about 400 times, and it got accepted for publication in this journal. Anyway, and then there's another one, you know, there's another paper on the hydroxychloroquine, you know, to a unique solution for COVID, which is a terrible paper anyway, which also got published. Anyway, so in this sort of market or environment, you know, how do you select a journal? Well, to me, you know, you should focus, you should ask yourself whether your paper in a narrow area, larger area, discipline or field or science. If your paper have a great impact on the science, then I would go for Nature and Science. If your paper have an impact on your discipline, you go to your discipline paper. In my discipline is endocrinology. If my paper have a major impact, you know, for GP, you know, you go to medicine, for example. So you have your research, you know, it's about national and international implication. Then you go for a big time journal. If you
Professor Tung, probably you may continue in the forum.
Oh, okay. I finished now. Now. So the criteria for journal selection, firstly, you go for readership, the visibility of the paper, of the journal, and the practice of the journal. And if, you know, you can check yourself on these criteria I listed here, then, you know, you should be able to publish in an appropriate journal in your field. Oh, and that's all I want to share with you. Again, you know, I just want to thank, you know,
thank you very much, Professor Tung. Thank you very much. Very exciting. And the topic is endless. The topic is endless. The topic will be continued in the forum. Now, take the power of the chair to invite Professor Trung Yuan. He got, again, too many feathers on his head. Chair Professor in Telecommunications, Research Chair of Royal Academy of Engineering, Research Fellow Chair, Research Fellow of Royal Academy of Engineering. These are three already gave us some very much appreciation for his honors. Okay, he today will talk about unmanned aerial vehicle assisted disaster emergency communications. Professor Young, please welcome Professor Young.
Thank you, Professor Wang, for the introduction. So everyone, can you listen to my voice clearly and see the slide? Yes, it's a great pleasure for me to be here today, especially we have so many big names from Vietnam overseas, especially to see some old friends like Professor Tung. We met many times in Vietnam, but because of the pandemic, we couldn't have time to visit Vietnam and meet again. So this is kind of the forum to exchange the idea and get to know each other. So today's my talk is a bit different. I think it's more like in the wireless communication. So I will try to explain to you why Professor Tung worked this out during his talk, but maybe not in very technical detail, because I know we have a lot of different audience from many different disciplinaries. So let's bear with me and apologize for some equation in the slide. So before we start the main talk, I want to explain to you what is wireless technology. and how it can help to improve the life of the human being. When we had the first mobile phone like 50, 60 years ago, and the 5G has already started to roll out in 2020. And nowadays, everywhere, everyone we can hear about how the wireless technology can really shaping the planet. So coincident, every 10 years, the wireless technology, the mobile phone, they change the generation. So 2 years ago, we have already 5G technology. So it stands for 5th generation of the mobile wireless. And we believe that the next 10 years, by the year 2030, we're going to have a new generation like 6G. So no one decided why the generation of mobile wireless changing. It's just because the demands of society and the human. But we have so many problems because of whenever we change technology from one to another, they have so many things, different in terms of the demand, the number of device, or the numbers of requirement. For example, just compare the last 10 years, the 4th generation and the 5th generation. In terms of number of devices, we have already 50 billion devices connected to the internet. And the population in the world, we have only like nearly 7 billion. So every citizen in the world possesses around more than 7 devices. So it's a big number. However, the mobile phone industry already hit the limits. So the CNN already said that the wireless technology is running out of the airways. That can provide some simple demand like voice, text, and internet service for the customer. And for the next generation of wireless, the real problem is not the speed or not the data rate. The more important thing is the latency. So we can see that sometimes during the call, like this kind of video meeting, we have people kick out of the call. We have people had the delay. Sometimes we cannot understand what people say, and sometimes even the voice come later. So that is the problem with the wireless. It's not the data rate, but more on that. It's more like latency and the reliability. So I want to talk about a little bit about futuristic, research of this kind of very exciting topic. Let's say 6G. So let's say what's going to happen in the next 10 years, right? So in terms of the number of connected device, I already showed you the previous slide. We're going to have like each citizen in the world has 7 devices connected internet. But the next 3 years, by the year 2025, the number of the device connected internet going to be 100 billion. So it's going to double only just to 3 or 5 years. But that's not a scary thing. The most important thing is the mission critical communication, where we have so many different kind of new applications that require not just the high data rate, but only the reliability and the very low latency. So what I want to emphasize here, the reliability is here. Say you send 1 billion packets or 1 billion bits, you're only allowed to get 1 bit error. So if you had 2 errors, that's gone. The whole thing is corrupted, right? And the latency is 1 millisecond. So I have to explain to you how short in 1 millisecond is. If we had the image and our human brain, want to process the image, we take around 10 milliseconds for the human eye to observe the image, right? So it's even 10 times shorter than the human processing. And nowadays, because of this low latency, the wireless technology can provide us. We have so many applications. For example, during the pandemic, we can have a lot of live video, live concert. Even people some different people from different country can play the live music together, and it's worked really well. So thanks to the wireless technologies. So today I want to emphasize the 2 main things. That is my main target for the research for the next 5 years. So again, the most important thing is for wireless technology is not just the high data rate, but also other critical mission application. So ultra reliability and zero latency is the the two opposing target. So on the one hand, you want to increase the reliability, but when you increase the reliability, you have to sacrifice your latency, right? So this is difficult, very difficult quality of service constraint, and as one of the biggest problem nowadays during especially with the number of devices increase, and we have a massive number of IoT devices connected, require this ultra reliability and zero latency. So for 6G, we expect that it's going to have huge impact on the society. It's going to have a lot of application in industrial Internet of Things, intelligent transportation, healthcare. So for example, we will, doctor sitting in different city, different location can perform telesurgery, and to have some hospital in maybe isolated area can have some victim and some patient, and it can be applied to the education, entertainment, also apply many field like environment, smart city, and so on. One of the my current research to apply for 6G is using the UAV, and UAV is one of very long traditional research topic, and it's having applied so many fields. For example, civilian search rescue. Nowadays, because of the development of hardware, UAV can become mobile data center, so they can carry like a small server, small computing devices. They can supply and serve so many IoT devices, sensor in the field. It can be applied to smart agriculture and many different other fields. And also, Amazon DSA already use drone to deliver parcel. It can save a lot of time, can save the cost as well. And one of the very important application of UAV during the pandemic is, the law enforcement use UAV to disperse crowd, to announce some emergency announcement, and it's being used for many countries in Australia, in US, in UK, China, France, or Italy, and so on. So, however, for me, as the researcher in the field of mobile wireless communication, UAV, I think the more important thing is can be become the temporary base station to provide the network for some kind of mission critical service. For example, if you have a disaster scenario when you want to find victims, to help people, and normally after the disaster you don't have the connection, you don't have the network supply. Now it's very hard to find people. So using drone become the temporary base station that provide the network for the areas would be very helpful. So you remember, like a few years ago, Facebook, they first launched the app of safe mode. Remember when we had the earthquake in Nepal, and whenever nowadays we had the disaster scenario, Facebook again they launched the safe mode, so people can check whether they're safe or not. But like a few years ago in Nepal, when the earthquake happened, the safe mode of Facebook doesn't work. It didn't work because we don't have the network. Of course, when we had disaster, the network already knocked down. So people, even they have safe mode in Facebook, they cannot connect to Facebook to check whether they're safe or not. So that is the biggest problem, right? So nowadays, already the technology develops so much, and you can see that we can one of the state of the art of the UAV to serve at the connection for the mobile wireless has been already in the air. So we have the 30 aircraft. These are one of the current most state of the art. They use the solar power, and they can fly in the stratosphere. We had a commercial flight about maybe 20 kilometers from the ground, but this is even higher than that level to avoid any collision with the commercial flight. And they can provide up to connection to 700 kilometers, and with the speed about 1 gigabit per second, which is exactly the same with the 5G speed. So that is one of the I think the future of the wireless communication. However, this is very, very expensive. If you look at the UAV, this UAV, I think the wing already 30-40 meters long, and the cost would be hundreds of millions US. So if you talk about this application to the developing country like Vietnam, I don't think it's going to be applicable because it's so expensive, and especially under the bad weather condition, it's not going to work. So what can we do in this scenario, especially Vietnam? We heard so almost every month we had disaster, we have flooding, we have storm. How can we help people? Because in rescue mission, the first 24 hours and I think the first 72 hours is very important to find people. After 72 hours, it's almost impossible to save life, right? So if you don't have the network connection, it's very hard, especially when we had the disaster. The number of calls become even higher and higher because they have a friend, relative to want to check whether the loved one is safe or not. So number of calls, the congestion become even higher and higher. So that is the biggest problem for the people working in this field. So back to our research in disaster communication, we already deploy our equipment and technology in Vietnam almost I think for 6 to 7 years, and it's worked quite well in several locations in Vietnam, especially in the central Vietnam, where we had the disaster happen almost every year. So here is some of the equipment that we deploy in the river we call Vu Gia Thu Bo in Quang Nam province. We had one of the I can say the most crowded area in Vietnam in terms of hydro power electricity. We have around 100 of this kind of electricity power plant. It's really a big problem whenever they had the storm or they had the raining during this area. All these power plants, they release the water, and it's called a big problem for the people living in downstream. And the research we have deployed has been, I think, very helpful for the local people. But the problem is the natural disaster in this region is really severe. So you can see in the picture, 1 year when we go back, one of our station had been knocked out because the previous year the flood is too high. And also we already provide very concrete platform for the hydrometeorological station, but because this kind of severe disaster, it has gone. So the idea is here we are thinking whether we can provide an additional level of protection for the people, whether we have another scheme that can help instead of put the fish station down the stream, down the river, stay there and can be knocked out by the flood. Is there any other option? And that's the answer would be yes, we have the UAV. And the idea we're gonna think is we're gonna have some kind of compact solution we can provide from the field to up to the locals and official, that they can provide more information for the citizen, and that we call smart digital platform. We have 4 layers. We can have the sensor, the device on the field. We can have the UAV to collect the data, send back the information to the station. That we had some kind of expert to process the data, and after we have the information, we can provide to the government, to the hospital, even to the law enforcement, that they can, provide that urgent information to the end user, the people. And here, the reason is I already mentioned that UAV is quite expensive, right? It's very expensive actually. So we cannot use such expensive UAV for this kind of mission because it's not applicable to many countries. So, for example, how to use low-cost drone to serve in this scenario. When I'm talking about low-cost drone, it's going to be cost like a few $1,000 US. And for this kind of drone, they has many disadvantages. For example, they have short battery, they have a short bandwidth, they have not really good the trajectory movement and so thing and things like that. So how can you use this drone operate in the field to help? And that is, I think this is a very good research direction, and this is one of the main topic that we are working on. So here I'm gonna go to the main talk, and I did already published in our paper, so I won't explain any equation, but I just want to give you some concept overview and the concept of how it's works. So let's say we have a group of people sitting in the area that hit by the earthquake or flood, and they need really important information to help them, like send the food, send supply, or even evacuate them immediately. And the problem, we don't have the wireless connection, we don't have the Wi-Fi, we don't have internet. So we send the drone on the area, acting at the flying base station, provide the temporary network for the people. in the disaster area, and they can connect back to the let's say the safe area, non-disaster area. We had hospital, we had police station, and so on. So the thing is how we can use drone in the better way, because we have very limited number of drones. They are so expensive. We want to use as small number of drones as possible. And the more important thing is the time, the critical time. How can you deploy the drone quickly, provide the network immediately, so that you can provide the Wi-Fi for the people in the disaster area. If your algorithm is maybe take an hour to run, it's already too late, right? So we come up with the idea whether we use distributed algorithm or centralized algorithm. So for the distributed algorithm, you can use each drone at the server, like I already mentioned. They can become the data center, or you can use centralized. You can move on the data up to the cloud, and the cloud can run at the algorithm and send back the result for you. So they have two options, and we can see which one will be better. So here the main optimization problem is, please apologize for the equation. Don't worry about that. So we have the objective function. You want to optimize the energy efficiency, which is the ratio of the maximum data rate of the whole network, and the limited power you have at the drone. Okay, this is a very critical factor you want to optimize. And on top of that, you have so many constraints, like you have operating type, the UAV. You have the minimum number of power in terms of the power of UAV. You have the POS requirement of the user under the ground, because if you don't have the POS requirement, the user cannot connect, right? And how you can use a minimum number of UAV. So there's so many constraints, and this problem is very highly complex optimization problem. For a large scale scenario, I don't think we have any solution. So that is the main challenge for this research. And first of all, clearly we had to break down this kind of complicated optimization problem into sub-problem to solve. And the first sub-problem I want to say, we're gonna optimize the drone. First, when we had the drone on the field, then you can optimize the power, or you can optimize the bandwidth based on the requirement of the network. And here we again, don't worry about the equation. We're gonna use several algorithms to optimize the drone to send the drone immediately on the field to serve the user. That, for example, the first one we use K-means clustering. This is one of unsupervised learning, machine learning technique. And then after we can deploy the drone on the field, we can apply two algorithms. As I mentioned earlier, the one is centralized, which is the cloud computing. It's a centralized cloud. They can use on the data we have to run the algorithm optimization. And another, I think, would be more reliable and can save a lot of time in terms of running algorithm, is the distributed resource allocation, where we have a drone can carry we can say computing platform to run the algorithm, the old algorithm. They want to optimize their own networks. You can say small network, small cell network, so that you can provide at least a certain amount of the requirement for the user under the ground. So here, this is the first picture I want to solve. So assume in this simulation, we have 10 UAV, but of course, if you want to send 10 UAV on the field, would be very waste of resource. So what is the minimum number of UAV to cover on the user in the area, right? And here, after running the algorithm, the question is, we have only, we can only need to use a UAV, which is really good solution, because we can save another two for other scenario. So here I want to compare the optimization provided algorithm with many other platform serving as the benchmark. So just ignore some kind of the abbreviation of the word. Here, the first figure you can see is the first slide. For example, this is the optimization we propose, the energy efficiency for centralized, and clearly this is the best one, because we already take into account on the requirement of the network, and compare with many other benchmarks like eco power allocation or eco time transferring. Our consider scheme really outperform and provide much gain. Many see other benchmark really below the proposed scheme. And this one of the interesting to show here, we consider one of the fundamental problem in the disaster area. Although you can optimize the whole network, but there are some user, we call it the worst user. they are really vulnerable. They really need to have a good connection, but because of the condition, maybe they're under some kind of shadowing, in some kind of underground, they cannot connect, and the data they have is really bad. So we provide to you another scheme we call QoS, centralized energy efficiency, and compare with other scheme. You can see on the right hand side the figure, the yellow figure, the QoS, the worst user, it really provide that kind of service. So instead of maximize the whole network, which you can sometimes ignore some most vulnerable user, and that can cause death, and that is a very, very critical scenario in this optimization problem. So QoS proposed scheme really can overcome this kind of challenge. So one of the final figure I want to show is the comparison between the centralized and the distributed. So here, the centralized, you can see both figure is the solid line, and the distributed one is the dashed line. So clearly, the centralized, which is sold by the cloud, much better than the distributed. So the question is why we have to use the distributed one? The distributed means the optimization is running by the UAV, not by the cloud. The answer is going to be here in this figure. So this figure will answer you how long to run your algorithm, right? First, for centralized, you can see the third column. Running the central algorithm, it takes you 25 seconds. However, the next column, the fourth column, in order to run the distributed one, it only takes less than 0.5 seconds. It means 50 times shorter than the central line, right? So the answer to use the advantage distributed over the centralized is that we can have much shorter times. It means you can really deploy the drone quicker in the field, especially when you have a larger number of drone or larger number of user. The distributed scheme is more favorable than the centralized scheme. All right. So I don't have much time for the other slide, but before I conclude my talk today, I want to show you one slide of the Professor Andrea Goldsmith from Princeton when she had the keynote about a month ago at the GlobalCom 2021, which is the biggest conference in the field of wireless communication, telecommunication, and she had very scary, I can say scary 5 bullet points. They say wireless is no longer a hot field. It means actually, and I agree with her, in the field wireless communication is already crowded, it's already saturated. The technology has been there for many years, and actually to come up something new is very difficult. However, before we close the talk and before we answer her slide, let me show you some of history and I can say the future story. So like 60 years ago, 70 years ago, one is this waiver in US mentioned that people can carry the phone in the pocket, and at that time people were laughing. No one believed that, but actually at the moment nowadays we all have the phone in our pocket. We even have more than one phone in our pocket, right? So we have watched a lot of Hollywood movie about flying car in the city. This is not science fiction. I don't think I think gonna become real in future, but I don't know when. But I think to start the research today, it can really make this kind of like science fiction story come true. So this is the end of my talk today, and thank you so much for giving me an opportunity to discuss my research. Thank you.
Thank you, Professor Chung. Thank you so much for your kind of informative and very in-depth kind of aspect of communications using UAV in disaster cases, search and rescue, and especially in emergency. I know that Professor Chung will have another family commitment. He will not stay in here with us. So if you don't mind, I can invite just one simple question to Professor Chung if you have.
Yes. I apologize. I had to take the kid to school, so I cannot stay longer.
I know. It is very important.
Three boys to school.
Okay. Since we don't, so we let the Professor Chung more time and keep safe and driving safe and take care of your children well.
Yeah. Thank you so much,
yeah.
Anh Quang, and thank you. And it's very nice to see you again, Chú Tuấn. Hope to see you soon.
And especially we would like to see Professor Chung in one more kind of event and very soon.
Yeah.
Let him go.
Thank you. Yeah. Bye bye everyone. Thank you
Thank you
so
very
much.
much. Thank you very much.
Bye. Yeah.
Yeah. Okay, so back to us. I think that is on the delivery of the whole program of the workshop. It's now time for us to sit down and starting. We have 30 minutes only for the open forum. Okay, now I have no limitation on the questions you will see around here. So whoever will start first, then please feel free to go ahead. I give you 30 minutes before we close this workshop, and I have something interesting to share at the end. Okay. Sorry, Anton. It's rather because of the pressure. From I need to interrupt you. I know that you have a time, so 5 minutes to squeeze down. Now, around here a lot. Yes,
May I have a question to Professor Tuấn?
Yes.
Yes. I'm very. I would like to thank very much, Professor Tuấn, for your lecture on how to publish on high impact scientific journal. So yes, the very difficult on the way to get the high impact factor journal. In our group, we also luckily we have a paper published in hepatology is a top journal in our field, impact factor 14. So actually we are also very structured in now in my lab. We have 3 students study at the same will be graduated at the same time, and we are now revise manuscripts or submit manuscript. And I'm very interested with the abstract. You say the last part is a short. How to make the short abstract is also very difficult from in my viewpoint. So make the short abstract by writing the short sentence or combine data in the short expression, or because the short abstract, but the attractive abstract is very difficult to write. So how can you say more your suggestion to make the short abstracts?
You know, it's some way very difficult to write an abstract, and that is the reason why I suggest that you write the abstract after you have finished the paper. Because after you finish the paper, you know, you sort of got a pretty good idea of what is the key message, and that key message, you know, should be inscripted, if you like, inscripted in the abstract. So my way of writing normally, you know, in the background and the introduction in the abstract, you have only 2 sentences, only 2. Yes. The first sentence is about the background. The second sentence is about the end. And you probably, you know, have about 3 or 4 sentences in the method section. And in the result section, you should have only 3 or so. You know, focus on the key findings. Forget about those details, you know, I studied in patient 50 years old, you know, range 20 to 70, you know, forget about those details. You know, go straight to the point. Because, you know, you have a research question, so the result should, you know, go back to that research questions. And finally, the conclusion should have maximum 2 sentences. The first sentence is a summary. The second sentence is the implication of your research. And, you know, when you write like that, you know, and then of course, you know, everything requires practice. So, with time, you will master the way to write the abstract. Now, I should mention to you that, I keep saying it all the time, people like me who is the editor of the journal, I don't have time to read your full paper. I never have enough time. I only read your title and your abstract.
Yes.
So if you can pass May, if you got through May, write abstract, you're done. You are 50% there.
Yes.
So it's very important to focus on those two bits of information.
Yes, thank you very much for your sharing. Yes, difficult, very difficult to get the very attractive abstracts. Like you clarify from the novelty to importance to clarity, evident or short. So it's very,
because a high impact, they always look for high impact things. They always ask question, is it a paper or this abstract have a wow factor? Things like, oh my God, they are so clever. I have thought about it. Wow, I think you already win there. But if they read the abstract, they say, oh well, in Vietnamese, we have a saying không. I'm talking in Vietnamese now. Không mở thì chợ vẫn đông. Right? In Vietnamese, we have a saying like that. So if they read your abstract and they say, oh well, whether this study is there or not doesn't make much difference. Then you don't have a chance to publish in the high impact journals.
Yes, and may I have one more question?
Sure.
Yes. So looking at the method section, you said that more than 74% of the paper rejected due to the lacking in the methods writing. I also became the reviewer for some journals. So how do you think about the design, method design, and the control in the negative and positive control and the other case control as a setting in the design of the method section? Is this a very important point to pass the reviewer?
Yes, absolutely. If you remember in the method section, I mentioned about the internal and external validity, right? So that's a two key points in the method section. Now you're talking about positive and negative control. That is about internal validity. You see?
Oh, I see.
And that is where, and that's why you should focus to describe a little bit more details on your controls. And then I mean that is absolutely important. I'm just I'm just related myself to another paper published by a group in Vietnam about the EIER, essay. Right. And when I look at this, I said, oh my God, that doesn't look like a control group to me.
Yes.
And they have a group of people who are suspected to have COVID, and then they said that's a control. I said, well, that doesn't look like control. And that's a reason why they couldn't publish in a high-profile journal. So yes, control is a very important one. It's a part of the internal validity of a study.
Thank you, Professor.
Thank you very much.
Thank you, chị Lệ Thủy from Osaka. Now I would like to invite Professor Quân. How are you?
Yeah, hello. Actually, I've been traveling today and I could not attend the meeting.
Oh, it's okay. It's okay.
Yeah.
You are always busy, director. So you are on your car. So thanks a lot.
Yeah, I'm very sorry. Yeah. So thank you very much, Professor Quang and Professor Tuấn and others for a great event. But just for the discussion, also for now, I just have maybe a small question regarding our last discussion about the COVID-19. So I might ask Professor Tuấn and maybe some others to give your opinions, maybe because you all know the COVID situation now maybe a little bit better here in Vietnam, but we never know what will be happening in the next couple of months or years. So so what you see about this, maybe in terms of, let's say, resilience or sustainability, and maybe also about like what could be the interesting point for research group, for example, a small research group like we have now here. I mean, because small, because we are different ones, we are not really together, so we are more or less small. So what could be the good topic for those group like us can do in the next couple of months? Yeah, thank you.
You know, it's a very interesting questions, and I also ask myself on the time that, you know, what could our college in Vietnam do to contribute to the control of the pandemic? You know, each of us, of course, you know, we can contribute a little bit. You know, from my perspective, you know, I do contribute in terms of the methodological of epidemiologies and methodological modeling and things like that. I guess, you know, in this group, I'm thinking of a kind of a large-scale simulations about the impact, you know, of population density to the incidence of COVID-19. So the question I will ask myself is that imagine that, you know, you have a community with, let's say, 10 million population, like Hanoi or Ho Chi Minh City, and with this sort of interaction that you would expect, you know, have to happen to occur daily, then how can you simulate the interaction at the population scale? You know, the people go to shopping and then talk and coffees and transport, mobility, and so on and so forth. How can you simulate that in terms of very, very large scale interaction among hosts, you know, among people? Then, given the knowledge about the relationship between population density and the risk of infections, can you predict the occurrence of the COVID-19 based on that simulated interaction? You know, when the COVID-19 occurred last year, I was a member of a group, you know, very powerful groups. You know, they do all sorts of fancy simulation. They use all sorts of engineering technique, which I had no idea what's on about. And they also use large-scale computer simulation. And then they can predict, you know, what would happen if we undergo lockdown. What happens if we open, if we, you know, lift up the lockdown. And by that, you know, they influence the policy makers at the national level. So, you know, that's something I'm thinking.
Thanks, that normally when we talk about simulation, there is two ways. The number one is model-based. Probably in this case, I don't think a model will reflect it on the complicated, interlinks for that is mega city interactions. So the second is modulus based on data. And now, based on data, let's say like air pollution or like air quality or like any interactions in society, then maybe AI could be an approach dealing with big data and artificial intelligence via learning. For example, a long short-term memory neural network can handle that situation given the spatial temporal relationship. But then a lot of problems need to be resolved in order to have reliability of the prediction and the quality of the prediction, because the window for prediction is rather limited, and it may have a conversion for a certain period, but then in a short term, again, you have a diversion. So that is a lot of contribution from all the area into that input for ensembling of the data sources and to give the correction means on the output. That is just you brought me to very vague thinking, and that is my perspective to address. But of course, we look into the future, especially large institutions. They are thinking about that.
I mean, in my presentation, I mentioned about the implication of the finding that I present. That is about the urban design, and you look at Vietnam. We have a number of many new towns, wind towns and FLC and who else. There's a lot of them. But if you look at the way they design, they're still pretty tiny, by our standard. And then, they still maintain the highly dense residents. And imagine that, Vietnam and not just in Vietnam, but Southeast Asian country, we always suffer from infectious diseases. We always, and we're going to have that in the future too. And if, with that sort of design, I think it will promote, more infections in the future. Of course, I understand why those people, they design house this way, because they can, sell a lot of houses, so they got a good economic return. But, if you have a good economic return, but you have to pay the price for ecological problems and infectious problems, I'm not sure whether that is the good return at all.
If we look at Professor Darip, the presentation, I think that is the problem of infrastructure, urban infrastructure we are mentioning, is kind of it has no stationary equilibrium. In fact, it is the dynamic equilibrium. So I think agility, and I appreciated his point of view. It's not that fail safe, but it should be safe to fail. So whatsoever, it looks like we accept the fatal rate, the mortal rate, to a limit. Of course, we need to accept that, and we move on. So it is like safe to fail. And I think more or less the Australian government adopt that, so that recently we deal with Omicron, and we deal with other kind of high number in terms of the cases and in terms of hospitalization or ICUs whatsoever. But kind of in our bottom of the heart, we kind of feel kind of exception. Oh, let it be. In a sense, I think we are talking not too much, too far, on too high or too ambitious, or in the future. May I leave that a pause for meditation, for pondering, for thinking, so that we will resume our conversation in another chance. May I draw your attention on the young, kind of the person who just fresh graduation from university, who looking at other opportunities to extend or to acquire their career in research. Can somebody from here, like Vũ, or like somebody, may I invite especially your voice in that forum. Like Vũ at Quy Nhơn, or like I'm not sure around here, a number of university the people joining this forum. May I invite the young people? May we listen to your voice?
Yeah, we love to hear from you.
Yes.
We love to hear from you about your difficulties in doing research, your difficulty in getting your paper published.
Like
anything
Vũ
that
at
you
Quy
want to
Nhơn,
discuss.
or like I'm
I'm
not
more
sure
than
around
happy,
here,
to
a
share
number
my own
of
experience,
university
although
the
I'm getting
people
old
joining
now,
this forum.
And our people, they normally have some wisdom to share. So I'm ready to do that.
We get Solomon's wisdom from Professor Tuấn. This is the
not getting old, I'm getting old.
Not me.
Yeah.
I just want to add something to Professor Tuấn about the transmission of the COVID-19 virus.
Yes.
In some city, the comparison of the different city, not only density, but also a high level of pollution, for example, like particle, then you have higher transmission of virus between within the population. So there are a lot of study on the different of the transmission of virus, depending on population density as well as the level of pollution.
Yeah, interesting idea. Yeah, I mean, it would be nice if we can measure. I'm sure you guys can measure the particle, what you call pollution, whatever way you can do that, and then we have the population density data, and then we can model them rather easily. So I guess that the issue is very much how to get the data in Vietnam about pollution in Vietnam, which is not easy as far as I know.
Yeah. And the second thing I just want to add is for publication and research, is sometimes you also depend on luck too. Sometimes a referee, you meet some your paper, encounter some very difficult referee, and they not appreciating your approach, and therefore it's very much depend on luck as well. So if your paper was rejected, maybe because it's not only your technical, but actually it's maybe something else, and because the some referee are really difficult and
prejudice. Yeah, I mean, I have a lot of experience about that, but what you said is quite true. Some referees, some reviewers, I said some, right? Not all. Some reviewers from Western countries, they seem to have a certain degree of prejudice against author from non-English speaking country. And I have evidence for that. I'm an editor, so I know. And I mean, we just have to deal with that. So if you have a paper that receive a rather unfair comments, you can actually complain to the editor. You never give up, right? You don't give up. You complain to the editor. You say, hey, sir, this guy or this girl, well, you don't know what a guy or girl, it's not fair to my paper, or they use some inappropriate language. And my members, my lab members in Vietnam, they encounter that sort of problem all the time. And I always ask them, I said, look, you write a letter to them, and then you put my name in it, and then we complain to the editor. And we normally successful, of getting the paper re-reviewed and published. So and that's something you should remember. Because I know that a lot of our people in Vietnam, once they got a bad review, they say, oh my God, maybe they don't like me, forget about them, and then you will go to other journal. Don't do that. You have to be persistent. And if you don't persistent, I mean, they say, oh, okay, all right, so look like we done the right things, and then they forget you. And the other thing, I should mention to you that, most journals are in a very difficult position to find appropriate reviewers. Very difficult. Established people, they don't want to review, paper from some unknown groups. They don't want that. So in the end, you end up with those guys who are postdoc, and sometimes they are, sometimes they're just a PhD student. And that's why, when you read the comments, sometimes the comments, you have to excuse my language. Sometimes the comments are a little bit, not intelligent or stupid, if you like. and then and me as an editor, I have to edit those comments, and sometimes I invite another person. So that is the situation that you guys, and me too, are dealing with. So when we submit a paper to a journal, and then you end up to have a junior people to review your paper. And then that junior people may have no idea about the area that you're doing. And then, it's not fair. So again, if you think it's not right, complain to the editor.
Okay, so it's okay. Now I invited Tuấn Dũng Hoàng to ask a question. We are nearly hitting 8 o'clock, so I like to be quick. Yes.
Yes, Professor. Thank you, Professor Quang Hà, for allowing me to ask one more question to Professor Tuấn Nguyễn.
Yes, sir.
For the population density and the COVID-19 disease, I would like to ask the opinion about the case of Japan. I think Japan has a very dense population, and recently they have a low COVID-19 patient number.
Yeah.
So Professor Tuấn, how do you see that situation?
Yes,
and do you think that the the Japanese people's gene has some influence factor that the results or the number of people there is getting the disease low? Do you think the genes is really matter there?
Yeah,
thank you.
I understand your questions, and Japan's is a very interesting case, and I'm sure you guys know that they have a very low, they have a very something very high, and then suddenly overnight they drop like this one, and it raises a lot of hypotheses. But go back to the story of population density and COVID case. I have seen a study from Japan. They also analyzed the relationship between population density and COVID incident in Japan, right? In Japan, because in Japan in general they have a high population density, but again, there's a huge difference between urban and rural area, and they also found a rather weak relationship between the reverse relationship between population density and COVID case. So, my point of view is that the relationship is continuous. So it's not a categorical sort of relationship, meaning that it doesn't matter whether you look at in Vietnam, in Australia, or in Japan, in any particular locality or this in countries. You always find, that relationship. It's just a matter of whether the relationship is strong or weak. Back to the hypothesis about the genetics architecture of the Japanese people that might explain, the sudden drop of the COVID case. Honestly, I work in genetics for a very long time, for 30 years, and I found that that hypothesis rather strange, and I have not seen the data that support the hypothesis. I, however, know that there is a study, a Chihuahua study, that they identify probably about 10 genes, 10 genetic polymorphism that are associated with the risk of infection. Yeah, okay, they have that study. However, when they analyze the association between those genetics markers and COVID incidence, they claim only 5%. So, in other words, genetics, yes, genetics may have something to do with the propensity of infection, but it is claimed less than 5% of the variation. So I think in the end, we're all in the same boat, whether you're in Japan or Australia or Vietnam, we're all in the same boat, if you are in the high density area, high risk.
Same boat.
Okay, so thanks. I think the problem is too difficult to answer right now in one go. May I invite Lu Ha from UET VNU to ask quickly? Okay.
Okay. Thank you. Can you hear me? Okay.
Yes.
I have a short question for Professor Tuấn. I'm Lu Ha from Vietnam University, Hanoi. I'm an assistant professor here, and I know you may know a lot about the problem with the young register in Vietnam. We have problem with infrastructure. We have problem with policy. We have problem with funding. But it's not easy to solve. But one problem I think we can solve, we may discuss, is we know about the paper milk problem. That is ethic problem in publication. Like some young researcher, they just sell the paper to some university in Vietnam. I don't name the university here. But the university do not involved in the research, and they just pay and buy the name of affiliation there. So you think?
So can you go back to the question? What is your question?
Yeah, the question is that do you think that it could have the science, the development in Vietnam or not?
Well, I think if you look from a national level, then the output from Vietnam research has increased very significantly over the years, right? From a national level. So in a national level, I don't care where it's come from, whether it's from VNU or Ho Chi Minh or Hanoi, I don't care, as long as I see that Vietnam. If you look in that front, look like the propensity, for increasing output is there. So it's a good trend. The not very good trend is this: about 70% of those output were dependent on overseas investigators. In other words, 2/3 or more than 2/3 of the publication from Vietnam was actually not led by Vietnamese authors, but by overseas authors. So that is the major issue. And that way the issue of, research capacity building. And that is something that people like me, I'm very passionate about. I try to build, research capacity for Vietnam. And that's why we do a lot of workshops on methodology, scientific writing, and all those things. But if you go down, to the level of institution level, then there's the issue of affiliation, right? The affiliation.
Yeah.
So people like me, but it's not just happening in Vietnam, by the way. It's also in Australia. So people like me, I have affiliation in UTS and UNSW and Notre Dame. So when my papers, actually my paper was done in another institution, but 3 institutions got the credit for it, right? And then, but they don't pay me. They don't pay me at all. They only give me the title. They give me the title of professor, look fancy, right? They give it a title, but
it was.
Constitution manual. I mean, that's not fair. But it's happening. But in Vietnam, it's another issue. In Vietnam, there are some institutions, they some people, some institutions they pay, to got the name in the paper. But some institutions they support the research so that they got their name in the paper. For example, I have a lab in Tôn Đức Thắng University, right? I have a lab there, and my colleagues running the lab, and so the university, everything come from every paper come from that lab. Of course, must have a Tôn Đức Thắng University name on it.
Yeah, sure.
But thank you for that. I just want to make sure that the issue is a burning issue in Vietnam, and we look at that, and that's why this kind of workshop are there to train or to give some right way or some dignity to for researchers around to uphold. Talking about the negative side is probably not so encouraging too much. I would like to invite Vũ Bùi. Last question. He is a young lecturer looking with good faith, bright future ahead, and we like to do the right thing. Yeah, Vũ, go.
Thank you, Professor Ha. Hello, everyone, and Professor Tung. I have a question for you. Actually, yes. I'm really interested in your presentation of how to publish the paper in a journal with high impact factor. And I wonder if I have your file of presentation after the workshop. And the second thing is that can you share some experience relating to what a beginner needs to prepare in order to write a good paper? Thank you.
Normally, I advise to my students and junior member of my lab before, writing a paper, you should take a coffee, you're in a coffee shop, and then you sketch out what I call it micro paper. A micro paper has only one page. You jot down, you say, what is the big issue now? What's the big issue? And why it's important? And then, where I come from. So what can I solve? So you create your list, and then you end. And then next, you sketch out the number of tables and graphs or figures that you want to have in the paper. And then you go down to discussion. You say, what do these things mean? And once you have that micro paper, it really set your mind, when you sit down and write your paper. And of course, when you finish writing your paper, you should also give to other people to have a read critically. In the old days, I normally give my draft to people who did not like me to read. Because if you give a draft to the people who like you, they always say how wonderful you are. But you should give to someone who didn't like you, right? and because they would try to find every single error from your paper, and by that you learn from them and you correct them, and then you got a good manuscript ready for publication, for submission.
Okay, and thanks Professor Tung. And to answer on the slides will be found by the website, or if not, then you can email Dr. Hiệp Định for the PDF of that. Okay. Now I think we over time. I apologize for the time being. For some unexpected things. But I would ask your patience in order to stay with me for the closing of this workshop. Sustainability for resilience and resilience for sustainability. We have discussed, I think, the whole day for that nearly. Okay. The morning wow, Professor Trinh from VNU, and the discussion, the chat, and the entertainment, rather very inspiring. Statistic, we have 76 participants from the many university and organization from Vietnam, Australia, India, Japan, UK, US, even from hospital and clinics. I guess some medical experts are there. Forgive me if I'm missing something, but especially this time we have also social media to participate here with Facebook of Professor Tuân, Professor Đức, group website, etc. Okay. Yes, and we have discussed on energy, medicine. Probably I don't have to spend, but I think all of this presentation on one side is very in-depth. On the other side, although it is, let's say, no kind of citation, but you can track down and to find there is a lot of works behind the presentation that is here made it in a condensed way. Okay. Succinct infrastructure and also environment and health. Not to mention that the COVID is still endless. Not to mention that the topic Professor Trung presented, communication for inspection and emergency, is also rather endless. And he ended by, you see that nowadays you will see that friction on, well, you see that flying cars will be delivering your pizza. Now, very interesting that we have interference between the science and music. In one way is to raise the awareness. We have a science and media this time. The impact, you can see that I'm ordered from Professor Tuân last night, and just not that one day we up to that the 836, I think more than that, to like and to share over 60, etc.
Drop out.
Drop out.
Drop out. Cannot hear you.
Maybe the internet connection.
And believe me, okay, don't translate it properly. What is the theme of our workshop? Sustain. Okay, back to work. You listen to me?
Yes.
Okay, so I share again. Okay, so I continue. The comment from Professor Tuân's Facebook. He decided he doesn't know how to translate that. And one comment that tried to translate, I probably not so agree with the translation. My translation, sinh tồn để vững chãi để sinh tồn. Somehow sustainability kind of, to me, maybe I'm wrong, but to me it's kind of it needs to be renewable. It needs to be development in the sense that it sustains something, develop something, and resilience. I like to translate it as a vững chãi. You fail safe, but you also safe to fail, and you robust. You also kind of redundant in order to be safe for fail. Okay, I just of course I invite you thinking, meditation, and pondering on the topic some more. Okay, in addressing the PhD student, young researcher, we talk about Pavlov's request makers, about Darwinism, about high impact publications. I think a lot of tips we can learn from Professor Tuấn, and that we will invite you to address us in the next event. Professor Tuấn, I order you.
Thank you.
But right here, we can see a lot of bright figures. Even the keynote, Professor Trung, he's young. So we believe in the next generation. Yeah, we entirely trust in your talent, your competence, your in charge of the situation in the future. And we want to see that the future is yours, not us, the old here, sitting here. I'm sorry, I grouped myself into the old. Yeah. Okay. So the message is that take care of the Mother Earth. And for this, I like to introduce the next workshop. So I have got confirmation from the Quy Nhơn University, the Chancellor, the Vice Chancellor, sorry, I first said the Rector, the Vice Rector, all very supportive to our workshop to be held in Quy Nhơn. So I guess if nothing happening to interfere much, then we expect to see each other again in one more year time, January 2023 in Quy Nhơn. Yeah, and I invite the Vice Rector, Professor Tùng. Dr. Tùng, yes, you are here. Can you say some brief word? Yeah.
Hello everyone. My name is Dr. Tùng from Quy Nhơn University. And we are very pleased to welcome you all to the next workshop at the Quy Nhơn University in January 2023.
Okay, so I think for this, I would say bye for now, and we thank you very much. Thanks every talented, renowned keynote speakers. Thanks for all the plenary presenters. Thanks for the generous support from VNU, UET. And if I myself made some silly mistake in order to push you or to try to run to catch up on time or whatever, then when I beg your pardon, and I look forward to seeing you in Quy Nhơn 1 more year. Okay, thank you.
Thank you very much.
Good afternoon and good night, everyone. Okay, thank you.
Thank you very much.
Thank you.
Bye-bye.
Professor Quang Ha,
Professor
Quang Ha, how can we keep in touch for the next conference?
You will keep in mind that you connect to Dr. Hiệp Định, who have on the email contact, and then we will stay in touch.
To whom, please, sir?
Yeah.
To whom should we contact with, Professor Quang Ha?
Yes, or Dr. Hiệp Định. Đinh Trần Hiệp. Trần Hiệp Định. Sorry.
Professor Tung, right? I will just type my email address here. So maybe I'll add you to the mailing list.
Okay.
Yes, please. Yes, please.
Okay, and bye for now.
Thank you. Bye-bye.
Bye from Australia. Goodbye.
Bye.